Hello and welcome. Let's get that chat in place, shall we? Hello everybody. How are you doing? Sorry if that was shocking. We are going to unmute into a group of friends in the Discord, which you can be a part of. Just join and we will be off to the races. Hello everybody, we're live. Welcome.
Oh,
We did it.
nice.
We have the lovely local
Hi.
and the awesome eternal.
Hello.
So it says just join and spam the voice channel. If you want a quick ban, that'd be great. I'm quick at dishing those out. Yeah, let's just get started. Don't we have something to look at for intercept, do we not?
We do, I think. Are you gonna share your screen again, or?
Yeah, I should probably do that in the Discord now. Cause it ended that way. That way. That way. Cool. Blippity blop.
Let's see. There we go.
Beautiful stuff. Beautiful stuff. First time chat from Peter or something. Unban with Lamau. What's up, Indecent Labs? I only know Tactics 26, Zarias. Welcome everybody. Rotbjorn. Crazy. I was crazy once. Lamau.
They locked me in a room. A rubber room with rats. Rats make me crazy. Crazy. I was crazy once.
There we go. Fix up our little chat. Okay, yeah, we have a poll request. We have two actually, but one big one.
We have two.
Woo! That's a spicy one.
Yeah, it kind of got a bit out of control.
Oh boy.
The addiction was strong with this one. That's a spicy 8K grind. That's right.
Yeah.
Peter says, I mean, you were talking with a world record holder of getting banned on your Discord. Lamau. Also, I can't believe how many follows there were while I was not live. Evil Aliens, or Alliance. Sirius Louvre, Peter 1, hey, it's you. Zyguy, One Hunga, Kaleote62, and Bopus. Thank you so much for the follows. I like Bopus. That's a good name. Every Sir AIDS one is big.
Files changed. It's only 81.
Only 81. Ay, caramba.
Yeah. I haven't touched the git ignore, it would seem. Yeah.
There's just a little bit going on.
Yeah.
It's taking GitHub time to load it. There we go. So yeah, there's about 30 tests.
One is just to test the testing framework. That's the last one. Test with spaces and name. That checks that our testing framework handles spaces and file names properly. Because that was a problem. Fun fact, in Visual Studio, which I had to use in my Windows VM, if you try to get to set a path with or any command line argument that contains spaces, there's a few problems. Visual Studio doesn't handle that correctly in some cases if you try to set that as the command line argument for something. So yeah, not only have Microsoft created a problem, because on Windows, the create process function takes a single string instead of a list of arguments. So the kernel has to pass the thing anyway. So not only have they created a problem for themselves there, but they also are incapable of fixing that problem they created in Visual Studio, because Visual Studio has problems because of that, where it doesn't handle command line arguments properly and
It's a
splits
kernel
them
issue.
multiple. Yeah, it's I don't know where it's either wherever that Windows API function is handled, wherever they split that into. If they split it at all, I have no idea. So yeah, wherever that's handled, there's a problem. Well, no, that part is probably fine, but Visual Studio is a bug, which is not terribly surprising. Let's be honest.
Yeah. Indecent Lab says good English by L. Xylan says hello. Nexavec says hello. You're still doing the compiler. That's unbelievable. I know, right? Where are we at? What is this PR about? What did it start as?
It started well, you can tell from the title, I was going to implement inlining, and if you're implementing inlining, you're also going to implement store forwarding, otherwise the inline code looks horrible. So let's go through that line by line. Inlining, I don't think I have to explain. You take all the code in I will explain how it works when we get to the code, because that's interesting. But from let's go through this first. So from a high level point of view, you take all the code from one function and copy it into another function. And that way you can optimize that function a bit better. At the very least, you get rid of the call. So that's inlining. Related to that is the next point, which is I've called it store forwarding. I think that term is more common when you talk about CPUs. There's a bunch of other names for it. But basically, this means if you store a value to a variable and then you use that variable, well, instead of just loading from it, you can just use the last stored value. Because we know what that is.
Because you just assigned to it, so it must be that value when
Yes.
you load from it.
This also handles things like, what if we have two consecutive loads with no store in between? Well, the second load can be eliminated. What if we have two stores with no loads in between? The first store can be eliminated. Of course, you have to handle edge cases, such as if the the address of a local is passed to a function, then that function may be modified, or something else in the program may, because that address now counts as escaped, so you can't forward stores across calls, typically, unless the call is like a const function or something. So we have to make sure that we take care of such edge cases, but this eliminates a lot of pointless stores and loads that look pretty horrible otherwise. It's not exactly a mem to register pass, but it helps like eliminate a lot of the horrible code that gets generated.
So to help illustrate that just a tiny bit, if we had like A is assigned to B, or let's say like 42.
Yes.
And then we'll do type inference or whatever. So if we had like A assigned to 42, and then we say B is assigned to A, and then this is when we had like return B plus 27 or something random, right?
So what? Yeah,
And
go ahead.
the store forwarding would effectively, I know this isn't how it works because it works on the level of the IR versus actual statements, but just to represent it, if we have A as 42 and B assigned to A, then in this statement right here, instead of loading the memory of B, then we could just use the value of A here. Or if we do like a chained store forward, then we could figure out like replace this use of A with just 42 and then replace B with its actual definition, which would then actually just be the number 42. And then after we have 42 plus 27, we can do binary operation optimization to just do it at compile time. And then this whole thing would just return 69. Is that right?
Yes, that's how it works, except on IR, obviously, as you mentioned. But yes, that is how it works.
Awesome. Hopefully that helps. That's what he means when he says store forwarding. It sounds fancy. Function inlining, it's very much like what it sounds like. Instead of a function call, you just literally copy the code into where the function call would be. Pretty much.
A few people are complaining about buffering in chat. You had some problems just now earlier when we were in VC, so
yeah, it could be something going on there. Indecision Labs says Twitch moment. I do think it's a Twitch moment because I was like able to load a YouTube video earlier, even when it was all roboty on Discord. My bitrate is fine too. It's stable. So I don't know. Hopefully it resolves itself. I only know Taxis says it's good for me. It could be a CDN issue.
Huh. That's true. Anyway.
Zarya said, maybe in 10 years when we are done in the compiler, the next project is making a bot from scratch.
I don't think a compiler is ever done, but okay.
Yeah, I've started something that will outlive me. I've understood that now. This beast has grown.
Scrolling way too fast. We're
just,
not done with that first section. You just scroll past everything. Good God. Also, someone joined BC, I see. Or I hear, rather.
Oh, I accidentally opened Steam. Legendary. Just trying to open Discord. Hey, we got
The wrong
Lumi.
browser. That's the wrong browser lens.
Okay, so we have function inlining, we have store forwarding.
This is like, I'm not even sure why this is a separate point, because that's just part of the inst combine pass. But basically, if the argument of an indirect call is like a function reference or something, or a bit cast of a function reference, then we can just inline it and make it a direct call instead.
If it's compile time known.
Yes.
So if you take a function pointer to some free function foo, it's like if you have foo, which is going to be like some integer returning function, which returns 69. Then you could have like bar, which is a pointer. Is this how we do this? No, that. And then
Yes.
that's somehow, I think, what we would do. So a pointer to
That is
this
a function
type.
pointer declaration, yes.
And that could be equal to the address of foo.
Yeah, I'm not even sure you need to take the address. I don't think you do, but
We
sure.
probably don't need to, you're right. And then, so we have foo assigned to this function pointer. Then we can just call bar in the language. And if it's a function pointer, it'll automatically like dereference it. And if it's not, it'll not do that, right? So what this does is like, this would be an indirect call because it would actually load the value at bar and then just call that as a function. Whereas a direct call would be if we just insert the address or the symbol foo, and we literally just call that directly, the function itself.
And obviously direct calls are better because you can inline them and so on. That's why.
Yeah, and exactly. It allows for many more optimizations if you don't have this extra dereference in here.
And you can see how in combination with the store forwarding pass, this would get inlined and then it checks, okay, this is actually just an address to a function, so we can just call that directly.
Which also really easily allows for efficiently like renaming functions locally if you want to shadow them with a local definition. Not that you should do that, but
to anything, but
like if you're in some scope and you want to be like, actually, bar, I want to call an integer bar. So now I'm gonna need like some other thing to call bar. Doesn't that make sense? Am I crazy?
I have no idea what you're talking about, but it probably makes sense.
I was crazy once.
Locals
If you're
back.
asking whether lambdas can be efficiently inline with this, yes, they can.
Yeah, that's sort of what I was getting to. Yeah. You get it.
Apparently the @ sign is sus now.
Interesting. But yeah, so this converts the call to bar to just, we already know at compile time it'll be equal to foo, so we can just do that with store forwarding, and then with store forwarding, we now realize this is a direct call, so everything gets happy. Okay, we're making it through these fast. This is good.
That's just
Obvious.
self-explanatory.
Yep. Remove
That
unused
too.
global variables. The function
I'm
analysis
not sure why
pass.
the downarts funarc thing is here, because that comment should be on the direct to indirect calls thing.
So the function analysis pass now removes functions if they are never referenced. This may not be exhaustive, but it's enough to fully inline the downwards funarc test.
Yeah,
That's
that
right.
comment doesn't make sense. This thing about inlining downwards funarc should be on the indirect calls to direct calls thing, because that's what that does.
Yeah, that makes more sense.
Yeah, it's weird that's here. But yes, we also delete functions if they're unused and not exported.
PogChamp. At was the imposter.
The simplify control flow graph pass has been a bit rewritten, and this now combines blocks when possible. So if you have a block that has one successor, and that successor has only that first block as its predecessor, you can just merge them. And that also means that the fact that we only do store forwarding locally, meaning within the basic block, is less of a problem, because now basic blocks that are trivially connected just get concatenated. So we get more store forwarding that way anyway. So we don't need store forwarding across blocks, really.
And better cache locality if there's no branches.
Yeah. Because for like global store forwarding, we're going to use a proper mem to reg pass at some point, and that will do that, but so store forwarding only needs to operate locally. And just in case anyone is confused about the terminology, if we're talking about local and global in the context of an IR, typically global means across an entire function and local means in a basic block.
It's like one level down from C.
Yeah, sort of, because especially if we're talking about like global register allocation, that doesn't mean for the entire program, that means for one function.
Yep.
In its entirety.
That makes sense. That makes
Because
sense.
you hear that a lot. Global instruction selection, global register allocation, whatever. Inst combine is just, that's what LVM calls, and that's the best name for it, honestly, because it's not just constant folding. It's also the thing, I'm pretty sure the thing that converts direct calls to indirect calls to direct calls is also in there, and it just does a bunch of simple transformations. So this is the paths were all like simple transformations that don't deserve their own pass go, basically.
Yeah, so if you just take like 2 instructions and then convert it into one, it's not like it doesn't require some complex function. And if you had to do that like if you had to loop over all of the instructions 8 times to do them, then it'd be inefficient.
That would suck, yes.
Indecent Labs says, okay, my bedtime is coming. Have a good stream. Good night, Indecent Labs. Thank you so much. We're going to go over your PR after this one, if it's not already merged in this one.
Okay, so this is like surprisingly, this PR has very few new language features. It's just a bunch of attributes and built-in. So I have an inline attribute that's not inline, it's always inline. So if it can't be inline, it's an error.
It is an error. Okay, so... And what are some cases where you can't inline something?
Mutually recursive functions. Those you
Right.
can't inline.
So if you
At
have
least
like...
you can inline them once, but not completely. If we're foo and it calls bar and bar calls foo and both are marked inline, then that's not going to work.
Something... I'm overthinking
It doesn't
this.
have to be, just have it call bar. It doesn't need to be complicated.
Okay. I was like, I don't need to make this actually work. So if this called foo...
Yeah.
Then
And if both
obviously...
are marked inline, then that's not going to work.
Yeah. And if you're writing code like this, you already know it's
Yeah.
you shouldn't be inlining these.
Inline
Or you should
is
only
real
inline...
things that this is guaranteed to be inline, basically. That's the idea.
Yep. Okay, that's very good.
And it's stronger than always inline because even always inline is allowed to fail. And the only case in which this is allowed to fail is tail recursive calls. If you can't inline it, but if it's tail recursive, then that's fine. Because tail recursion is better than inlining anyway, because it's a jump backup. It's basically the same thing.
Yeah, it reduces code duplication.
We've decided that tail recursion is okay. If we can't inline it, but if it's tail recursive, then that's fine. But that's it.
Why did we go from type varname to varname type syntax? We as humans? Like, because C started with type first?
There's two answers to this question. One is with
Or like
respect to
intercept.
intercept, in which case it's Lens just decided that it was going to be that way, and that's it.
Well, it was never like type varname in intercept.
Yeah, it always was var name type and intercept. And the reason is that that syntax, I don't like it either, but objectively speaking, it's better because it's easy to pass, because it's unambiguous that the thing after the colon is a type. That makes things easier, especially if you have odd independent types.
And easier to parse isn't just like a technical detail. That's what your brain does when you look at code. It parses it.
Yes, I've never found varname varname harder to read than varname type. I don't, but I don't. In terms of legibility, they're the same to me, but I do prefer having the type first, either because of experience and because it looks nicer that way, and I'm used to it. So I don't like the varname type syntax subjectively, but objectively, it's simply a matter of fact that it's the better syntax in terms of it's easier to pass.
And
I'm in the same boat.
the only reason it came about was because I like the colon equals as the assignment operator and distinguishing it that way from the equals operator instead of having equals equals, because that just seems ridiculous to me.
Yeah, and this thing with
And then just putting the
so
type in the middle made it work.
Hold on. We're going too fast. No inline is the opposite. You can't inline it, except you can override that with built-in inline, which we'll get to.
Yeah,
So
don't worry
that's
about what that
still
is.
and everything. So no opt is just an internal thing for testing. So that way it prevents the function from being optimized when optimizations are turned on. Maybe we'll remove the underscores and expose that at some point under some name, but I didn't feel like making it a language feature. It's just there for testing the optimizer.
Yep, pretty much. So you can write a test program and actually control, like, this code won't get touched.
Yeah.
For me, the
We
problem...
might make that a proper attribute without the underscores at some point, but currently it's just like this.
Peter says, for me, the problem with making a compiler is just C, C++ syntax is so good that I would just have to make a C compiler. Hold on.
Naturally, yes, that's the logical conclusion. Have you ever seen a function pointer, a pointer to a function returning a function? It's glorious.
Oh, no. Like, this is what C looks like. Look at this.
This is
This is good C.
This is good C.
What about this is nice that you want to
Readable,
keep?
isn't it? You have to use. See, this is the genius thing. You use a completely different language so that you can share no features whatsoever to write macros. So you can make the language that is horrible to use a bit less horrible by introducing a thing called generics that every language after 1980 that's somewhat decent has.
Yeah.
But yeah.
Like, this is good C right here. This is fantastic C. This is not...
As much as I like C, it's not good.
It's bad. And I agree that the type first and then the name can make it easier based on, like, where the context that your brain's within. But my whole deal with that is, like, while the type name does give you more context about what the name will mean,
Yeah.
in your own, like,
Okay.
these names are for the programmer. They don't exist for anyone but the programmer, and they made the names, so they'll know the names better than the types.
If you want to showcase the true breadth of what Cursed C can look like, you shouldn't be looking at this. You should be looking at my branch where I have some very nice new macros.
That's
You should be
true.
looking
There
at
is
the
some,
inline
but
branch.
that's not C. That's
No,
C with compiler extensions.
generic isn't the compiler extension.
Oh, you're talking about the generic one. I thought you were talking about the statement
Yeah,
expressions.
the statement expressions are bad enough, but generic. I'm talking about the what is very, very much standard C in IR.h. Not
Intermediate.
IR.h. It's not in CodeGen.
What have you
No,
done?
intermediate representation has been deleted. It's been moved. IR is now in a subfolder. There we go. IR.h. I've also called it IR.h because the name was too long.
It wasn't too long. I'll probably rename that, but it's okay.
So
Or at
we
least
could
name the
scroll
folder
down.
that.
Yeah, and scroll down a bit. Further down, further.
Oh,
Oh,
dear.
yeah, it looks horrible here because the lines are too long, so it's line wrapping. Can you collapse this damn thing on the left, maybe? Then again, this isn't
No.
even the section that I want to talk about. There we go. That's better. It's better already, I think. So if you scroll down a bit, or up, I guess, I don't know, somewhere else. Oh yeah, there we go. These are very nice. So this is how you
Yeah.
this is defining getters and setters because we need those now because IR is a very complicated data structure and there's too many invariants to keep track of manually.
Yeah.
Use marking. We'll get to use marking, but just like as a quick showcase, this is not even that bad. If you scroll down a bit, it gets worse. Like if you scroll down a bit to like IR ID or something. There
Oh,
we go. That's a
dear.
nice one. Yeah.
Generic with a generic.
This is how you do function overloading in C, by the way. This is an overload function that delegates to 4 other functions. At what point do you switch to C++? Is someone asking in chat. I've been asking Lens that for a while now. This would be so much easier if we were just using C++. I wouldn't have to do any of this cursed nonsense. I could just use a template, a language feature that
You
actually
just start
works.
doing other cursed nonsense.
Exactly.
Well, generic is horrible because every sub-expression of a generic selection has to
We
be a
don't-
valid expression.
We've got to train. We got to catch the
That's
train.
not true for templates.
Used.
Anyway, used is just there, which if you want to prevent the function from being deleted when it would otherwise be deleted, it's there.
Make sure to drink water, everybody. So that makes a lot of sense. So with this pass that you added up above, where you delete
Yeah.
functions that aren't referenced, it now may be important to keep that code around for some cursed reasons. So
Yeah, for instance, if you want to actually look at what the optimized IR for that function looks like, but the optimizer has inlined every use of it and deleted it.
The way Discord did the audio, or like you might have leaned away from your microphone, it sounded like
Yes,
you like were circling my head when you were saying that. So I just pictured you like walking in circles around me.
no, I was turning around to grab my water bottle.
Nice. Hydro homies.
Anyway, next one is pure and const. I'm not going to go too much into those, but those are basically optimization hints that you're not really supposed to use manually. You can, but if you use them incorrectly, it's going to lead to incorrect code gen. So this is basically just used by the optimizer to make sure that to tell it that, okay, this function is, for instance, two calls to this function will always return the same value or something like that.
And
The
here's the
exact
thing.
semantics are detailed here, but it's not that important to know about that.
This will all be done automatically, so you don't even need these in every case that it would matter.
Yes, the only time where you would use them manually is in a module, maybe. If you export a function, you can mark it as const. That way, if another module imports that function, it
It
doesn't
will
see the
know.
definition, but if it knows it's const, it can like do common sub-expression elimination and stuff like that.
Exactly. So
And
for
you have to be
APIs
careful.
and libraries.
Yeah, because if you have to be careful, if you misuse those, I mentioned this earlier in the store forwarding pass, where it won't forward stores across calls because the call might modify the variable. Well, if you mark a function as const, that function is not allowed to do that anymore. So you can forward stores across const functions. But now if you do mark a function as const, but it does modify memory, and the optimizer thinks it doesn't, then you might get incorrect code gen. So if you use these incorrectly, you will get incorrect code. And that's why you're not really supposed to use them manually unless you know what you're doing. And that's why I'm also not really going into that much detail here. Like all the what it means exactly is described here, but it's not that important.
Yeah.
But most people won't need these. Like they exist in a similar fashion in GCC. GCC also has attribute pure and const. They mean slightly different things, at least const. But very few people ever have to use those manually.
Yep. Ooh, Next Vivek says this changelog is insane. You've done a lot of work, guys. This is all eternal. I haven't done anything on this PR. It's incredible.
Someone's asking, does intercept infer a function is pure not from its body? Yes. If it has access to the function body, it does.
Also, I only know Taxic said, at what point do you switch to C++? Responded with, when you want dynamic arrays. That was long ago. We wrote our own dynamic arrays in C. At least Eternal did. And then it's grown from there.
We have a vector implementation for that because it was too goddamn ubiquitous.
And then a
No return.
philosophy. There's a philosophy question first.
Oh no.
What is the difference between a library and an API?
Oh yeah, that's what I'd like to know from too many API designers. So basically, the API is supposed to be the public interface of the library that people are allowed to use. So that interface typically it has to satisfy a set of conditions. For instance, it should be stable. You shouldn't be changing your interface too much. Like it's fine to change the internals of a library however much you want, because people shouldn't be depending on that. Shouldn't be depending on that in the first place. But if you suddenly change the API, that typically requires a at least minor or sometimes major version change if you're using Semver, at least. So the API is the interface that other people can use to use the library, and the library itself is the entire thing with the internals and everything.
That's right. And I think in the case when I was speaking, I said library first and then realized that API better described it. So I said
Yeah.
library or API.
Yeah, API, for the people who don't know, it stands for Application Programming Interface.
There we go. Yeah, you were saying no return. Sorry to cut you
No
off.
return was already a thing, at least internally. I'm not sure whether it was exposed. It is now. It indicates that a function does not return. That's used for things like exit or long jump.
Very
And this is
rarely
all.
needed.
This is checked by some, or it should be at some point. It is also inferred by the optimizer. So the optimizer infers all of these except obviously things like inline, no inline, and no opt.
Yep.
But pure const no return, and also a few other internal ones like leaf are inferred by the optimizer. So even if you specify pure, if the optimizer has access to the function body, it doesn't care. It just recalculates that. So specifying pure constant no return manually only really makes sense even if you, I mean, pure and const definitely only makes sense if you don't have access to the function body. If you have the function body, don't even bother specifying those. The compiler can figure that out way better than you probably.
Yep. Fantastic. And then we now have something called intrinsics. What are
Yeah.
intrinsics?
Intrinsic functions are functions that are intrinsic or internal to the compiler, which means they aren't actual functions. They look like functions because that's the simplest way of a function is a very flexible expression, if you will. You can pass in any amount of expressions. It's syntactically the parentheses delimit exactly where it starts, where it ends. So it's a very flexible API for just passing data to the compiler and telling it to, hey, do this with it. And intrinsics look like function calls syntactically, but they are implemented in the compiler, which means they aren't actual function calls most of the time, but rather the compiler at some point generates code for them, depending on what you pass in. For instance, built-in debug trap here is lowered to an instruction that calls into the debugger. So on x86-64, that's int3, or LVM debug trap if you're using the LVM backend, which also is then lowered to int3. Then we have built-in line and file. You will know those from C probably. It gets the current line and the current file. This is where this is called in.
And these
Then
are
we use
macros in C, usually defined as
in,
macros.
well, they're sort of macros. They really are. Well, yes, that's true. But GCC at least also has built-in line like that.
Yes,
They
it
can call
does.
you can call that too. But yes, and built-in inline takes one argument, which has to be a call expression, and it will inline that call. And it doesn't care if that call is marked no inline; it will also inline it. And if you're specifying this manually already, then it only makes sense for it to be an error, to make it an error if it fails, because you want it to be inlined every time.
And if you,
That way
so
you
it would
know.
error on like an imported function, right?
Yes, for instance.
Okay. Oh, this is a good
Uh,
one.
Built-in memcopy is, I think, self-explanatory. This is just memcopy, which is currently always unrolled. Eventually, if it gets too large, it should be lowered to a call to either libc's memcopy or a runtime memcopy in our runtime once we have one. But that functionality already exists in the compiler internally. And also the IR exposes an API function for creating a mem copy now because
Yeah.
that's needed in some cases. So we might as well expose that to the front end as well if we already have it.
Perfect.
Yeah, but
Perfect.
this built-in mem copy was added in the backend first and then just exposed, basically. And that's all the new language features actually, because
Which is not too
um
much. I mean, it's
yeah,
a ton, but it's just
it,
all,
yeah,
it's all behind the scenes.
yeah.
Beautiful. I feel like
The
it's like a
next
bow on
section is
top.
the next section is the big one.
Uh,
We're gonna go
Oh
through
no.
most of this. Most of this isn't particularly interesting, but let's see. We now automatically insert a new block when trying to insert an instruction at the current insert point. So this is all internal stuff mostly. Previously, IR insert would error if you try to insert a new block, and because of that, every time we're inserting a branch, we take care to insert a new block which was cursed. That led to us inserting extra blocks after return instructions, which then would cause the code that emits functions to see that the block isn't closed and emit a second return and stuff like that. It was horrid. The better approach is to just create a new block every time we need one automatically.
uh, I can't believe the compiler worked.
Yeah. So that's that point. We now have a proper representation of linkage. If you're interested, you can click on that link. That's the commit implementing that. It has a nice long message that explains everything. We're not going to go through all of that, but basically, we have a proper way of referencing where a symbol is defined and how to deal with it. And that's for both variables, so static or global variables, as well as functions.
And if you're super curious and have no idea what this is about, then you can look up like object
Yes.
file symbol. That'll probably get you very far.
It's
then-
sort of like that, yes. Also, even just the concept of linkage in general, because that's also a thing in C and in LLVM, for instance. This is more modeled after LLVM, obviously, which has a much more precise definition of linkage. But yes.
Yes.
And Piotr in chat is asking, what's the example use case of no inline? There is it's rare. It's when you have mostly like cold code often that's not really called that often, and you don't want to inline it just because it's rarely ever called for stuff like that. For instance, there are cases where you just don't want to inline something because it's not used commonly or because it just makes the function too big. Like there are cases where that can improve performance by just keeping everything small in the cache.
Yep.
But I'd say the use for no inline, it's rare. But there are uses of it for both inline, both inline and no inline in the sense of force it to inline it and never inline this. They're not too common that you have to use these. It's not too common. There's some cases where the compiler can't tell that it's a good idea to inline or not inline something, so you kind of have to help it along. But a lot of the time, you just want the compiler to figure out whether it's a good idea or not to inline it. So these are not that common either, but they're definitely more common than something like pure or const.
In most cases, it's never going to be used, but if someone wants to optimize something, they'll be necessary.
Yeah. Like all of these things, except for some of the intrinsics and except for no return, I suppose, are really more for optimization.
Yep. Beautiful, beautiful. Okay. IR free function.
You just delete an entire, yeah, we can now just delete an entire function.
Beautiful.
I'm not sure if it's even called that. I think it's called delete function now because this was before the big refactor. But anyway, each use of a static variable now generates a separate static reference, which it's better that way because we were running into problems with what if a function tries to use a static reference that's inserted in a different function and stuff like that. So because of that, we were inserting references to all globals at the beginning of every function. That was just a stupid thing to do. So now we're not doing that anymore.
Yeah, so this reduces it to only having the static references that are actually used.
Yeah, every time you use a static variable, it uses a new static reference. That's how simple it is.
Which is kind of like exactly how immediates work.
Yes, pretty much.
So it's an inlineable operand. Cool, cool.
Sort of, yeah. Improved handling of intrinsics, and we now have backend versus front-end intrinsics. That's an internal thing. So, for instance, some intrinsics like line and file can be handled by the front end, and we don't need cogent support for it. But something like built-in, there's also built-in syscall, for instance, which was added by an earlier PR that needs to be handled in the backend, or in this case, built-in debug trap. Like that is a very backend specific operation that can only be handled when you're doing cogent.
Yep.
That's handled specifically in manual instruction selection right now.
Which makes sense.
What? I accidentally. Hold on. There we go. So yeah, we now have separate function and variable attributes, and the same thing basically goes for attributes. We have front-end only attributes, and most of the attributes are shared though, and now they're automatically propagated from front-end functions to IR functions.
Beautiful. Instead of just reaching into the front end to know that.
Yeah.
Because before we would just like, oh, go to the IR node that this was generated from, and then go to that data. But now we're actually passing it through.
And well, I haven't changed the machine IR if you're talking about that, but the IR.
No, the IR itself, yeah.
And it's also automatic using macros. If you add an attribute, then it just gets added automatically to everything that needs it, including the code passing it and so on. Yeah, that's that. We now compute that is actually false. It's no longer during dominated reconstruction, but there is a separate pass for computing predecessors because we need that in the simplify CFG pass. But it's not during dominated reconstruction because that was before I refactored that.
Oh, and the IR. I was like, I swear I remember just writing the code that does this, but I did it for the MIR.
Yeah, pretty sure you did it for MIR.
For RA, yeah.
Okay. An unknown opcode in the ISL table is now an error. It used to be a warning, probably because you were testing stuff when you implemented that. It's now an error.
Oh, yeah. Yeah. So the deal with that is that I was gonna have it where like I was overcomplicating it. Yeah. I was gonna have it where like the backend was gonna be a loadable dynamic library, and then it would like it could just be fed any opcodes, and then at the top of the instruction selection file, you would actually
Yeah.
assign the values to each name, like you define your variables, your opcodes.
So that would be one way of doing it, but currently we aren't doing that, and this confused me for a bit because I got a warning when I added a syscall node or something like that. Or reachable, I think is what I added, something like that. So it's now an error.
Beautiful.
Okay,
Beautiful.
IR remove. So this is funny because this was before the refactor. This is now not a problem anymore with IR remove because this was referring to the fact that it was a list before. Now it's a vector, so that's less of a problem now.
Beautiful.
Some functions that used to take a span now take a string because that way you can
Yeah.
just pass in a string without passing in a span and then having the function copied again. So
And it also makes it explicit to the caller that this is going to be like a new allocation because you have
yeah,
to make a string.
I haven't changed it for like the AST or something, but just for the IR currently. Helper to checks if a function is a definition because we know how no longer have an is extern flag, and with linkage it's a bit more complicated because there's multiple types of linkage that correspond to external and internal functions. So now you can check with that. If that returns true, that function has a body, otherwise it doesn't.
I'm kind of getting confused on the name here.
It checks if the function is a definition as opposed to a declaration. That's the idea here.
Oh, okay.
Definition has a body, declaration does not.
Yeah, so it's like header versus implementation.
Sort of, yes.
That's what I'm getting. So,
Mhm.
okay. So it's saying this IR function that we have, is it the definition of this function that it's describing?
Yes.
Okay, I'm getting it now.
Names of generic machine learning instructions now start with m dot because it was currently complaining about an unload call instruction
Oh, yeah.
right next to an XA664 move instruction that I got really confused. But what it meant was a machine call instruction. So now they have different names so as to not be confusing anymore. So it's now m dot call, m dot return, or whatever it is for all the generic mir instructions.
So if it's not from the backend, then that makes it
Yes.
clear that it's not.
Yeah, m dot call is a generic call, and just call would be an XA664 call.
I ran into that a few times as well, so that's way better.
Mm-hmm. We now opt is now a subdirectory, and all the optimization code is in there.
That's awesome.
Yeah, the frame type handling was really off because we were.
Yeah.
Yeah, there was a bug in there that just caused the stack pointer not to be restored, but that's fixed now. And I've added a comment to make sure it's now clear what all of the frame types mean and what needs to be done, because that was just not correct. Where even is that? I'm not sure what it is.
I'm not either, but I was going to try and find it. I'm pretty sure it's
I
just in
guess
the big one.
I can find it in C-line, I suppose. Hold on.
I appreciate this.
Frame full. Where's that defined? It's defined in arch x664 common.h.
It's in the common header. Nice. Yes, very extensive comments. I like it.
It's extensive enough.
It is. I love the desperation in your voice there. You're like, no. It is very extensive enough. So, yeah, what I misunderstood, I think, was that the
You were
minimum.
pushing RBP for the minimal frame, which is the exact point of the minimal frame is that you don't push and restore RBP. That's the main problem, I think.
Right, and my thought was like, oh, we don't have to like set the base pointer to the new stack pointer.
That too, we don't have to do that either, but
Right, but I didn't take it far enough. All we have to
yeah.
do is make sure the stack is aligned.
Yes, so what that entails is we add something to RSP at the beginning to align it, and then we subtract from it again because we know what the frame size is at compile time. We subtract from it whenever we return instead of using RBP at all.
I just pictured I totally got distracted. When that sound of like ice clinking in the glass happened and you pouring something, it was so satisfying that like I just lost track of anything that's happening.
Wasn't ice, that was just the bottle cap, but sure.
Oh, it was beautiful. And then it was like all I could imagine is like you're in a suit and you're like pouring a martini and then you like you poke an olive with a toothpick and you're like chewing on it. You're like and just while you're doing all
Sorry,
this.
but it's just sparkling water.
Oh, that's still fancy. That's still fancy. You could still be in a suit.
No.
He doesn't want to say because he's naked, like me.
No, I'm just wearing regular clothes.
Right, none at all.
Is how I would put it. Now, where were we?
Is it you said hi?
ASMR moment. Oh god, this is an ASMR stream now. Okay, let's see. Yeah, that it validates attributes. So now if you make a void function discardable, that's nonsense, for instance.
Nice, yeah.
It doesn't check for no return yet, though.
We'll get there.
Yeah, the test runner was horribly broken in more than one way. It is now no longer broken, I would hope. It also uses my command line options library for better command line options passing and lib format so we don't lose our mind trying to deal with IO streams. Those are included using it says external project add here. I also changed that. It's now via fetch content and only if you actually enable the tests.
Is fetch content available in our CMake minimum required? Do we know that?
I increased the CMake minimum required because of that.
Fantastic. Tests now always fail on an internal compiler error.
Oh, nice. Yeah. I don't think they fail on assert yet because that doesn't contain the words internal compile error, so we'll have to add that too. But ice is good enough for now.
Yep.
And it was a 2-second. Funny story about the next one. It used to be a 2-second timer. That's completely fine on my PC. But when I did this on my VM, where I had it set to I think like 2 threads only, it would actually just time out because the VM was too fucking slow and all the tests were failing all the time because of that. I was very confused. So I've increased it to I think 10 seconds now, and that's enough for my slow VM. Because when I was testing it on Windows, I had to use a VM. That's why. So 2 seconds works for my PC, but not for a VM or a slower computer, apparently. Hold on, I'm getting a lot of Discord notifications. I think I need to mute a channel or something.
It's all good. The address operand of stores and loads is now opaque. That means that the optimizer and backend will ignore its type. Instead, the
Yes.
type of a load determines how many bytes must be loaded, and the type of the value operand of a store determines how many bytes must be stored. Basically, we're ignoring type information. That way we reduce the amount of data we need in the IR, right?
Yeah.
And we can
This is
do
not
better things.
fully implemented yet. I think there's like some weirdness happening still somewhere, but this is already better now than it used to be.
Nice. As long as we started towards this, that's even amazing.
Yeah. The AST struct is now called module, though I think the
Makes sense.
like some internal variables or fields are still called AST, but the thing is now called module.
I think that's fine for now.
Which makes more
That'll
sense.
iron itself out.
C standard version is now set to C23 and
What
CMake.
was it?
It was C11, I think.
Oh dear, yeah.
This I think is not accurate anymore. I did that, but I reverted that. The redefine some macros things. So ignore that. A Dominator tree construction now uses the Lengo-Etagen algorithm. I'm not going to go into that too much because it's a bit complicated, but basically we now use a proper Dominator tree construction algorithm. You can look that up. There is a paper on it from Lengo-Etagen, who would have guessed, from the 70s. It's a pretty old algorithm, but it works. We might replace it again completely because there's another algorithm that also computes loop nesting forests, and that's nice to have. So we might replace that eventually in the future, but for now that's good enough. It generates a dominated tree that looks right, so that's good enough for me.
Beautiful.
The code is horrible though.
Oh, you just slap that one in there.
Yeah, the II is now opaque. That took a while. I think that was a single 4,000 line commit because there was no way of breaking that into more than one commit logically. because we had to change everything. So basically, the story behind this one is interesting because the main problem here was use marking. So basically, in many places in the optimizer and also some other places, the compiler needs to know how often and by what other instructions an instruction is used. That way, it can replace instructions by replacing uses of that instruction in every instruction that uses that instruction. So clearly, if you get use marking wrong, terrible things happen. And terrible things did happen because keeping track of use marking manually is a goddamn nightmare. It's atrocious. It's not that it's too tedious to do, it's just impossible. It's so easy to make a mistake there. Like, I'm not new to compiler development, and neither is Lens at this point. We were constantly making mistakes with that all over the place. It was horrid. There was like, I don't think there was a single day where I was working on the optimizer where I didn't have to fix use marking bugs. So we've decided no more. The entire IR is now opaque. You cannot access the user list directly anymore. You can't set, add, or remove anything. All of that is handled internally, and whenever you, for instance, change the operand of an instruction, you have to do that using a function, and that function keeps track of uses and sets them and unsets them properly. So now we will hopefully never have to deal with use marking bugs again. The only place where that can still happen is in the IR implementation file that implements those functions. I'm pretty sure most of those should now be working correctly, so I hope we won't see too many use marking bugs there anymore. We won't get any more use marking bugs anywhere else, or as a result of anything that we do anywhere else. And the only code that uses IR structs directly now is the inliner, because it kind of has to, because of the way in which it is creating instructions. That isn't exactly trivial. And that's also now considered part of the IR implementation because of that. But yeah, that's that. And that took a lot of rewriting.
I can imagine that took an amazing amount of time.
I think it took 3 days or something.
Yeah, because it like that's literally everywhere where we're like accessing the members.
C-line shows me a list of errors in each file. I had 200 errors in 5 files, not across, in each of 5 files.
And each one, like, you can't just search and replace because they're all slightly different.
No, it's not that they're slightly different, it's you have to change field access to function calls.
Exactly, yeah.
Yeah. Nothing uses linked lists anymore. That have removed a major pain point. Things are a lot easier
For
now.
you.
Yeah, I mean, it was horrible. There was so many bugs also because of lists, and removing instructions was hard. There were bugs because handling doubly linked lists is awful. You constantly it's so easy to make a mistake there. Again, it's so easy to get something wrong with these kinds of data structures that I've just eliminated them now. That also has one more benefit. The size of an instruction used to be 128 bytes. It's now 112 because the 2 list pointers are gone.
And they've moved.
Yeah, now they have moved it all. They're gone. It's now a vector. So all the information is just stored in one place.
Exactly, yeah. Yeah.
And it also makes made the inlining code easy because, like shuffling, like moving instructions from one block to another is now easier because you don't have to fix up the previous and next pointers of blocks and instructions anymore. You can just copy them around and it works, or move them around, right?
True. In a much slower way. But it
Yeah,
is
I mean, I'm not
in
even sure
modern
it's slower.
computers it doesn't matter.
Yeah, especially because of like caching stuff, because linked lists are just categorically slower. I don't think there's a good reason to use linked lists anywhere anymore. Even for stuff like when you need to insert or delete, like walking the list or something like that, that is still worse than just copying half of an array around. And most of the time we're not going to be dealing with basic blocks that contain 2 million instructions. They're going to have like 10 or 20, and copying that around is trivial.
Right. But I also want to say that what you're describing is an ideal world. And I agree that like we shouldn't have to use like temporary fixes or quick hacks ideally, but we do have to. So
Sure,
like
at some point, but I'm saying is, yeah, because now that we have vectors, we can just use those every
exactly.
time instead of
Yeah.
ever using linked lists again, is what I'm saying.
And I think that's a good idea. You should always
Yes.
verge towards changing the data structure and making it more better. We talked about this one.
We just talked about that one. Yeah, no longer manual and lowering instruction. We lower parameters first because that might introduce. Originally, it did
Oh,
introduce
yeah.
like loads and copies, but now the parameter lowering code has special handling, and it inlines, for instance, System 5 two register parameters are inlined into stores. So if you have a store of parameters split across two registers, the store is now replaced with two stores of the two registers. And stuff
That's
like
so
that.
much better. That gets rid of a lot of the jank along
Yes,
arrays.
there was a lot of jank in that regard, as we can see in the next paragraph.
Yeah.
Lower load, this was a bit of a complicated one to get right because this is a fundamentally flawed concept. You can't load a 64, not a 64-bit works, but like a 10 byte or 20 byte value. What are you
On
going to
some
load it
backends,
into?
yeah.
You can't load it into a register. So, and the thing you have to realize that here is that the only thing you can do with like a quote unquote load of a 20 byte value is either pass it to a function, which requires special handling anyway, or store it into something else. And if you pass it to a function, you might need a temporary copy on the stack. If you store it somewhere else, you don't. So the idea is that we just emit oversized loads. And if we have oversized loads, then we rely on the fact that every instruction that is allowed to use such a load, which currently is just calls and stores, such instructions have to iterate it over for potential uses of such loads, and they have to check for those loads and lower them appropriately if there are any, basically. So we now iterate over all in lower store. We check if the operand is a load. If it is, we replace the entire thing with a mem copy. And the important thing is we remove both the load and the store if the load is no longer used after that. And yeah, oversized loads are now just DCE'd out of necessity because we can't emit them. We just can't. They have to be used by something to be able to be emitted. Like a load of a 20 byte value still makes sense internally as an intermediate representation. Funnily enough, as an intermediate representation. Sure. But we can't emit that on its own. It is meaningless, pretty much.
A computer could never do it.
Yeah, there is no. The only thing you can do is make a copy, but that's not the same thing as loading a value. That's allocating a new variable and storing it back into that.
So we
So yeah,
kind of
this has now
removed
been.
the. Go ahead.
Sorry, I was just going to say this has now been unscuffed, and we shouldn't have problems with that really anymore. Anyway,
Beautiful.
what are you going to say?
I was gonna say that like it's basically it's hard to pinpoint exactly how to say this simply, but basically instead of lowering loads of like 20 bytes into load 8 bytes 8 bytes and then 4 separate bytes, we are still doing that, but we're we're only doing that in a way where we don't create a pointless copy in doing so, right? There's no temporary.
It's not even just that we're doing that. It's more like in some cases we end up doing that because what happens is that if we have a store of a 20 byte value that uses a load of a 20 byte value, well, both that store and load will be replaced with a mem copy, and then the mem copy gets lowered to a copy of 8 and 8 and 4. Sure. So eventually, if it's used in a store or something like that, it will get lowered to copies, but on its own, it just doesn't get lowered to anything. On
Which
its own, it
makes
just
sense, yeah.
kind of sits there. And if it isn't removed, that's an error. We can't deal with that.
Yeah, that makes a lot of sense. Okay.
Mm-hmm.
And that'll fix a lot of jankness, like you were saying.
Mm-hmm.
That's awesome. Yeah, so that's the two things you just mentioned will probably fix the like arrays being horribly bad.
Mm-hmm.
Un-
Bad
as,
to deal with, yeah.
unless sys5 is unless I screwed that up pretty bad.
Arrays, I think, are mostly working now, yeah. Yeah, I've added simple iterate and validation checks to make sure you don't delete or insert
Statement
anything in a loop.
expressions.
Mm-hmm. Not even statement expressions, no. They're just function calls.
Oh, nice. Replacing single elements is still possible. Nice.
Because
Yeah.
that doesn't invalidate anything, because it doesn't cause a reallocation.
Yeah, like and that's basically like just changing the details of a single element.
Yes.
Read instructions.
Read instructions and blocks are cached and reused, and if address sanitizer is enabled, they're also poisoned to make sure that you don't actually use them accidentally. So they still act as though you had freed them.
How do you poison a computer?
You don't.
Strychnine?
You call a function in the asan runtime. There's asan poison memory region. You call that, and that tells address sanitizer this is poisoned now. The way address sanitizer works, to my understanding, basically the compiler performs some transformations to insert calls that check that everything's okay whenever you dereference a pointer and stuff like that. So
Yeah, so poisoning just says like, hey, these pointers are no longer good.
yeah, and I presume it has an internal list of all poisoned regions or something in that vein.
Nice.
And this was a weird thing. We previously had both an ID and an index on an instruction. Now it's just an ID because we don't need both.
And this resulted as a complexity from when
I believe it
we
was register allocation.
yeah, when we implemented register allocation and the whole virtual register thing started happening.
Yeah.
And that's when my brain, I couldn't understand it, and I just needed a way to actually refer to an instruction where I understood it. I'm pretty sure that's why index was there, because I could be like, okay, this is the 37th instruction in this function.
I think index was used to just index into it an ID to debug it, for debug printing, but we'd only need one of those.
That's right. I probably got those backwards.
That also means you need to be careful. For instance, if you recalculate if you in the debugger, if you call IR set IDs while you're, for instance, in the main inlining loop, it will mess things up because they now use the same variable. But that's only if you do bad things in the debugger. So
don't do that.
Don't do that. Yeah, there were some bug fixes. Attempting to generate IR for return expression that returns a value no longer crashes the compiler. Because that was broken. An explicit return. I'm not just returning last value, but the return keyword. That was just broken.
Awesome. We didn't have a test?
Yeah, that's related. Sorry, what?
We didn't have a test?
No, I didn't think. I'm sure either was failing or we didn't. Now we do. Yeah, there was a bug that was related to the thing where we're inserting basic blocks after returns. I mentioned that earlier. That's fixed now.
That's right.
There was some use tracking bugs. I think that was before the refactor. Now that's just all the use marking bugs are hopefully fixed for good now. And there's way less potential actually no potential to cause any further use marking bugs.
You underestimate my skills.
Block labels were not being emitted due to some weird thing in, like, we had some check that didn't emit labels if they weren't used, but I'm pretty sure that check isn't really necessary anymore because in an optimized build, we concatenate adjacent basic blocks and so on anyway. So this should not really be necessary anymore as an optimization fundamentally. That was from days of yore where we didn't really have a proper optimizer anyway. So
that makes a lot of sense. Yeah, that I remember that was like one of the first ones we added, but it did help a lot clean up the bad code.
Yeah. That was the stack frame thing.
Oh, yeah. That was me.
The align to macro now uses statement expression, so it doesn't invalidate arguments multiple times, because that was happening where it would call type align or something like that multiple times because of that.
So we are able to do like a expression once type of thing if we put it in intercept terms. Sema now prints a sensible error message when attempting to perform overload resolution on an empty overload set. Oh yeah, it was just
before it would just print the overload set, which is weird because there was nothing in it. Now it just prints unknown symbol or something like, which makes more sense.
Nice, that's much better.
The source location of return expressions was set incorrectly. Was some bug there. I don't remember what that was, but it's fixed now. And now when we remove an entire block, if there are any files that use values in that block, they're just removed. the uses for in the files are just removed because the entire block is now gone. So you
Oh,
have to be
wow,
careful
yeah,
when you
yeah.
remove a block. You have to both unregister values from that block used in other files, and also the files in that block have to be handled. It's a bit of a mess with the files, but you have to just keep one or two things in mind. That's also explained in comments, but that's handled now, so we don't have to think about that too hard anymore. Yeah, ANSI escape sequences that didn't end with M were not being treated correctly by both the format check plugin and the formatter, because we're just always accepting an M. Now it just looks for any character, because for instance, if I have code that moves the cursor to the 60th column
Okay.
for printing users, and that ends with G, and that was just crashing. So now it doesn't do that anymore.
Nice. Yeah. Oh, yeah. There's probably a bug in Lenser OS with that then.
Interesting.
Because I'm pretty sure there's code that does this exact same thing where it just looks for an M.
Yeah. So that was fine when we were still using colors, but now that we are also using more, it stopped being fine. Anyway, fixed the bug in the test runner. Yeah, that's the test runner was completely refactored. That there was some problems. And we fixed more iterate and validation bugs. The iterate and validation checker helped with that too, and fixed warnings like W conversion, W sign conversion everywhere, especially in like the backend and like the
Casts.
object file and so on. Yeah, mostly casts. So miscellaneous stuff. We have this is just stuff that isn't really a refactor. It's new things, but they're internal. They're not really part of the languages of the compiler. We have a poison instruction. It isn't really used much yet, but this is a way of telling the compiler, hey, there's an error here, basically. And you can, for instance, replace an instruction with that to effectively remove it without removing it. There's some uses of it. It's currently not really used anywhere except in, I think, in IR force remove, but which is also not really used that much, but it's there for whenever we need it.
Perfect. We have int3 and UD2, which for those
So
that don't know, here, I'll get that up.
int3 is the debug interrupt, and UD2 is an undefined instruction that just crashes.
It calls the debug exception handler.
Yes.
With
So in case you don't know that, if you set a breakpoint, what that does is it replaces the instruction in that place with an int3. And the int3 then, in the kernel then calls into the tracing process, which is the debugger. And the debugger then shifts that back. And that's why it's 1 byte, so you can replace any instruction with it.
How beautiful.
So that's how breakpoints work. It just replaces it with an int3. And yes, you might say that's self-modifying code. Not really, that's the debugger modifying the code, and the debugger or any tracing process is allowed to do whatever it wants pretty much with the trace, including just arbitrary edit memory, including the code being executed.
Don't a lot of debug builds generate no ops in a lot of places so that breakpoints don't have to modify actual code?
I'm not sure about that. That could be the case, but it's not really necessary even.
It's not necessary, but I feel like I've read that somewhere that a lot of debug builds for big software will just.
Maybe, I don't know too much about that. I only know it replaces it with a knob, and then when after it hits the breakpoint, the debugger, it of course remembers what it replaced and substitutes the old thing back. So
I
it
guess
doesn't
that
actually
works,
break
yeah. So
anything.
maybe that's older stuff that didn't want to do extra work.
Yeah. And UD2 is designed to be an instruction that just issues an undefined instruction error. That's used particularly for testing, but also we just use it for unreachable. If unreachable ever needs to be code gen, we insert that there. And this can actually be useful in some places because it stops the processor from reading ahead and trying to speculatively execute whatever is. So you can sometimes put UD2 after a jump to stop it from reading ahead. That can be useful. But that's like a super micro optimization if you're writing assembly by hand.
Yeah.
It's mostly just so we can code gen unreachable because we weren't able to do that before, and this seemed like the natural response.
I agree. Yeah. That's a great way to do it.
Yeah, that's how it's implemented now. We have a rule in the ISL table for that.
Which makes sense.
We have an undocumented command line flag that's intended for. I mean, we can document it and rename it if you want to, but the primary purpose of this is to it is the same thing what used to be the debug IR flag before you decided that it was a good idea to still have it generate code after printing the IR, which is generally not what I want. I just wanted to print the IR and exit without emitting any code because I just want to look at the IR and not generate code. So that's what that's for. Because it got
Nice.
annoying that it would just generate code all the time.
That makes sense.
Exits after the optimizer. We're missing some type defs.
Were we really?
Yeah,
Just these random
U16,
ones?
I8, and I16. Just those. The other ones are all there.
Weird.
We have a vector resize now, which is just like vector reserve, but it also sets the size.
Nice. Yeah, it just does the reserve and then sets the size to the new size.
A vector push unique, that's basically, so vectors can also function as sets now because we need them in some places.
Nice.
Vector move to an insert, all those are only used in like one or two places, but they basically move a bunch of elements between vectors. They're used in like the inliner.
Makes sense.
And
Eskel
replace what? No, keep
Essel
going.
Cardawani and Zirkos86, thank you so much for the follows.
And function that replaces the first occurrence of an element with another value. That's also useful. So like
Yes.
replacing uses, for instance. Or I think replacing uses is done
Tests.
differently, but it's useful anyway. We have some more tests. We
Ooh.
can now print both the control flow graph as well as the DJ graph, which is currently just the Dominator tree, but it will soon be the DJ graph, to a dot file.
What is the J
DJ
part?
graph join edges.
Ah.
That's edges that go back up. That's useful for dominance frontiers, which is useful for mem to edge. So
For those of you that don't know, Dot is a graph description language, which basically GraphViz, this really old software, was used to generate graphs and things like that. And dot files are its input, and then it can create different graphs from the dot files based on the given connections and nodes.
yeah, and this is like traditionally used by compilers to visualize control flow graphs and such.
Yeah, see, it's a lot of the times it's simple like this.
We can look at some graphs later that it
That's right.
generates.
That's a good idea.
Mm-hmm.
GraphViz, awesome.
We have an option to make ASAN ignore leaks because we have a lot of leaks right now, and there's more pressing issues than leaks like use after free bugs sometimes, and I only want ASAN to report those.
Instead
So
of
that's
just
why.
endless output, yeah.
There is an op. You can make it set a CMake. By default, it still reports leaks, but you can now set a CMake option to make it ignore leaks.
Awesome. Mr. Dick Steele with the follow. He came in from the Discord swinging around, and you decided to come back,
I see.
join the old Twitch. Oh, the
We
last
also have
one.
maps and multi-maps now. They're not hash maps, they're just vectors. But they have a map-like API that's very useful in some places, and we can eventually see. That's the thing. Someone mentioned API and implementation earlier. The API is there now. We can always just replace the implementation without having to change the API. But they behave like maps now. These things. So a map is just every key is associated with a value, and a multi-map, for those who don't know, a key can be associated with multiple values, where you can query that key and get all the values associated with it. So column, that's just a vector of vectors.
It's beautiful.
So yeah, that's a high-level overview of the changes, but there's some stuff we want to look at in both in code as well as in what it does.
Woo! PogChamp. What should we look at? What should we look at?
What I would look at in sort of this order is the some of the results that the optimizer produces. Now, particularly, there's one test I want you to try. Then we can talk about how inline is actually implemented, and then we can maybe look at some control flow graphs or something.
Okay, so first step would be like pull this locally, right?
Mm-hmm.
Okay. We're just gonna go here. I think I have it.
If you have a copy of my repository, you can just check out the inline branch.
Okay. Git pull does a git fetch, so I should get your branch.
Oh god, you have merge conflicts now.
What did I do?
I don't know what you did. You
I
did
had
git pull,
nothing.
git fetch. Just do a git restore dot. Not got restore.
Oh,
Git restore.
yeah, a bunch of errors.
Whatever. Just ignore it. Don't do git pull.
I have a solution.
The reason it's complaining for maybe you changed something and also I force pushed some things and I rebased your branch, so that's why.
Is this how this works?
Yes. Clone it and then check out the branch. Git reset hard, that would also have been an option, I think. Yeah, that's what I typically do. But it's too late for that now, and it doesn't really matter. Git checkout inline. Git checkout, it doesn't show it if you haven't pulled it. Just
That's
git
so
checkout
annoying.
inline. There we go. You can
Okay,
do git
now.
branch -v to list the branches, by the way.
Yeah, let's
Anyway,
just see what happens.
let's just build it and see what happens, because it will have to do some stuff locally. Let's see if this builds fine on GCC 10. Okay, good God. Let's see if that works.
It's the newest available.
That's abysmal.
It's
but
not.
sure.
It's like 2 or 3 versions behind. People
Three.
are still on 4.
I'm using 13, but go ahead. But okay.
Oh, it works on my
Let's
machine.
see if this builds. If the test runner builds. Oh, yeah, need to specify what linker to use.
Why?
Because it can't find that automatically, because that's too hard if you want to use testing.
That's annoying. At least there's a thing.
It needs to be an absolute path to the linker.
Why is it not? See, this is the case where it should be shorter. Intc test linker would make more sense, or even just test linker because it has nothing to do with intercept.
Sure, whatever. But you need an absolute path to GCC or Clang.
I don't have one of those. Why do I need an absolute path?
Good luck trying to resolve a path on Windows.
Why do you need to resolve it? What do you
I don't
mean?
know. There was some weirdness with relative paths because of environments. If you can figure out a way
It's
that works
in.
cross-platform, feel free to change it. I couldn't.
Well, why can't we just write Clang?
Try it. See what happens. You can try. Maybe it works. Let's see if the test runner builds with GCC 10.
No.
It seems like something didn't. If you scroll up a bit, expected expression before. I think I changed that, didn't I? The pragma thing.
Well,
I'm pretty sure. Okay,
did
I
you
know
push
what
it?
that is, but hold on. Where is that? In the dominant reconstruction. I'm pretty sure I changed that though. It's weird that it complains about that. I know what it's complaining about because GCC doesn't allow underscore pragma at expression scope. It needs to be a statement. But I'm pretty sure I changed that. So I'm not sure what it's on about. Hold on.
Line 234.
Okay, now C line is taking a while to load this goddamn file because it's just too damn cursed. But taking a look at it at Vim, because that file is horrible. Let's see. I'm pretty sure I changed this though. Yeah, I'm not sure what it's on about. I changed it to be at expression scope. Let's see. Hold on. I'm gonna try building with GCC, but it should work.
And you have no local changes?
No. We are going to hold on.
Then the answer there is it would be compiler version, and you're doing something funky.
I'm using GCC 13 again, so I don't know if it builds with GCC 10, but we can test.
Why would you use something that nobody has?
It builds with GCC 13 just fine.
That's something
Do I
that
have
nobody
it?
has.
I have it. I think I even have GCC 10 on a goddamn Debian 12 server or something. I have GCC 13 on my Windows VM. Okay, so
Good for you. It works on your machine.
so I don't know what the problem here is because that shouldn't. Okay, I can test it in Godbold if GCC 10 complains about that because that's a weird. We can just comment on the pragmas if that's a problem because they're just there to silence some horrible. Or we can just put them at the top of the file. Because this is some horrible code here. What you can try and do is just grab the push
Just
ignore
here?
all the warning stuff, the push ignore warning macro and the pragma string macro and put that at the top of the file.
Where are those defined? Utils or something?
No, just grab them from here and put them at the top of the file. Just copy line 51, 52, put them at the very top. And remove the pop warnings thing from line 56.
Yeah.
And that let's try that, because this problem Clang compiles are just fine. GCC 13 does too, but there are some problems with GCC doesn't. This uses underscore pragma instead of hash pragma because you can't put preprocessor directives in macro expansions. But GCC or some versions apparently don't like if you put that in weird places. They don't like that.
ICE segfault.
What?
Command line
Internal
options.
segfault.
Your other thing is broken.
GCC crashed. You crashed. Okay, my library crashed GCC again. Brilliant.
Stop doing these things.
This is a GCC. Okay, so the problem here is that my command and options library is crashing GCC. I know that some versions of it do that on some versions of
You're
GCC.
so
I
bad
really
at writing code, the compiler crashes.
I'm not.
I
GCC
know, I'm
devs
just
are
joking.
apparently so bad at writing a compiler that they crash on my poor library. So this code is horrible, by the way, because the algorithm is also horrible. Don't worry too much about it. You can read the paper if you want to understand it, because it's literally a 20-page paper or so that just explains the mathematical reason for why this algorithm even works.
Well, it's beautiful. I like it.
And I think I'm going to replace it because there's a better one that also constructs the loop nesting forest that is less scuffed than this. But we'll get to that. So now what we need to do is we could just need to change the way command and options are passed. Because apparently GCC 10 is too stupid to not crash on my library.
Right. Because you're writing...
I'm writing very cursed code, admittedly, but the compiler shouldn't care. It should just compile it properly. That's what compilers
I
are for.
agree, yeah.
So GCC, they're apparently not doing too much metaprogramming testing. So I'm going to quickly change the test runner to just literally just accept command line options in order or something, because all of them except for -O are mandatory anyway or something.
Exactly.
So we'll just accept them in order and be done with it, because it's always target, test, compiler, linker. And that's not going to take too long. And we just put -O at the end, and it will just look for that if it's there.
Beautiful. I am going to use the
This is
restroom really
not new to
fast.
me. Like my library has crashed GCC twice before. In one case, I managed to remove a no discard to uncrash it, and for another one, I had to remove some macro cursedness to also make it not crash anymore. But I really thought that I managed to get it to not crash anymore. I will have to investigate that, because that is not good. Yeah. Then again,
Something's going on.
I filed a bug report before they fixed that. I filed another one. They haven't fixed that one yet. So yeah. Hold on. So these are just in order now. Target test in CLD, target test in CLD. Okay. So these are just in order.
All right, while you finish that up, I'm going to use the restroom. I'm going to do a quick shout out. If you haven't joined the Discord, be sure to join. You get announcements every time I go live, as well as like this awesome community. So, and you can be part of streams. Just join the general, and then you're here. Anyways, I'll be back.
Clang has never had any of these problems before, by the way. Clang compiles my code just fine. It's just always GCC that has the bugs. I'm not sure I've ever run into a Clang bug before. And I have it set to use Clang on my end because we also have a Clang plugin that type checks format strings. That doesn't work with GCC, obviously, because it's a Clang plugin. So I only really use Clang if I'm developing the intercept compiler. So I haven't really tested it with. I haven't tested it too much with GCC, and also I use GCC 13 instead of GCC 10, and apparently that's, well, obviously there's some bugs they fixed in there that they haven't had the time or reason to fix yet in GCC, or hadn't had the time to fix in, or that just weren't fixed back in GCC 10, I suppose. Anyway, does this do? Oh, let's say static assert. Now I'm rewriting this code to work just with manual command line passing. That shouldn't take too long.
I'm back.
You're back. I was just ranting about how I've never had any bugs with Clang and just with GCC.
Ah,
Clang is a great compiler. I love Clang.
Clang is very nice, yes.
it's if it wasn't part of a whole thing, yeah. On itself, Clang is fine, I guess. But when it comes to like the entire ecosystem it's a part of and forces you to shoves down your throat, I should say. That's the issue with me.
I mean, Clang on its own isn't really a problem. It's just if you try to use LVM for anything, you have to well, probably build it for yourself, and that's a bit tedious.
It's not a bit tedious, it's impossible. For many.
Yeah, depending on your system, it might be impossible. That's true.
For most.
So if argc is less than, what is this? This is up to 5 arguments. 4 are mandatory, so if it's less than 5, then that's a problem.
Command line arguments always thought were like passed by the shell or something.
What?
Command line, I'm just filling silence. Command line arguments are like I always thought they were passed by the shell or like handled by the shell and somehow passed to the program from the shell and like it was doing something crazy or from the terminal. But as it turns out, the kernel handles all of that.
Mm-hmm.
Which is scary. Because you can just pass in like 8 null pointers as arguments. And like not even strings, just null pointers. And the kernel has to handle that.
Mm-hmm.
It's a scary world we live in. And then every pointer the kernel gets passed, it has to validate.
1, 2, 3, 4.
It's a mess.
Okay, I think I did this right, probably. So now we can replace these. So this is now just going to be test. This is going to be that. This is going to... By the way, the test runner getting paths to work on Windows was horrible. That was just pain. Pain.
Can't you just use slash?
Can you just use slash? Yeah, good luck with that. Even from the command line, no, you can't. Because you need to pass it, you need to escape. So on Windows, the command line is a single string. The first argument has to be an executable name. That means it has to be a valid path. In particular, you can't just double quote the entire thing. If the path contains spaces, you have to quote the path segments between the slashes or backslashes.
So
but
dumb.
the other arguments can just be double quoted, and it will remove the double quotes when it passes them to the program. So you can just double quote those. So because of that, the test runner now does proper path passing on Windows.
Well, what if you have like a program called double quote?
That's illegal on Windows. You can't have double quote slash backslash colon and a bunch of other characters and file names or directories on Windows. Windows API is pain. Yes, it is.
It's pretty accurate.
I'm gonna disable the verbose logging for now because
You know it's
I can't
also
be
pain?
bothered. Sorry?
You know it's also pain?
What is pain?
Ioctl.
I suppose that's not much better either. But at least paths work sensibly, I suppose.
Yeah, I'd agree that. Unix paths make so much more sense. And they're much more freedom allowing. You know what I mean? You can just like most characters are fine, everything except null usually.
Everything except null and slash are fine.
Yeah.
There used to be, I'm not sure if this is true, but it said that Stephen Bond, the guy who made the the born shell that's bin sh. That's why bash is called bash. It's the born again shell. It's a joke. But the original Unix shell was bin sh, and it said that he used to have a directory with one file for every ASCII character except null and slash, and that would constantly crash shells or something. He used it as a test suite for his shell and a bunch of other stuff. Okay, let's see if this builds. Oh, I have to remove it from the dependencies. Hold on. I have to remove it from here to, where is it? Here, we can remove that. There we go. Dealing with outdated compilers is always a pain.
I agree. But it'd also be a pain if, like, all of a sudden someone came along and said, intercept is actually this now. And then we had to, like, rush to try and implement it. And the slower we are, people are like, oh, you suck. Your compiler sucks. You're slow. It's like, no, we're not focusing on that right now. You can't constantly add new features as a compiler dev. So I get it. But as a user, it's very annoying. Like, we're in C++. We're in 2023, and C++ 23 is nowhere near usable.
Yeah. C+20 is mostly usable. Only mostly.
2 out of 10 is not mostly.
Oh, how does this work again? Hold on. It needs we can just pass. Okay, I need to quickly rewrite this function because it's very generic. So we can just, because I'm using an internal function from my command line options library, which we're now removing, which means I need to, that's the map file function that maps a file, duh. So we now need to remove that. This. Paste this here. That's good enough. I haven't even implemented. Yeah, we don't need to use C error though. We can just use format. At least lib format works with all the versions of C++. So that's a start.
Well, we think it works, unless it built claps
It
first.
works. I know it works. I know it works. That. Oh, actually, this doesn't even need to return anything. This can just be no. Can a lambda be no return? I don't even know. Let's try it.
I had a mini panic just now. Because I
What?
was like, did I never switch the stream away from the VLC thing? The visualizer? I was like, has it
Oh,
just been
God.
a black screen this whole time? I was like, oh
I think
no.
chat would have probably
Yeah, they may not
complained
have
about
known so much. If they're just looking at a black screen, it would be hard for context. That's a good point.
that. I'm almost done, by the way. Don't worry.
PogChamp. Oh,
This is now horrible code, but it's good enough.
interesting discussions about milk in the Discord. I didn't realize milk was so controversial. Everybody talked about milk. Do you drink milk?
Drink? Not really, no.
I'm sure you consume
Milk
it in
is
like
disgusting, and I'd never drink it.
do you eat like creamy foods?
Actually, I drink milk every now and then, but
Not
ain't
particularly.
So like pasta, mac and cheese?
Oh, that I suppose. Yeah. What do you mean by creamy?
There's milk and cream in it. And that's a main portion of the flavor.
I'm not sure if that's. I don't make pasta. I don't know what it's made of, but yes, I eat pasta. I don't. I can't cook. I suck at stuff like that.
Would you make Alfredo? I guess is the question he's asking.
Sorry, what?
Would you, I assume the question was something to do with creamy stuff on your spaghetti or something?
If it then says sauce, well, not.
Yeah, like an Alfredo sauce.
I think I have cream in my sauce. No, I don't think I'd like that.
What?
Alfredo is pretty good. Not my favorite sauce, but it's pretty good.
So you're not a cream guy?
Not particularly, no.
Oh, I love cream in my mouth.
I love creamy
it's gonna be
drinks,
quoted
creamy
for years.
Right,
snacks.
but
I just
phrase
don't
it
like
a bit
milk.
better.
Yeah, so drinking milk straight is definitely not an all the time occurrence. Right? But I do drink it all the time and eat it all the time in everything. Like mac and cheese or oh, someone just had a good one in chat. Coffee. I only know tactics. And then so like I don't particularly like love it or am addicted to it. But Dabster of the of the Discord, this community member, said that he drinks a gallon a week at least.
What is a gallon?
4 liters.
That is absurd.
I know, it's insanity. And it's just I
Then again, I
cannot
don't drink milk, so I wouldn't know.
it's I just can't imagine his throat must be so like filled with mucus. I don't know how else to describe it. It's just that layer.
I don't know. We can return this thing now.
Lactose elitism, shaking my head.
Lactose, that's a word.
Oh, a famous quote from Dapster. I don't drink soda because it's not milk.
Fascinating.
Another famous quote. Already downed half a gallon of milk today. That's 2 liters in one day.
What are you on about? I'm talking to the compiler.
Milk. I'm on about milk.
It's being stupid. I see what it is. We need to do this, I think. There we go. Yes.
Dapster. I've been drinking gallons per week ever since I was about 10.
Fascinating.
I don't even know how that's possible.
That's
I don't drink that much water.
What is N?
You should probably drink that much water.
Iced tea, which could
Gallons
what?
per week? What are you?
Sorry. Oh, it's F read, not I'm stupid. I'm so used to read returning a negative value when it is an error that I'm not used at all to F read returning a size T.
Damn, bro be drinking milk like it's water. Dang, really milking the milk there. I like how we had a damn and a dang clearly separate from each other. They both just emerged next to each other. Because of that milk, son.
Okay. Map file from this is a path, so we'll just call this and be done with that. Okay.
Someone.
Well, what else? Oh,
okay,
here.
totally another random thing. Someone said I sound like David Blaine, and I can't get it out of my head.
I have no idea who that is, but okay.
I forget that the world's
no
big.
return should not return. That is probably true. Yes, this should definitely call exit.
Beautiful. A couple of weeks ago, I tried to make hamburger helper with it. Didn't go well at all. Hamburger helper is pretty awesome. It's a little expensive for what it is. But in a pinch, it's just like seasoned food that you don't have to work for that hard. But you can pretend you did because you still have to make it on the stove. Hamburger helper with regular milk is amazing. Hey, I am new here. Oh, I missed something. Because I was talking about milk. Hey, I'm new here. Can you please tell, are you tutorials to make a compiler beginner friendly? They will be when I make them. I don't have any tutorials.
We have tutorials. We just have streams that just sort of exist.
We have documentation.
It still compiles, it still tests, so I think I'll call this decent enough. It's not good code, but it will do. I think it's actually not too bad. Let's remove dependency on plots to support lenses, archaic compiler. There we go.
Pretty accurate. I'm just git statusing over and over. I'm waiting for it.
Okay, here we go. You can get status on the show's local changes. That's not going to help you when you need to both. There we go. Okay, let's try building this again. Jesus Christ.
Beautiful.
Ugh.
Thank you. It'll be funny if it just doesn't work.
What in the world? Still? Where is that?
This is in dom.c now. The test runner appears to have worked.
What do you mean expected expression before? Where? What do you what pragma? Hold on. You moved that. Oh, you didn't move it. I have to move it. Right. My bad. We need to move the Dominator thing macro.
That's right.
Yeah.
That's right.
Okay. Where's at?
Okay.
We need to move this thing. Can just grab this. There we go, and put that somewhere here.
So you like milk? No, but so yeah, I'll just talk a little bit about that. I do plan to do actual videos soon. Probably in a few months though. Cuz right now I'm really busy and tired. Still doing good though. But in a few months, I should also have enough saved up to do my computer upgrade that I desperately need. And at that point, it's possible my computer will not explode and crash opening a video editor. Chat GPT about
try
this
now.
chat.
Try now. I swear to God, if it's not this pragma, but another one, I'm gonna scream. I don't think there's pragmas anywhere else, like inline like that.
That should be it.
Okay.
And I think the main issue is it's in a statement expression.
Yes, that is the main issue. Okay. It's linking. That's a good sign.
Ah, yes. Failed all of them.
Yeah, because the test run had a problem. So the link is see, you need an absolute path, I told you. Oh no, it's compiling because it doesn't find it. It tries to make sure that it exists. So we can remove that check and just let it crash, I suppose, if it really doesn't exist. That is an option, sure. We just remove the check for the linker because why the hell not?
Yeah, what does that look like?
But the main problem is that you sometimes need to append. Oh my god, this sucks so much. So I suppose if this is horrid, we can do this.
What's an
That
assert?
is absolutely atrocious, but it might work.
We've commented out verbose. This is awesome.
No, I did something worse than commented out. Only test if linker exists if it exists. There we go. Wrap your mind around that. Try now.
Say my name.
Good God, this is horrible. It builds though, so like the fetch content thing and is working. At least it's grabbing the header. It hasn't. Oh, it is linking too, so it is fetch content is just working. Okay, that is still not good. What's the problem now?
Well, all of them have failed.
Yes, why?
There's
like
no reason in particular.
probably because not finding the link and system is crashing because you didn't give it an absolute path. That was my problem at least when I tried this.
Why does it need an why?
I don't know. It's goddamn Windows.
System doesn't need an absolute path.
I don't know. It's Windows. Something is just not working.
What is
Don't
happened?
ask me.
I know that's fair. What do we do? What do you run command now?
Yeah, we have to do some horrible things. Oh, I think it's trying to canonicalize the path because it has to be a valid path. So, and Clang, it doesn't find where Clang is.
What?
Okay, I have to comment out more is what I'm saying. Oh my God.
It's even worse than we thought.
I swear to God.
So we're doing
The problem, can you just use absolute paths? Please just use absolute paths for goodness sake. It's not that hard. Just type where clang and it will tell you where it is.
I'm
Or
just
which clang. I don't know
nobody's
what
gonna
which
do
shellcode, but
this, and they're just gonna get errors all the time. Everything they
and
do.
people shouldn't be running the testing framework to begin with, just for compiler autos. So I candidly don't particularly care about that.
Even if I'm me, just even screw people, me. I'm gonna forget this and not be able to do this.
Canonicalizing the path. So I'm just going to comment out the entire path. Okay, so screw this. We're just going to run system and see how it goes. I don't care anymore at this point.
No, I am figuring out an absolute path.
Yeah,
It's gonna
please
suck.
copy that thing in there, for goodness sake. Oh my god.
The desperation.
Don't double quote it.
There's no spaces. There's backslashes, so it may be broken. That's a good point.
Doesn't matter.
It works.
So now, is it fucking finally? Oh my god, I'm gonna lynch someone else.
GMOSXX says you don't need Clang forever. Yeah, well, just until we write a linker for every platform we want to support.
I want to see 20. Okay, there we go. 11 tests failing is what I'm expecting. Good. And I'm going to add the check to make sure that the thing actually exists back.
Oh, is this right? Okay, yeah, that's a good idea. It's not a terrible check. Feel free to force push or do whatever you need. So it worked.
I'm not gonna force push because then you'll have to rebase or something. It's gonna be horrible.
How'd you break function arguments many?
I don't know. That was already broken.
I don't think it was.
I don't know. Let's just not worry about that for now. We can worry about that later.
That's fair. I am worried about it though.
Most of them are passing. That's good enough, I'd say.
Maybe this means the SDL one's not gonna. The SDL example's broken.
Has been broken for as long as I can remember.
It hasn't. It was working.
I don't know.
I promise.
Most of these are broken for backend reasons, I think. So that might be one of them.
In that case, if we had like object here, then it would only fail in like the assembly or the object one.
For like backend instruction selection reasons is what I'm talking about.
I see. So architecture, not the backend.
That is, yeah, for me, that's part of the compiler. Backend is everything after the middle end, which is instruction select, which is optimizer.
What's your opinion on NixOS? It's awesome. It's cool. If it catches on, it'll be even better. I'm not just going to go and use it because the stuff I need doesn't work on it. That's kind of...
I only know it by name, so...
It's basically a state, like a reproducible OS. So every package you have installed through the package manager is like recorded, so you can just hand that to somebody else and they can like just have your machine, your system up and running.
We can do some tests now. Just run the compiler without the testing thing. Just run the compiler manually and pass in the --print IR2 flag.
Just what file?
Just give it, for instance, we can do not examples. In tests, I want you to try downwards funarg, for instance, and also optimize it. That.
Ooh. Very nice.
It's inlining the call.
Very nice.
And as you can see, the functions are gone. 69 and foo are just gone after that.
Yeah, they're not like just dangling or anything like that. That's awesome.
Mm-hmm. Also, because I know you wanted this, I want you to take a look at one of the tests. At the code.
Oh dear.
It's one of the attribute tests. There we go. Attribute flatten. You wanted this. You told me you wanted a way to inline every function. There you go. The flatten attribute will inline every call in a function. By force.
Ooh, yes. Yeah. This is awesome.
Mm-hmm.
Okay. Yes.
Run that one.
The parser, I've broken the tree sitter grammar doing this.
Apparently, I think flatten is not in there. Probably that's why.
Ooh, that's part of it apparently, but not all of it.
Maybe not it. Okay, sure, whatever.
Wow. Okay, so flatten will cause all of these to be expanded into this.
Yes, and that's not an optimization thing. That's again If it fails, that's an error.
I love
That's
how this
just a
is laid out.
nonsense test with a bunch of blocks that's from the jump threading test, actually, to just create a bunch of basic blocks that need to be concatenated.
Yep. That's fantastic. So if we actually
just
pass
run that.
this,
You can try running that without optimizations and see what happens.
oh god,
200 basic blocks. There you go. That's what happens.
oh god,
If you inline the function, I think 20 times or so.
that's amazing. Lots of empty branches because the else.
Yeah, those are going to be now run it with optimizations. There you go. That was my main goal for the inlining PR for that to work, and it does.
Oh, that's
Funnily enough,
satisfying.
this only optimizes away to 42 if you have the flatten. If you remove the flatten, it doesn't inline everything, and it doesn't optimize everything. Because
Ooh.
it doesn't inline everything because that would be too much. So this only works with attribute flatten. This being all optimized away currently.
So you
at
can
least.
be way more aggressive with optimization this way.
Yeah. Currently, I think it's also just the way it works. We can take a look at the inliner next. I think there was another thing that we wanted to look at. Oh yeah, the dot graphs. Do you have GraphViz installed or dot or whatever it is?
I should have, yeah.
It would seem you do. Okay, so just run. I think they're documented. It's, for instance, .cfg, and you have to pass in a function name. Like you can give it, don't optimize it, and just give it bar or something. I think that's what that function is called, or main, or whatever. Or maybe let's do a simpler test first, not this abomination. Let's maybe go back to, there was some test I was using, I don't remember which one it was, some simple one.
Yeah, this
With a
is
few
going to be...
branches, not too much. I think one of the if tests would probably work. What was I using? I was using something. Hold on, let me check what I was using.
There's only a few.
Dot early return cond is what I was using apparently.
Cool.
That one is decent. Yes, grab that one and just print for foo. I was using the function foo here because it's more interesting. So
Okay.
foo, that will create foo dot.
Foo dot dot.
And now you can run, what is it? It's dot, hold on. Dot slash capital T PNG.
Yeah.
Dash capital T PNG, and then O, the output file name. Dash O and whatever you want the PNG to be, and then the input file.
Oh, the input file.
You need to give it an input file.
Ugh.
And
dot
spell
is
it
so
right.
weird.
So now you should be able to look at food.png.
Ooh.
There you go. It's the control flow graph for food.
How beautiful. Oh, Piotr says, or Nexavec says, gotta go have lots of fun. Bye, Nexavec. Hopefully that wasn't a long time ago. This is beautiful.
Oh, it was just a minute ago, I think. But yeah, we have that now.
Oh.
And this, because you asked that, this uses they're no longer called IR emit because I just call them IR print now. But yes, I'd use the same thing basically, except that instead of like vertical slashes for the type, it uses an arrow and stuff like that because that looks nicer.
So this format and this format are pretty much the same. You can draw equivalencies between them.
Pretty much.
Oh, this is fantastic. So
now you can actually visualize the thing now if you put them side by side or something.
Yeah. This is beautiful. Here, let's try the optimized one.
Yeah, the optimized one is probably not going to be too interesting.
Can I set the name of the dot output file?
Currently, no. Currently, it's just functioning dot. Again, it's very rudimentary support because you'd have to add another command line argument for that, and that's annoying with how we're passing command line arguments. So the optimized one is not particularly interesting, unfortunately.
Ooh. Assertion failed file.
I don't know what that means. Don't worry about it.
Who knows? So,
Who knows?
what was I
Anyway,
dot.
Yeah. So, well, foo opt is just going to be, if you just print...
It's going to be nothing, right?
It's just going to be one block. It's
It's
going to
the
be the
same.
same thing because it didn't recompile. Well, there's some assertion fail. I don't know what it is. But it's a assertion failed file would mean it can't open the file for some reason, which is weird.
It's like it can't open a file called main dot dot.
Main dot dot.
Maybe
Apparently.
that's no good in Windows. That's some hidden disallowed thing.
Who knows? Anyway, we know this is working, and you can also print, in addition to that, the Dominator tree. We can take a look at that. That is print.
Oh
I
dear.
think it's dot dj, and it also just uses foo dot. It also just calls it foo dot o, no foo dot dot.
Ah, yes, you've done well.
It's seg false. That is very strange. Does it do that on my end too? Hold on. DJ. What? It's not print DJ. It's dot DJ. Is it?
Did you like forget to null terminate a path or something?
No, I have no idea. Hold on. Early return con dot DJ for foo. It also seg false on my end. Let's see what this is about. I can debug this real quick. That won't take too long.
Beautiful. I'll start
It's
talking
also
about milk.
because I implemented this before I rewrote all the Dominator tree construction stuff, so maybe I just forgot to update something.
Ah, I see, I see. Dang, reminded me of last sem. I don't know what that means. Nyland Dude says project. I linked the intercept repo, or technically the pull request that we're working on right now, but don't worry about that.
Apparently, something is wrong in the Dominator tree construction code. Where it just returns null for some reason. That's interesting.
Fantastic.
We're not going to worry about that for now.
I like that mentality.
I need to refactor that part of the code anyway, but
Incoming PR.
like the Dominator tree construction algorithm right now is pretty much already in need of refactoring, even though it was just written because it's a mess and there's a better algorithm. But yeah, let's not worry about that. It'll work eventually. We don't really need it for anything either right now, so it's fine. As is obvious by the fact that optimizations work without it.
Yeah.
But we will need it in the near future. Now, what was I going to say? Yeah, we can take a look at how inlining actually works.
What do you mean? You just copy the code.
It's more complicated than that.
I know. Where am I going?
It's in IR, I think, because it kind of needs to access IR structures directly. It's in inline.c, yeah. So all the inlining, good God, what is wrong with your LSP?
You, clearly. File not found.
File not found. Why? It is there.
Probably because we don't have the compile commands.json copied because I did the thing. And then
There we go, that's better. So this context, it just has a bunch, okay, we'll talk about the history. We can talk about that. Basically,
ooh,
this
hold
is to
on.
prevent infinite recursive inlining, where you inline function A, which creates a call to B, which you have to inline, which creates a call to A, and so on. This just keeps track of where a call came from to make sure we don't inline the same thing over and over again.
Basically, yeah. We've got a question in chat. What is a Dominator tree similar to an AST, I'm assuming?
Explaining that would be okay. Basically, I can explain that real quickly, but not in depth. So a Dominator tree is a similar thing to a control flow graph, but it's based on immediate dominators. And in a tree, a vertex dominates another vertex if all paths to the exit block. No, sorry. If that. Okay, hold on. Yeah, a vertex A dominates a vertex B if all paths from the root to B go through A. I mean, you can't get to B without going through A. If that's the case, then A dominates B. And the dominator tree is a representation of the control flow graph based on immediate dominators. And immediate dominator means the closest dominator that is not the block itself. because a block, by definition, a block dominates itself, or a block being a vertex in the Dominator tree is a block in the control flow graph. So that is, and that representation is useful for a bunch of things like loop optimizations, but also SSA construction and things like that. It's not necessarily for if and else, it's for loops a lot, but yes, in part for optimizing or inserting files rather. So there's things you can do with that, but explaining that in depth would take a lot longer.
Yeah, that was beautiful. That was really good. Hopefully it helped him too.
We have some. Oh no, go ahead.
Next project, native HTTP support in C++.
Jesus Christ.
You got any thoughts on that one?
I'm not writing another URI parser. It sucks so much. And using curl for web. Problem is that, yeah, URI parsing is just horrid. I'm not going to get into that. There are HTTP libraries out there, and there is a networking proposal for C++ that is hopefully going to come soon. Maybe not in C++ 26, but at some point. So there is a TS for that. You can look into that. There's a bunch of stuff in it.
If we're
If you're
lucky,
interested
in 10 years.
And it's based on ASIO, so you can just use ASIO until then. Boost ASIO. So this IR inline call function does the actual inlining. The rest is just wrappers around that. So it just grabs a bit of data here. It counts how many instructions the callee has, and so on. So this part is not particularly interesting. Then it checks the history to make sure that we don't fall into an infinite loop, because that has happened. There are test cases for that now.
It's a little cache.
Yeah.
We have, so if the call exists, what is that?
Yeah, you can read that comment there. That sort of explains on line 87. That explains how
If
the
the
history
inlining
works.
of this call can be traced back to the inlining of the same function, then we have an infinite loop.
Basically, if we inline a function, whenever we create a call as part of inlining, we keep track of what function we inlined that got us this call. And then whenever we try to inline that call, if it's trying to inline the same function that ultimately that it came from ultimately, then we don't do that again. And this also goes over, like, it's basically builds a history of what calls were inline via what functions, and like transitively.
Okay. So, yeah, this is keeping track of which call generates which inlined code, basically.
Mm-hmm.
Okay.
Just call instructions, but yes.
And that, okay. And then remove the call from the list and everything after it from the block.
So we just, because yeah, we remove everything up to the end of the block that contains the call instruction, because we'll have to insert that afterwards.
So you have like the stuff before the inlined call, and then like the stuff after.
Yes.
And what we're doing is literally like, okay, remove this and separate these two.
We just remove the instructions. We don't really create a new block or anything, but yes.
Okay, so we just remove it. What does leave everything after it connected mean?
That doesn't mean anything anymore. That was in reference to when they were still at prevent next pointers.
Gotcha. And then we use move to, I see. Whoops. Use move to, I see.
Yeah, that moves all the instructions afterward into the temporary vector. And then this is the interesting part. So the way this inlining works is we will iterate through all the instructions of the callee and copy them individually. But these instructions, and I need to explain this for these instructions, they use other instructions in the callee. So we need to make sure that when we copy them, the instructions they end up using are the equivalents to those instructions in the callee, but in the caller. So basically, if we have an add instruction in the callee that adds two values, when we then copy that add, it has to refer to the equivalent inline, to the inline equivalents of those two values. And the way we do that is we allocate a bunch of instructions up front. We basically create a map from instructions in the callee to the copies, and that map works via an ID. We assign each instruction an ID, and then when we, for instance, want to copy the left-hand side of an add instruction, instead of actually copying the left-hand side, which refers to an instruction in a completely different function, we set it to whatever the equivalent of the left-hand side is in the inline code. So we allocate the instructions up front. That way we can grab pointers to them before filling them in. And the same thing goes for blocks. And then if you scroll down a bit, because that part just sets that up, that's not particularly interesting. We also add the call block as the first block, because that's what we start inserting right after the call instruction. And then we just assign. I'll go over the parameters in a bit, but let's scroll down a bit. Let's scroll down, further,
map.
down, still further. For instance, here, okay, no, down a bit. We can go to add, and so yeah, okay, that's fine. See, where it says copy left-hand side is map of instruction left-hand side, and this map macro just maps the left-hand side in the callee to the equivalent of the left-hand side in the inline code. And we do that for all references. So that's how we copy the structure of the IR, instruction by instruction. And there's a few interesting things here. There's two cases that are interesting, because obviously in the inline code, the inline code can only really refer to itself, because you can't just refer to instructions or other functions, right? So all of that is self-contained except for two kinds of instructions. That's parameters and return values. The way parameters are handled, we need to scroll up a bit more for that. So in here, as you can see, okay, if we read on line 212, we just skip parameter instructions. We don't copy them, because what we do instead is we replace, or rather we map the parameter instructions of the function. And the way we do parameters is for each function parameter, we insert a function parameter instruction at the very beginning of a function. And those are the only parameter instructions, so we know where they are. And we map those to the arguments of the call, which we insert at the end of the instruction list. So we set the indices, or the IDs of the parameters, to where the arguments of the call are stored in the instruction list. That way, any code in the inline code that refers to a parameter is automatically remapped to refer to the corresponding argument of the call.
Yeah. So using the same cache that you used to like say, oh, this instruction should be replaced with this one. We don't insert the parameters anywhere, but we still map them to the already existing arguments. Fantastic. Okay.
And as you can see, we insert the arguments of the call at the end of the instructions list.
In place of the parameters. Yep.
Yeah.
That makes a lot of sense.
Well, not really in place. We just map the parameters to that. It's like, this is very much like virtual address to physical address mapping. The IDs are the virtual addresses, and the physical address is that instruction vector.
That makes a lot of sense.
And the other case is return values. So for return values, if there's only one return value, we can just remove the return instruction, replace all uses of the return value with the value that ends up being returned. So that's the easy case. If there are multiple return values, we need to create an extra block and a phi to collect all of them. That's all there is to it.
That makes sense, yeah.
And we go through this loop.
What is this loop doing?
This just
This
copies the instruction data.
Yeah. Okay. So this is the mapping. That's the return. It's going to be complicated.
And then the uses are also elegant. We copy the uses in one fell swoop, and that is we iterate over all the uses in the original instructions in the callee, and set the uses of the copies to the mapped users, to the corresponding users in the copies. Basically, that was a bad explanation, but so again, essentially, we just iterate over all. Okay, the terminology is horrible. The original code is the code in the callee, and the copy is the inline code in the caller. So the original code, we iterate over all uses of all instructions in the original code and add a use to the copy of for each. Okay, this is horrible to say. So for each user of an original instruction, we add a use by the corresponding user in the copy. It's, you know what I mean. It's horrible to put into words, but you know what I mean.
So you're saying, like, instead of recalculating uses or anything like that, we copy the originals and then we apply the same cache that we did to update backward references
Not a
before.
cache, that's a bad term for it. I called it map in the sense of a map in mathematics and linear algebra. It
Right.
maps between two representations. Yeah, you can get the corresponding instruction via the map. So yeah,
Exactly.
you
Yeah.
just map everything. You just copy the structure and map the instructions over.
Ooh, Peter says, I love how you guys are making this whole compiler project only because you just woke up one day and was in such a mood. Pretty much. Does this language support functions as passable values? First class functions, you mean? Yeah.
Yes.
Yes, it does. There's a downwards funarg test. And upwards funarg is complicated. There's only a few ways to solve it, and they all suck. We're probably just going to do static chain
That's
stuff.
complicated because of like, yeah, you need to refer to the parameters of the variables of the parent somehow, either with, as you said, a static chain or captures and closures and stuff like that. And the main problem with that is returning a closure from a function. That is a fundamentally
Upwards
problematic
funarg.
thing to do. Because static chain pointers don't help with that. Because the variables are no longer live when you return.
Yeah, it's a mess. And I think the real solution would just be like don't allow returning
Don't
those
allow
types of
that.
functions, but
And if you need to, you can create a and provide some way for the closure to copy it or something like that.
exactly, have it where you can do like a Lisp style where you just like contain all of the variables it captures within
Something
itself.
like that, yes.
Or just we could also do something where we like copy the values that happened when the function returned.
That would be captured by value, not by reference. That is also an option. Yes, that's how Java does it, for instance.
Exactly. But I don't think that's good, and I don't it should honestly never be done. But
It's not ideal.
we should
Yeah.
allow for it.
Yeah, we need to, yeah, but that's a problem for future us.
That's
Now,
right.
and then, yeah, we fix it the return value, blah, blah, blah. Then we can delete the call because we're done with it. And we
Hey.
insert the return block at the end of this block list that we have. And then we just insert the blocks into the function after the call block. That comment there, I think, is also nonsense on line 405.
So we've
Or maybe,
generated,
I don't know.
we now have like the copied function body with fixups.
Yes.
And then, okay, so the call block is where we came from.
Yes.
That's
Where
like
it's not, yeah.
that's the inlining, that's the call we are inlining.
Yes.
So this call, the block that it's within, we then just take this copied function body, and it's made up of IR blocks, and we just append those blocks after the call block.
No, not exactly. Instead, is sort of, because what we do is we start inserting directly in the call block. That's the first block. So the first block of the callee is mapped to the block containing the call.
I see now. So this whole block has
Yes.
with this IR remove, it now just contains.
It now just contains whatever the first couple lines, whatever the instructions in the entry block of the callee are.
Okay.
And then what we're inserting is, that's why if you go down to line 416, it says block data +1. We insert everything after the first block, after the call. Because the first block is the
dear.
call.
Yeah. I like the vector span.
Yeah, you can do stuff because vector insert only cares about the name, so you can create these little structures ad hoc here. Just and give them members name and size, and the vector macros just work with them.
Beautiful. I'm not going to go too deep into this, but if the element equals
This
a call
inserts
block,
into the vector call call block function blocks. It inserts the it inserts at the position, whatever the position of the call block is, +1. Because it inserts before.
okay,
It
yeah,
inserts the contents of vector span.
beautiful. Okay, yeah. And then if it's a tail call, we do stuff or we don't.
If it's a tail call, then we remove the instructions after the call instruction, because that's the semantics of a tail call, basically.
That makes sense because
And-
it's supposed to jump away.
Yes, and otherwise we just insert the instructions that we removed earlier. When we append them at the end of the last block that we created here. So after the very end, after all
Nice.
the inline code. And this way we minimize the number of blocks we create.
And then clean up. And done.
And then clean up. Yeah, because we may have allocated more instructions than we needed.
Beautiful.
And that's the entire inliner. The rest is just wrappers around this that do some checks.
Yeah, with some go-tos.
These are just checks, all of these.
Oh dear. Yeah, it's beautiful. 500 lines of C to inline functions.
Mm-hmm.
Not bad.
Yeah, this code is fairly good. This code, I think, doesn't really need to be changed much. The only thing you need to do is if you add instructions, you need to add them here, but that's it. I don't think there's much to improve over this in terms of inlining, candidly.
It looks
Unlike like the
really good.
Dominator tree construction stuff, which is really scuffed right now, needs to be overhauled. But this code, I think, is pretty much done now. We just have a working inliner. Because I don't think there's many ways you could conceivably break this.
We'll find a way if there is, I promise. Man, that's
Because
awesome.
also added tests for some edge cases to make sure it doesn't fall into an infinite loop.
Oh, there's lots of inline tests.
Mm-hmm. This one,
Yeah.
this just checks that it eventually stops inlining. This works. It will inline it a couple of times, but eventually the functions just get so big that it will stop.
Yeah, so it'll like make each one as big as its threshold is and then stop.
Yes. Basically.
Beautiful. What did I do to break? Ooh, return maybe isn't in the tree sitter grammar yet.
I don't know.
I may have not done that. I can see myself not doing that. Yeah, it's just not there. Fantastic. I'll get to it. That's really awesome. So I can't. So it does all that to like one of these.
No. So what it will do is if it starts with F1, it inlines the call to F2. Then I think it just inlines the call to F2. That creates a call. So inlining the call to F2 creates a call to F3. It then inlines the call to F3. That will create a
I
call
see.
to F1. And because of how the inline history works, it may inline F1 itself once. It may try to do that. But I'm not sure if self-inlining is really supported. But either it will stop there or it will stop once it sees F2 again because of how the inline history works, because it tells it to stop because that's recursive. Then it will do the same thing to F2 and then to F3, and eventually on the next pass that then the inliner is done, and whenever the optimizer revisits this, they will try inline. So it will do that again because the inline history isn't preserved across invocations of the inliner, just once locally. But then eventually F1, F2, and F3 as a result of that will get so big that it stops inlining because the threshold is just too high. Oh, sorry, you get too big for the threshold.
That's really
And
cool.
that's also what, for instance, GCC does. If you define these functions, you'll see that both of these they're just inlined a bunch of times until they get too big.
This is amazing. It hurts my head a little bit.
Hmm.
So the optimizer, it's like going in order. It's like it replaces this, and then it checks what it replaced this with for more stuff to do.
Yes.
Beautiful.
You can take a look at it in the code. There's a go to I believe again in not here in yeah there. Start over. We start again.
Yep, after we inline it. Wow. Difference between A0 and A is assigned to 0. One of them is a declaration. So colon and intercept is the type inference operator. So it'll just declare the variable name on the left to the type of the expression returned, or the type of the result of the expression on the right-hand side. Jesus. So if we did like A is assigned to a string, then it would just automatically go, okay, A is a byte array. And you don't have to write that. And that helps a lot. So in this case, it's an integer. And we could change it to a byte or something if we wanted to use a cast. So we could say 0 as byte, or as U8, or I8, or stuff like that. Oh, I can't get rid of it. But yeah, so A colon 0 in any form declares A as a new variable and assigns it to 0. And you don't have to write the type. It's really nice. Whereas A is assigned to 0 requires that A has already been declared, either like this or like this. And then this assigns the value. So you could say that the colon is equivalent, right? You could say like equal to doing the declaration with whatever the type of this is, and then doing an assignment after. Hopefully that helps. This is really bothering me that return isn't done. I might do that, I mean, I have to sleep soon, but I might do that tomorrow. So just...
No, sorry, keep going.
So just A is assigned to 0 would give an error. Yes. This by itself would say like unknown symbol A, because it doesn't know what it is, assuming none of this exists. What were you going to say?
What was I gonna say? Oh yeah, I was thinking about what else could we take a look at.
Ooh, yeah. Wasn't there the, here, what was it? The, maybe I'm crazy. Wasn't there the mem copy? Did we want to look at that?
That's not particularly interesting, I think.
I see. Nothing happened there, I swear. I cannot remember, though.
Take a look at like how like the IR is accessed now.
Ooh, the
Because that's
Opaque API. Yes, yes, yes. Great idea. Oh, we have another question. Can this compiler reject the inline keyword?
well, inlining can fail, yes. And then if, for instance, if you put inline on F1 here, I'm pretty sure it will. Yeah, there's actually a test for that. You don't have to do that here. There's another test for that. It's inline mutual recursion error or something like that. Or just inline mutual recursion. Yeah, that second one.
Nice,
That
yeah.
one fails.
Because it can't always inline them.
Yeah.
Even though it can one time.
Mm-hmm.
So yeah, it can reject it, but it's a compiler error when that happens. So take with that what you will. Yeah, that's fantastic. We were just you just said something to look at. I totally forgot already.
The Opaque API.
Yes, yes.
That's
So
in the IR directory. In ir.h is the public API.
yeah, this is the API itself. So we have, oh dear, we now have some macros, I see.
Yeah, the way these work is they get the value if they are not passed an argument, and they set the value otherwise. So if you call IR alloca size with an alloca instruction. It gets the value. If you pass in a value to, then it sets the value.
Oh dear.
Because I dislike writing get and set in front of everything. It's horrible.
That's fair. Very cool API. Not sure I'm going to ever be able to work on it. What is...
Some of them, it doesn't make any sense to be able to set them so they're not macros, they're just functions if you scroll down further. They're alphabetically. So these are all
You've
the
done it
macros.
alphabetically.
Yes, I always do, typically. So for instance, it doesn't make sense to set the argument call count or something.
Yeah, that makes a lot of sense. Very cool. So this effectively replaces everywhere where we would access the IR thing itself. Because
Yeah.
before we would just be like accessing values directly.
Mm-hmm.
Oh no.
Yeah, there's some macros to automatically declare accesses.
Oh
Just
no.
writing all that by hand is horrid.
Oh no. This is terrifying. I know what you mean though.
This is what you get if you have to use C. In C++, this would be a lot nicer.
Well, what is this?
That's for instructions and functions. You're not supposed to call those directly, so the names don't really matter.
Okay.
The macros call these, the generic macros. Because, for instance, the IR type of macro works on both instructions and functions, and the IR location macro works on both instruction and functions, and so on. So there's several macros that support several types, and for those we have to define the overloads manually.
Dear God. What drew you to do this? Is it just the use marking horribleness?
Yes, I hate use marking. It sucks so much. This is much better than that.
I love looking at stuff like this because it doesn't even look like when I was first starting the compiler, I would never write this.
Yes.
Because I had no idea about these issues, and I'd like, this is such a, I don't know what I'm trying to say, but it's such like an, not, this isn't the right word, but optimized solution.
It's not really optimized so much as it is a clear display of of how sick I am with dealing with users.
Exactly. Yeah. It's like we would never have done this. Like if I feel like if I brought this up as an idea, like instead of accessing any member, we're just going to make everything a function. It would be a little like, do we really need to do that? Isn't that just going to complicate simple things? Like, come on, we're just accessing like two numbers. Why do you need to do this? And it would never happen and it wouldn't make sense.
Yeah.
And then a year into it, it's like, anyways, we redid everything in this way that we never would have expected. And it's better.
By the way, there's like pairs of create and insert functions for almost everything. For some, there isn't because it doesn't make sense to create them to insert them immediately. But basically, the create function just create that instruction. The insert function also inserts it at the current insert point, and the insert function is only really used during code gen, like IR generation, so in codegen.c. Everything else just uses the create functions.
That's very Pogger. So this replaces our like instruction macro.
Yes.
Fantastic.
The implementation of all of this is in ir.c if you want to take a look at it.
I do, but it's gonna scare me. Ah, this looks familiar. So, is there anything in particular we should take a look at?
You can take a look at the instruction. We now have a free list for instruction. That's what that alloc thing does.
Interesting. Somewhere. Here it is. Okay.
There we go.
So this is an allocation instruction or an allocation function that returns an instruction. And it will either
Okay.
oh. Yeah.
From IR instruction to just inst just in this file because I got tired of writing IR instruction everywhere. It sucks. I hate long type names so much.
Yeah, that's fair. That
Or long
makes a
names
lot
in
of
general.
sense in this case too. So I'm now getting it. So if we get rid of an instruction and then allocate a new one, this will just use the one we got rid of, never free it, and then we just reuse that memory.
Mm-hmm.
Beautiful, beautiful, beautiful. Also, Joseph Caceres, thank you so much for the follow. Beautiful stuff. And then the same thing for blocks and functions, I presume.
Not functions, no, just blocks, because we don't create that many functions that free list is worth it.
Yeah, that's a good point. And not like throughout the lifespan.
Just blocks and instructions.
Yep. Beautiful stuff. That's really awesome. This is all going to help so much.
Mm-hmm.
We're going to, this compiler may actually be usable soon. Like we may be able to write programs that like do more things than just like compute a silly number.
Mm-hmm.
It's going to be fantastic. Oh no.
This is just to make sure the free list doesn't get too out of control. If it's too big, we free half of it.
That makes sense. Is it faster than Rust? Yes. Nylon Dude says
Faster than Rust at compiling intercept because you're going to have a hard time compiling intercept with Rust, seeing as there is no Rust compiler, no intercept compiler written in Rust. So I suppose it is.
that's also what I was going to say. Like, Rust isn't faster doesn't mean anything. You didn't specify Rust the programming language either, so.
It's probably faster than Rust the video game, yes.
And iron oxide.
Yeah.
Is it possible to compile Hello World in it? Of course. Oh yes. It's been that way for a while.
We have an example probably.
I think I got rid of it because it was too simple and it moved to like string literals to teach people how it works.
I see.
But yeah, here's our Hello World, like very, very minimal basic one. And it basically just calls puts. We're still working on the standard library in that we haven't started it yet. But modules exist now, so we should be able to.
Should be able to, that's true.
And really, if we get that libc wrapper like started, then it's just going to be like huge from there, where we can just start writing tons of programs.
There's two ways of doing that. The scuffed way that is easy to do, and the better way that's harder to do.
We should probably do the better way.
One way is we just the way what we're definitely going to do is we're going to use Clang or libclang libtooling to pass C headers and generate definitions from them conceptually. There's two ways of doing it. One is to just link the compiler against Clang, and just whenever we have and just allow importing C headers or something like that in intercept, and then that would just call into Clang to pass it and generate the type information, everything in memory, so we can just use it.
I don't like that
That's
one.
one way. That requires linking against libclang, which might be, or libtooling, that's actually called, which might be a bit more complicated. The other option is to just write a standalone program that can pass a C header and emit code using it.
I think
the only problem with that approach is that if the C headers have platform-specific things in them, then that's not going to be cross-platform. And then you'd need a version of the tool anyway to generate the headers locally. If you can compile the tool locally, we might as well merge it into the compiler. That's kind of the thing.
What if we just like used that to start? Does that make any sense? Like write the program that converts the C headers into like basic intercept syntax. And then just use that as the beginning of a code base that we then manage manually.
I suppose, yeah.
Because I don't see the C library changing in like drastic ways.
Less about that and more about what is the definition of VA list in this system and stuff like that. Because that's different
And
depending on your platform.
yeah. So variable args aren't something we've even tackled yet. So
That is a specific thing that's a bit problematic. But if it might even be things like what is the size of time t on this platform, or stuff like that.
right, and that's all like autoconf stuff.
Yeah, stuff like that.
Yeah. Yeah, there's not always great solutions to
You
that.
literally want to create C pointed diff t, C time t, and etc. We're definitely going to need C
No.
long and C int and all of that internally, but
Yeah, that's fine.
that's already bad enough.
Yeah, I think yeah, it's gonna suck.
Mhm.
That's fine though. It's yeah, we'll cross that bridge when we come to it, I guess.
Mhm.
For now, we're
And there
just
are
gonna
some
start.
limitations because macros would be annoying with some like I'm gonna need to look if there's a good way of like converting macros into constants and stuff like that for like no values and stuff like that.
I mean, we'd probably just have them like defined as constants instead of macros, right?
Yeah, we need to iterate over the macros aren't in the AST. You have to find them first. So,
That's right.
but yeah, I'll look into that. I've done stuff like that before, so it shouldn't be too hard.
Beautiful stuff. Beautiful
Main
stuff.
thing is what happens if we run into things that we don't support currently, like flexible array members is always the big one, and also unions, because a lot of stuff uses unions. Unions are the most common problem. The other one is bit fields, flexible array members, and unions are the 3 problem points.
I know it's not nice to use right now, but I think we're okay with unions because we're able to do casts as long as between structs, as long as the sizes aren't
Well,
bad.
the problem is we need support for unions in intercept because I'm not
Why?
doing how the hell like you'd have to manually that would be horrible to do otherwise.
That's what
It
I
doesn't
just
really
said. I said it'd be
how
horrible and it's not really usable, but technically we
yes.
can do unions.
I can replace a union with a byte array. That's all that can do.
Right. But yeah, you're right. We should have unions. We should add those. And honestly, it shouldn't be too difficult.
Yeah.
I don't remember structs being a pain.
Unions are not that complicated, no. It's just doing more manual stuff and we're doing everything manually anyway, so
Perfect.
what was I gonna say?
You were going to say
Unions,
thank
yeah.
you Nylon dude for following.
The other two are bit fields, which that's a problem, and flexible array members is the other annoying one.
Well, bit fields just don't and write an accessor. And then flexible arrays is just don't include that member. And then it's just, you know what I mean? Someone who needs to use it will go,
Oh, yeah.
oh, just add this, add the size of
Mhm.
this type, and then you'll find the flexible array.
That works, yeah. You just can't access them and intercept them.
Yep. I'm not looking for like huge FFI between C and intercept. I just want intercept to actually be able to function. Like calling between Python and C isn't like as easy as intercept even. So I think we're already doing relatively well there, and everything we do is just quality of life. So that's perfect. I think that big green button is looking pretty juicy. What do you think?
Yeah, I think we can merge this now. I think it's fine. A few things need rewriting, but that's always going to be the case.
Yeah. we could go until it's 10K, but I'd worry for your sanity. All right. Any last words?
Not particularly, I think. We're good to go.
All right, I'm gonna go with peanut butter and roses. Hey,
Nice.
it didn't explode.
Hmm.
And then we have another one. which is just the syntax highlighting fixes by Indecent Labs. How amazing.
I'm pretty sure this is missing flatten because I didn't include it, and also memcopy because that's a late addition, but the other ones are still fine.
Ooh, he did
Oh,
add flatten.
they did figure that out. Nice. But not memcopy apparently. But
Yep.
I added that like literally like yesterday or something, so
We'll get to it. Perfect. And this
good though.
this does pieces of Emacs and then most of it in Vim. Beautiful. Yeah, so we got inline and Emacs, and then in Vim we have inline, no return, no opt, const, peer, used, flatten, and built-in syscall, line, file name, debug, trap, and inline. Whew. Thank you, Indecent Labs. Merged. Howpog. Also, wasn't there an issue that you opened?
The ISO issue, yeah, but that's a longer one.
Oh yeah, I did whole messes of things I remember now.
I'm gonna leave that part to you.
Yeah, I know.
1,300 commits, almost 1,400.
That is impressive. We're coming up on, it's kind of scary. The compiler's gonna pass Lenser OS very soon. If I don't do anything about it. Lenser OS is just over 1,500.
Even if you do something about it, I can't guarantee it won't pass it.
I see how it is. I see how it is. I gotta start no, I gotta sleep more.
The thing is, I'm also at the point where I want to implement importing C headers for my compiler, so I might just make this a library sort of that does that in a way.
Nice, yeah, that we could both just use.
Yes,
Be
because I'd hate
fantastic.
to rewrite that twice. That would be annoying.
That would be horrible, yeah. I would never want that for you either. That sounds awful.
I kind of don't want to write a C API for it though, because the problem is it's going to be in C++. So that may be a bit annoying.
Well, yeah. So my part will be writing the C wrapper that we use from Intercept.
Sure.
Or from the compiler.
Either way, we could just rewrite Intercept in C++, is all I'm saying.
We could.
That would make a lot of things easier.
It would make some things easier.
It would, like, if you look at ir.h.
Here. I just found a thing. I gotta fix this link, and then we'll go to ir.h. Mr. Mugabe says no C++. I'm shaking.
Yes, C++. You can look at the atrocities I've committed in ir.h and look at that and then tell me that C++ wouldn't be better. Also think Emacs is hanging.
Yeah, something's happened. Oh, there it goes. It just it got embarrassed. Okay. Fixed. Where am I going? ir.h. Where
So
are we
you
at?
can let's take a look at this. Not this. This is just looping stuff. This is also horrible. That would be fixed with iterated. But actually, let's look at this. Yes, this is what happens if you don't have iterators. I could replace this with bounce check type, like bounce checked, iterate and validation checked iterators. And you could just use a range-based for loop, and it would just work with none of this nonsense. You could just write a range-based for loop and it would work. That's the first point. And you wouldn't need any of this nonsense. Let's scroll down. That's just the start. Let's take a look at these are just helper macros. These are horrible, but the use of them is. Let's take a look at IR. Let's pause for a second and take in the IRID macro. Just take a look at that for a second and try and figure out what that does if you're not familiar with how any of this works. So can you tell me how this works? Not what it does, but how it works.
So we have a generic, which means we need a type to match on, and then it will run code based on the type.
Yes. An expression will match on the type of that expression, but yes.
And then we're using VA first here. So I think that means that the first one that we give, it actually does the type of that and matches on that or something?
Yes, the reason why this exists, VA first is a macro that takes in a variating argument list and returns the first one.
Right. And then if there isn't anything, right, then
Yes.
we'll end up with a null pointer to a no generic argument type, which is being used as a flag to yet another generic, or actually this
Yeah.
generic.
Mm-hmm.
And then it matches and says, oh, this whole VA first thing resulted in a no generic argument pointer.
Mm-hmm.
And then we do another generic, and if there's no generic arguments, aka no ... then that means that for an instruction, then we call get, and for a block, we call get for the ones that we need,
Mm-hmm.
which means that when we use IRID, we need to like, it'll like, the generic
Yes.
expression will basically apply, right? Apply this function using the argument. Does that make any sense?
If you understand how generic works, it makes sense, yes. If you
Okay.
don't, then I'm pretty sure a lot of people are probably somewhat confused by this. If we just used C++, we could write 4 member functions and that was it. That would solve that.
That's true. By the way, the default is if we do pass in a generic member or generic argument, in which case then we will call set, and then it'll kind of curry its
And
way
what's
through.
important here is that the argument list has to be at the end. Because if you put it inside the generic, all sub-expressions have to be valid expressions, but you can't call, for instance, IR, ID, B, impl, get with an instruction and an ID. So that's why the arguments have to be outside the generic, because if you put them inside, it doesn't compile.
Yeah, so it's simple. It's one big generic that results in a function, and then we call that function.
Mm-hmm. There's a one that's almost worse if you look at the Dominator tree code.
Oh no.
It's the at macro there. You already saw it. If you go up, that on line 49.
Nice.
It's brilliant, isn't it?
It is.
If we look at on line 52, if it's an IR block, if I is an IR block, then on line 53, we cast I to an IR block. That looks completely deranged, doesn't it? Why are we casting it? Well, it's because if it's an integer, this code still has to be valid, but you can't call block to ID with an integer. So in order for it to still be valid, even though it's never going to be selected, for it to still be valid, in case this is an integer, we need to cast it to a block pointer. That will issue a warning, which is why we disabled the into pointer cast warning initially with a pragma that used to be in here, but GCC didn't like that. So all of this is just a whole lot of nonsense. Generic in C is the best thing we have, but it sucks. It is horrible because it doesn't discard non-selected instructions, unlike if context were in C++ templates in C++, which does discard non-taken branches for obvious reasons, which is how it should be.
I mean,
But for
I
some reason,
agree.
they decided in their infinite wisdom that they weren't going to do that.
C++ does have more like high-level stuff that makes it easier. But I think that's also why I don't want it.
So you don't want it to be easier. You just want everyone to suffer, is what you're saying.
Yes, because I'm a masochist. No, what I'm saying
I'm
is
not.
that I don't want it to be easier at the expense of going high level. I want everything to be low level.
Okay, then go back to IAutoH and tell me that. Go back to IAutoH and tell me that this code that's in there isn't at the expense of something. Like, just take that in for a second and tell me that this is perfectly readable, low level, and understandable code.
I mean, I can't. I'd be lying to you.
That's the point.
But
Explaining overloading is much simpler than this nonsense.
yes, that's my problem.
Overloading intercept. We haven't implemented this nonsense.
Right. So it's like intercept is meant to be like a low level language as well.
Yes, and it's already more high level than C because it has overloading.
And that's my point. Like, if we were able to have just a few extra features in C, like function overloading or binary operator overloading or stuff like that, it would become so much easier to do so much stuff. And it
Yes,
would
there's
be
a language for that
fantastic.
called C++.
No, it's not, because they change everything else. Them damn iterators.
Iterator, go up a bit.
I know.
What you see up here is basically iterators. This is how iterators work.
Yeah.
We have a begin and end pointer. This is iterators, just horribly implemented.
Right. So that's my point. In like, by understanding the fundamentals of iterators, you're able to write this low level code that does iteration. I agree that just writing like for a ranged for loop is 99% easier and simpler and more readable. It's just not low level or like understandable what's happening. Most people don't know what a range based for loop, even how it works.
Well, you know how it works, and
'Cause
you and I are currently the only ones really working on this project, so it would
right.
only really matter to us. Like, if your
Well,
argument is that someone else couldn't come in and understand the code, I'm again advising you to look at the generic macro below. Because someone who doesn't know C very well is not going to understand a single thing about what's going on in there.
Yeah, no. It's not about that.
Because I also had to, when I implemented this, I forgot for a second that I had to add VA first, and I wondered why it didn't compile. So I had to remind myself how this horrible trick works because it's just too goddamn complicated.
And I see your point where it's like, if it was just for us, we would just switch to C++. But
If it was just for us, we would just switch for C++. If it wasn't just for us, then this code is also horrible, and we'd have to change that too to be understandable.
well, here's the thing. It's not. It was a compiler. The original scope was like compiler from scratch in C, right? So it's like, if this is what it takes to write a compiler from scratch in C, then this is what needs to be there.
Well, this is why I wouldn't write a compiler from scratch in C.
Exactly. And that's what we're also going to prove to a bunch of people. Imagine how many compilers are going to be written in C++ instead of C because they watch this video, they skip ahead, they see this code, and they go, oh my God, that's so stupid. That's crazy. Why are they looking at random symbols on a page? I never want to do that. I'm going to write C++. That's like the effect we have, right?
I have a counter argument. Instead, you could just write C++ that looks good and easy to use.
I agree. I would rather have one, like,
Would rather have
maintain
horrible C than nice C++.
for this project. Yes, because it's like, in general, C++ does make everything easier to write, and anything you can do in C, you can do in C++. So why wouldn't you?
Mm-hmm.
But from this project's perspective, why wouldn't you? There's a lot of answers to that question, at least in my mind.
I don't know. I don't really have one.
Right. But you aren't all the viewers.
No, I'm the one implementing the stuff.
Exactly. Which is why it sucks more for us. Because we actually have to do it and show people this is what happens when you do this stupid thing. Right?
So we should stop doing the stupid thing. And now that we have shown that it's a stupid thing, we can show that we're capable of learning from our experiences and that we know how to make it better.
Well, yeah, but that's going to be like the when we either like write the intercept compiler in intercept, the other project.
Which is what you don't want to do.
I don't want to we talked about this before more extensively. We came to a middle ground. I don't want to replace this project and this compiler with an intercept one. I don't want to start rewriting. But I'm okay with writing.
The problem also is that is still a bit far off because self-hosting a compiler takes a lot of features to do it decently. Like, we could probably do it now, but it would be absolutely atrocious.
Exactly.
It would be much
it wouldn't
worse
be
than
worth
this,
it.
and this is atrocious.
Right. So imagine that by using these atrocious features to implement non-atrocious ones, right? We'll end up with a language in which that isn't atrocious, and we can escape this horribleness eventually.
Eventually.
And then, and then it's like, oh, if we add a language feature, I'll probably go back and fix this compiler and add it to this one. But most of the time, it's going to be the intercept one, right? Because then at that point, it's going to be about, like, what if we add a new language? What if we add 3 new languages? What if we add, etc.? I don't know. And then there's going to be the whole other thing of I'm going to be writing a, like, toy compiler, like a little one, for the tutorial series.
Mm-hmm.
Also in probably C++.
Mm-hmm.
So, there will be a chance to show how to do it the right way as well.
My main problem is that this just sounds an awful lot like just the sunken cost fallacy to me. Because it sounds to me like the argument you're making is we've already come so far, we might as well continue. But the thing is that if by continuing we just end up writing more horrible code that is horrible to deal with, because the thing is, this entire thing, I mean, a rewrite here was necessary because of the internal invariance of everything, but the rewrite would have been a lot easier in C++. I could have just used member function instead of this nonsense. But even now, like, adding new stuff to this is pretty horrible. Like, it's not going to get its use marking is handled now, but as a result, what you have to do to actually use the IR anywhere is a bit horrible now. And also, candidly, the only reason why I was even willing to do this is because I know that the horrible amounts of performance loss that we have just incurred by this refactor can be remedied with LTO. Otherwise, I would have been very hesitant to do this, because now the performance is just crashed because everything is a function call now. So this fixed bugs with use. The thing is, it's better than it was, but that doesn't mean it's good now. It's just that it was so atrociously hard to deal with before that even this sounds like a reasonable alternative now. And I'm not sure that that's a good point to be at. And I don't like being at that point. I'd rather be able to write code that is nice and easy to deal with than this. I mean, just look at the IR property macro. Just look at this abomination.
So here's another thing then. There's going to be, like, let's say we just start allowing C++ in the code base. All of this code is still going to be here and we're still going to have to use it, or eventually figure out how to replace it in C++.
Replacing it in C++ wouldn't be that complicated.
But here's the thing. It's like, it's not that it would be complicated to replace. The thing is, at that point, we're going to have to write worse C++ to interact with C. That sucks. That we know sucks.
Better than this.
And I agree there too. It is gradually better.
What did I come back to?
We're debating. So what do you think? Which language?
Which language for what?
Eternal is once again asking for my cooperation in converting the code base for intercept into C++ instead of C.
That sounds like way too much work this late into the project.
I just did an 8,000 line PR. You can't tell me that would be too much work.
Yeah. We've invested so much work that isn't even an option, a parameter anymore. There just is work.
Yes, and the thing is also that it would be too much work, or that we have already invested too much work, is just the sunken cost fallacy. It's not an argument.
Yeah, but it's a good sunk cost fallacy.
That's
sunken cost fallacy is never good. I've had to learn that way too often. Like,
it is if you want to be stubborn.
Yes, I'd rather not be.
I don't know. So Mr. Mukame brings up a good point. Every compiler is written in C++.
Yes, for good reasons.
Well, no, not necessarily. And even if it's for good reasons, it's like, well, some pro Like some experts in their field don't do the things that's most recommended because they choose not to. I'm not saying I'm an expert in compiler development. I'm just saying in picking languages.
Sure, but the thing is, experts in the field would probably also not do something that is obviously worse than what they could do instead.
But they do.
No, not if it's clear that it's not a good idea. Like no one would. If you need to calculate if you need to write a function that calculates Fibonacci numbers, no one is going to write the doubly recursive one, except to teach that that's not a good idea.
Okay, counterpoint. Everyone in maths uses Python to solve complex problems and runs programs for 3 months instead of just writing it in C sensibly and then or C++, just a low-level compiled language, and then having the program run for 5 minutes.
Yeah, that's mathematicians, not programmers. They're not experts in the field of programming.
They're experts in the field of solving mathematical problems, and if that's how they choose to do it, it's not the ideal way.
With a computer.
Okay. I'm just saying, like, doing it the best way isn't always the way to do it.
I'm not saying that it's but what I'm saying is that if there is another way of doing it that is obviously worse, and there are no good reasons for doing that, then there are no good reasons for doing that, and that is what I'm arguing here. There are no good reasons for doing this.
There are good reasons. You just don't feel them directly. I understand that. I only know tactics as, what about Haskell? That's a good point.
What about Haskell? Sure, if I understood Haskell, maybe. Haskell is too complicated for me. And also, I will sort of agree with, I will cite Tsoding here, who recently has taken to call functional languages like Haskell comp-soy languages instead of comp-sci languages, which I think pretty much gets the point across there. I don't really think you could really get stuff done with Haskell unless you're really into Haskell, and I'm not.
So you are a milk drinker?
No.
Haskell was written in C, though.
I'm pretty sure the Haskell compiler is written in Haskell.
It is now, yeah.
Well, the first Haskell
maybe, sure.
Yeah.
C. Mr. Mukme says that's for math people, and math people are smart. See? Sassy Fajita. Ooh.
I like tensor calculus and differential geometry, and that's about my that's the only thing I like about maths. So
Sassy Fajita brings up a good point. You're just giving up. The sunk cost fallacy is just an excuse for giving up.
Because it's atrocious. I am giving up on this almost because it's atrocious.
Yeah, I kind of agree with you there. I get the feeling.
Yeah.
Because I'm at the point there, I passed that like a year ago with Lenser OS, where it's at this point, I want to give up.
Choose between giving up and struggling in vain, I'll choose the former. Because then I can use my time better to do something else.
That's right. Whereas I don't value my own time very highly, and I'll spend it doing jack shit. As long as I'm making progress.
I very much loathe wasting time. I can't stand it. Like if a project gets to the point where I feel like I'm wasting time, I'll stop.
That's fair. That makes sense.
And that's also why, like, sometimes I start writing something, like the typical programmer, what is it? Not fallacy, not stereotype, is that a programmer will spend 50 hours automating something they could have done in half an hour manually. When I sense myself that it starts getting to that point where I start implementing a tool just because I feel like implementing it, but I'm not getting anywhere because that tool is fucking complicated and I could just use an existing tool instead, I'll just drop it and use an existing tool instead, even though it's maybe not exactly to my liking, because at some point I just get too sick of implementing something I don't even really... Well, with compilers it's different. I like writing compilers, but if it's something I don't even like implementing, then I have even less of an incentive to keep working on it.
That makes sense.
It also depends on what sort of code you're writing. Because if you're just writing mainly a dominator reconstruction algorithm, I don't think I particularly care about whether you want me to write that in C or C++, or even like the optimization stuff, because you're just iterating over stuff and replacing. It's not particularly interesting code. Where I care about it is when it comes to vectors, maps, and code like this. code like this, which is horrible to write in C++. C is a decent language for stuff like, I don't know, just adding a bunch of numbers and maybe moving stuff around or whatever. But as soon as you need things like strings, collections, and an effective way of manipulating them, that is where C just goes out the window, where it becomes just horrible to deal with. Because it has no. The C improves on that because the whole point of the STL is that things can be combined with one another. You can take an algorithm and combine it with pretty much, not every, but pretty much any container, and they will just work. You can use find on a map, on a vector, on whatever. Maybe not on a list or something, because lists suck, but you get my point. You can combine the things, and they're not just monolithic little objects that you can't reuse for anything else. In C, you don't even you have to somehow jerry-rig generics into the language with either macros or the abomination that is generic. And generic in C isn't even a good generic because of the entire problem that it doesn't discard not branches that aren't taken. And if you don't understand why that isn't, I'm not saying you don't, but if you don't understand why that is a problem, then you simply haven't been using generic enough, because trust me, it is absolutely horrible. And it's very hard to write anything other than simple overload, function overload wrappers with generic because of this problem.
Yep. You basically nailed it on the head there. It's hard to do anything except write function overload wrappers with generic.
Mm-hmm.
So I agree with you. And I've been thinking in these past 3 minutes. This is part 2 to the 5, right? Part 64 of this compiler series.
Yeah.
2 to the 6, which means Jesus.
Oh, you were saying 2 to okay, now I get 2 to the power of 6. Now I get it, yeah.
So at this point, I think I may be okay with expanding.
Mm-hmm.
So if
Because it's
here's
also
the thing.
Okay, no, keep going.
This series has gone on for a long time now.
Mm-hmm.
And there's a lot of videos in it that I think is more than anybody will ever watch in their lifetime.
It is pretty long, yes.
Especially Dapster rewatching the same episode over and over again.
I know.
I forgot what happened 30 minutes ago.
He's gonna, yeah. He's got some time. He's gonna get to episode 10 when he's 40.
And then back to episode 1 when he's 41.
Because he forgot. That's so good. Just for the memes, I'm gonna throw one word into the room: rust. Oh no, Mr. Mugume, what have you done? So
still better than C.
It's come a long way. And I would, maybe it could be argued that we did write a compiler from scratch in C.
Yeah, I think that's also an argument that that's what I said earlier. You argued that we could be demonstrating that it's not a good idea to write a compiler in C, at least not like this. And I agree. If you just look at your screen right now, I think this point has been pretty well demonstrated. If this is why, if trying to write code that is not absolutely horrible and completely repetitive leads to you writing macros like this, then you should probably stop and reconsider your life choices, which is what we're doing right now. And regarding the compiler series, you could just say, okay, this is version 2.0 or something now, and like start with a new series.
Take all of your learnings and make intercept 2. Yeah.
Well, the intercept wouldn't change, but the compiler implementation would change.
So Mr. Mugume says, I think it's just a question if we are here for the adventure of creating the compiler and language, or if we're here to really create a usable language. Okay, I want to add on that.
The language doesn't really have much to do with the implementation language, but...
Exactly. So I think that Mr. Mugume is hitting the nail on the head, in that is exactly my hang up with this problem, is it's like, I don't want to just like shoot ahead for like, I'm going to create the next best C. Like, I don't want to be like Nim or like be like, yeah, we're here to replace C. That we're gonna make an awesome language and it's better than yours. Like I hate that stuff. But I really like writing the compiler and like working on it. So I just focus on that being the adventure, and that's what we're here to do, is like to write it.
Mm-hmm.
But at this point, what's kind of becoming clear is that it's becoming less and less of an adventure and fun to actually write it.
Yes, that is, and actually, it's interesting because that point that Mr. Mugumi brought up, I'd say either way, switching to C++ would make sense, because if you want to make a usable language, well, you want implementing that language to be as straightforward and easy as possible, so you choose the easy route. And at the same time, if it's just for fun, well, I wouldn't say implementing this was fun. Just refactoring this took 3 days, I think. It was pretty painful, and it was a single. You could if you take a look at the branch of the PR, it's a single 4,000 line commit, like 4,000 lines added, 3,000 removed, because there was just no way of splitting that up into smaller commits.
And there's
Because
no
it's
saving
all
grace.
changing so much.
Yeah, it's always changing. And there's no saving grace of like, oh, but it's educational because you learned a lot along the way. All those changes were like just tedious, like monotonous
None of this
changes.
was anything interesting. The only thing you'd learn from that is how to use generic in C, and that is neither particularly worth learning about nor something you ever want to be. Like if you find yourself using underscore generic, that's the point where you stop and switch to C++, because that's the point where the language itself is telling you, please stop, this is not what I'm made for. C is for writing device drivers, not this. And in a device driver, you don't need this underscore generic and all of this. This is a compiler. Unfortunately, it would seem that it would seem in a compiler, you have two things a lot: vectors and lists and graphs. And dealing with either of those in C is not fun. And strings too. And it just keeps going. So state, a compiler is just a giant ball of state. And dealing with state is what C is not particularly good at.
Yeah, it's horrible.
And especially not just a bunch of random state, but state with a lot of invariants, to the point where LVM's codebase, for instance, has asserts, is littered with asserts, because it's so easy to get stuff wrong. And doing that in C is it certainly does not help.
What if we put some limitations on ourselves? Because here's what I don't want. Let me describe a scenario that I'm picturing very clearly. I'm picturing a lot of colons all over the place, and there's way too many. So can we start off with like writing C like C++?
Counter argument, scroll down a bit, please.
Yes.
Do you see how all these functions are prefixed with IR?
Yes.
Because not doing that would be insanity. Would you agree with me? If we just called these funcregs in use or something.
That would be incredibly difficult.
Yes. The whole point why namespaces exist is because you remove the IR underscore and you put all of this in the IR namespace, and then everywhere outside, the only thing that has changed is that instead of an underscore, you now need 2 colons. But inside the namespace, you can omit the 2 colons. That's the whole point of namespaces, is so you don't need these prefixes anymore. Everything in IR is prefixed with IR. Everything in opt is prefixed with the opt. Every machine IR struct starts with MIR. Everything in the register, like, it keeps going. Everything in x86-64 starts with x86-64. Would you like me to go on? All of these things are clearly namespaces, just in a language that doesn't have namespaces. So all of these things in C++ would just immediately become namespaces because they're already namespaces, just scoffed, because C doesn't have namespaces. You have to do this instead.
I was referring to inheritance. But I see how you could get confused. Well, that's my point, is we don't need it. So can we avoid the C++ features that we don't need and just use the ones that make life easier?
I don't really... Okay, the only thing you could conceivably use inheritance for is because the thing that C++ isn't particularly good at either is variants, but at least it has them, unlike C, which only has tagless unions. So there's two ways generally of implementing something like an AST or an IR instruction. One is the one that we're doing here, just have a variant with all the data. That would be the same in C++, except that use a standard variant and provide some convenience functions. I like to call them is and as to check if a variant is of a type and cast it if it isn't. But the main problem with that is still that this gets annoying. I'll show you why it gets annoying, because that's the approach I've implemented in my compiler. And that gets annoying in its own regard because of this. Hold on. Let me show that to you real quick. I'll show you a screenshot because
Okay,
this is all over the place in my compiler and it is horrid.
What's
I
another
hate
C++
it.
thing?
Hold on.
We shouldn't
Hold on.
use.
Where's the problem with the fundamental problem with as everywhere? Not cast as. Hold on. There. It's this goddamn pattern that is so much of an anti-pattern that is in the entire code base of my compiler. Just maybe you can pull that up on screen or something, and I can on stream, and I can talk about this because this is atrocious. Hold on.
I was gonna say, where is it? AV9, thank you so much for joining the Discord.
In the general VC.
Okay. Fantastic.
This pattern. So what's happening here is we're making a tuple. Tuple is a tree, like tree is like a node pointer intercept. That's the main AST thing. And tuple has a variant that contains all the AST node specific data. And with as, you get a reference to that data. But the problem here is now you have two variables, one for the shared data and one to access the tuple specific data. And this is everywhere. Every time you need to access both shared data that every AST node has, as well as node specific data, you end up with this thing here. You have to create two variables, one to access the data, one for the shared data, everywhere. This is everywhere in the. I can't stress how annoying this is. This is everywhere in the code base, in the parser, in CodeGen, in Semma, everywhere. It is so incredibly annoying to deal with.
Inheritance.
And that is the fundamental. No, that's not inheritance. This is variance. This is if you use variance. Because now all the trees have shared data and all the tree specific data is in a giant variant. And you have to get a reference to the tree tuple thing in the variant. Whereas if you made this inheritance based instead, you could just use the same pointer because you can access base class members via the derived class pointer. So the fundamental problem here is that it's already bad in C. I mean, in C, it's obviously worse. This is at least better, but it's still bad because there is no good way of doing variants in C++ because C++ doesn't have variants. It doesn't. It has union, but union isn't the proper variant. It has standard variant, which is a library feature, which is never going to be as good as a language feature. And that's it, basically. It has no... It doesn't have language level pattern matching yet or anything like that. There's proposals for that, but the earliest we might get something like that is C++26, and even that is like, I don't know if we're going to get it that soon. So until then, until we get something like that, using variants in C++ is just fundamentally hard to do. And this is, by the way, the easier way. I made this as function. In C++, the default interface is standard holds alternative and standard get, which is absolutely horrible to use. So what I'm saying here is that using variants in C++, you have standard variant when you need them. Sure, you can use them, but using them profusely is painful because there's also no good way to, like in intercept, we can do a switch statement on the node kind. In here, how are you you can sort of do that if you create a template that converts the variant index to the type, but
Yikes.
then you still need to create a variable that actually references the data, and you still need access to the shared data. So there isn't the only other ways of matching variants is either to use standard visit, which is a pain, whether you implement it yourself or use standard visit, a bunch of overloads, a bunch of the lambda overload set pattern, which the fact that exists clearly shows that we need pattern matching because that is already complicated enough to explain and annoying to use. And then there's the third alternative, which is if const expert chains. I've used all of these. None of them are particularly fun to use. So that's why an inheritance-based approach where you have one base class and then each node is a derived type from that thing would allow you to just act. You still would have to do the downcast. It's the same thing. You also need to do an as access here to get the data. So you need some sort of cast anyway to get the specific data. But now, at least you could use the same goddamn pointer to refer to both the shared data and the class data. I mean, still, even then, a switch state over inheritance is still annoying. But then, at least with the inheritance-based approach, you would have to use a custom tag anyway. You wouldn't be able to use standard variant anything, which has its own tag. So you'd have to provide your own tag, and you can switch on that tag at least. So that would be easier to deal with than using a variant. And the other main reason for using inheritance instead of a variant is the size of a variant is always obviously the size of its largest member. So what you end up with is that in intercept currently to represent let's take my compiler. In my compiler, the size, let's take a look at the size of a tree. Hold on, if I can find this thing. Struct tree, the size of, come on, a tree is 424 bytes with the variant-based approach. The variant data itself is, let's take a look at that, 336 bytes. Why? Well, because my language has variants and templates and everything, and some nodes simply have all of that state, but a single number doesn't. So in my compiler currently, to represent a single integer AST node, you need 424 bytes. 336 bytes of storage, which includes the tag. So if we say are generous and say, okay, that's 16 bytes of actual data, we have 320 bytes that are unused. That is another big problem with the variant-based approach, and why fundamentally ASTs are better expressed, as I've found, via inheritance hierarchies, because it's inheritance in that sense is basically like a variant but dynamic.
So
the only thing you wouldn't be able, almost done. The only thing you wouldn't be able to do with the inheritance approach is directly overwrite a node, like what we do sometimes in intercept, where we just overwrite the node data with something else. But the thing is, you don't really do that ever. You replace nodes with each other, but you never just completely overwrite a node. I never need that in my compiler, ever. So I'm pretty sure you could definitely use an inheritance-based AST with this and just never have to rewrite it. We would be using way less memory in the long term, and it will probably end up being easier to use than the variant-based approach. Like, I'm not saying full OOP style virtual function or anything. No, I wouldn't be using virtual functions. I'd just make a giant switch case statement in every member function, because we could switch on the node type that'd be stored separately. I'm not saying polymorphism, virtual functions, abstract everything, just inheritance hierarchy for the sole purpose of copying the things that need to be in every goddamn node anyway into each child node. That is my main reason for using inheritance. It's literally just for concatenating structs. That is pretty much all I use it for. I don't really use virtual functions or any of that nonsense. So that is my opinion on inheritance versus variance in C++.
what about
Either approach would still be better than this, though. What we're doing right now, just so you know. Anyway, I'm done. Now you can talk.
why? So here's the thing. Here's my issue.
Mhm.
I have like 3 things.
Yeah.
1, I don't like solving C++ problems as much as I enjoy solving C problems. Like, seeing 18,000 lines of template error doesn't make me go like, ooh, I can't wait to find what this template error is. I just go, oh, it's a stupid template error, and they're so stupid they can't show me how to solve it or where it even
Sure.
comes from. So now
I'll
I have
take a
to
look
do all
at
this
those.
work. Right. So then the thing is, it's just like I would enjoy working in C++ much less, even if things are easier, if that makes sense.
I mean, do you enjoy debugging the variant, the like macros that are currently on screen?
I haven't done it yet, but I
Yeah.
presume I would at least understand how to. Whereas with templates, it's like you have to be a goddamn wizard to even understand what ... means.
Okay, admittedly, that one is syntactically quite horrible. That's what the main problem with it is. But understanding template instantiation fundamentally, I'd say, isn't that hard. Sure, you can get some horrible. I've talked about this. Oh yeah, I talk about this in my dissertation. But there are a lot of problems with how template errors are typically presented in C++. Sure, and you can make that a bit better with concepts, I suppose. So that would be an option. But yeah, templates always have the problem. But I don't even think someone in chat is also mentioning concepts might simplify template errors. Yes, they do. They do. And we could use them for that. And the main thing is, if you're worried about that, variant is going to be a nightmare for you because the implementation of variant is of standard variant is going to be a horrible mess of recursive templates.
Yeah, and we should never use it. I hate it.
It's horrible. So I wouldn't be that's also another part for a reason for using inheritance over standard variant. But the thing is, I don't think we even need. Sure, I like to use templates, but I doubt most of them would generate such horrible errors that they're undebuggable. Like, I'm not planning on doing what I'm doing in my command line options library on like a regular basis in here. That is horribly complicated template code that is not needed for 99% of cases. It is needed if you want to do string passing on stuff like that and parser generation at compile time, but there's no need to do any of that here. I don't see the templates being that complicated that there would be such a problem. Candidly, in this case at least.
Okay, and then thing 2.
Yeah.
We use tagged unions all over the fucking place.
Well, we can still use standard variant. It's not ideal, but it's still better than
How stupid is it that C++ doesn't have unions?
Well, that is stupid. I agree. There are proposals
Like,
for at least pattern matching, which would
this
make
is
it
why
easier.
it's like I get so pissed off. Like, C++, all you're doing is fighting with the type checker most of the time to make the data you already have work. Whereas in C, if you have the data, you're just fine. You can make it work.
I suppose it depends what you're doing. With standard variant, you definitely get that more than with other things. Like, it's definitely not ideal, I would agree.
And here's the thing. With standard variant, you keep saying, but there's no other way to do it.
You could do unions manually with a tag, but you need to implement all the constructors manually. Yeah, it is the C way of doing it. You could do that in C++, but it's horrible.
So why not just use C?
Well, then you end up with this. You can't. That's not an argument. Just because one language feature of C++ sucks doesn't mean that it doesn't have 90 others that are better than whatever you're seeing on screen right now.
But this is only like one part of the entire 15,000 line compiler. The most of the compiler is fine.
It is just one part. It's not like I just changed 4,000 lines of code. It's just one part.
I mean, it is. It's just the IR. You did an incredible amount of work. I'm not saying it's not.
Code.
I'm not trying to minify
it. It is just one part, but it's a damn big part.
Right. But here's the thing. The solution in C++ has another error with this same part where we can't represent IR instructions without using like a horrible standard variant, which will give us terrible, ununderstandable template errors. Or we have to use inheritance, which is just a whole fucking mess.
Inheritance is much less of a mess than you think it is, probably.
No, I've used it. It sucks.
Well, then...
You've seen the kaleidoscope tutorial?
But trust me, standard variant is more of a mess than that. I would definitely use inheritance over standard variant there, or at least try to make it good. And the thing is, where we still, if there are places where we're still using tag unions, we can use standard variant. It's not like it's impossible to use, it's just a bit annoying. Standard variant works, I'd say, pretty decently, actually, if you have no shared data. If you just have the variants and you only need that, it's perfectly fine. The problem is, as soon as you have shared data, variants and union in C just has the same problem. Like, I feel like in a lot, and enums and Rust have the same problem, because someone's certainly going to mention Rust. As soon as you have shared data, most variant-like constructs in most languages just fly right out the window because they have no way of representing shared data. That is a fundamental issue with implementations of some types in many languages, because some types simply don't have shared data. But in the real world, you need shared data a lot. So that is a fundamental problem that if you can find a language that solves that well, congratulations. I don't know one. That's why I'm trying to make one. But I don't like it's bad in C, it's bad in C, it's bad everywhere. It's just a fundamentally hard thing to get right, I would argue. And because someone's saying you just if you have a shared data field, you just replicate it. Yeah, replicate it across 40 variants. And it's not one field, it's 4 or something or 6. It's horrible. It is absolutely atrocious. And then you'd have to or maybe you could stick that in a separate struct. Then you have a separate struct you need to add to everything that's more in direction. It is atrocious. Variants are just fundamentally bad in many cases. Or at least not have problems like that. There's just no good way of doing it. There's just ways that don't completely suck.
You're right.
And the thing is also about union. Yeah, unions seem convenient in C, but they're also goddamn unsafe. It's very easy to make a mistake when you're using them. That's also if you go to ir.c, there's a bunch of asserts in all the accessor functions at the very bottom. Just go Control N. Yeah, there. See asserts everywhere that this is actually the right kind of instruction. And variant enforces this basically, whereas with unions you have to do it manually everywhere. So it's yeah, I'm not saying that C++ that switching C++ would allow us to make use of the optimal way of implementing an AST and instructions that it would solve all the problems immediately in an obvious manner. No, all I'm saying is that what we're doing right now is pretty horrible. If we go to C++, it will be a lot less horrible. In some places, it might still be somewhat bad, but at least it's not whatever this is.
But the way in which it's bad is just ununderstandable. Like with that generic code, I can at least read it and go like, okay, so this is like a generic and a generic. C++ just gives me like, oh, here's a template. I can understand the template, but I still don't understand the problem. Because it's just an unreadable error.
Because if it depends on what you're thinking of. Because if you're thinking about template code like it's in for instance in standard format in LenserOS, that is horribly complicated template code. It's more like
and that's all there
code
is. There is no simple template code. Otherwise, you wouldn't use templates.
I'd say like a templated vector is fairly straightforward generally. As long as you try.
If you have to add fairly and generally around it, I don't know if it's a true statement.
Using standard vector is straightforward so long as you don't try using a placeback. In which case, don't use a placeback. Use pushback. You would never think about using a placeback anyway if you didn't know about it. So I'm saying is it doesn't have to be that horrible just because we suddenly have templates. That wouldn't make it that much worse.
I'm just
it wouldn't make it worse. It would make all of this that you're seeing here. It wouldn't even need templates. It would just be function overloads. You wouldn't even need
exactly. I'm okay with function overloads. Like if those were in C, we'd be using them all over the damn place.
And also the thing is also here with if you're writing a bunch of getters and setters in C, you kind of want to write C++ really. I know someone's asking is templates are okay until you start doing spinny nonsense. I do like spinny, but I could see how that would be confusing. If you don't want, if you don't know what it is, don't worry about it. If you say you don't want to use that because it's confusing, that I can understand. I use it because I like C++, but it's not that big of a deal if you don't want to use that. That is fine if you don't want to deal with that. I'm not talking about using the most complicated template code ever.
And that's what I'm mentioning. I'm saying let's limit our C++ to be like C like C++.
I wouldn't ever want to write C like C++. All I'm saying is we don't have to write the most complicated compile time metaprogramming code ever. We could just write decently reasonable code. Because I'd say like most of the templates in my compiler even are pretty simple. I don't have any complicated, horrible stuff that's just unreadable.
I mean you're very biased. Just on C++ in general.
Biased, but I have written fairly complicated template code, and none of this really is that. I don't even have that many. If I just search for templates in like, hold on, man. Let's see, templates.
Davros gives the worst suggestion of available.
I don't even have that many of them. So it's and most of mentions of template are actually just relating to like what is it, templates in source. But like most template code is maybe stuff like this, like The most complicated it maybe gets is stuff like this. Okay, but even this, you don't need that all the time. Hold on.
Also, Davros with the worst suggestion in the universe. If you're a C user who dislikes C++, it might be worth giving Rust a shot. I'm not sure if there's supposed to be a /s there.
Mm-hmm.
If you don't like C++, don't try Rust. Rust is like everything I hate about C++, but stronger.
For instance, you can take a look at this. Okay, this is at the bottom, by the way, is a function declaration. It's just cut off.
This is another thing I dislike. As soon as one person mentions Rust, all anyone can mention is good things about Rust. It's like, it's a fucking circle jerk. Can't stand
What
it.
I hate about Rust is the way it does compile errors. Well, that's the one thing
I
that
hate it.
everything else is annoying. I don't like it, but this is the thing that makes me just never use Rust. I've tried it a few times, but that's always why I gave up. It's because, you write code, 3 errors, you fix those 3 errors, 20 more errors. Instead of just displaying all the errors, it shows them in like stages. And sure, sometimes, okay, I can understand errors causing other errors and fixing errors, like making it so that other errors manifest. Of course, that I understand.
But here's the
that makes
thing,
perfect
the
sense.
errors
But
tell
most
you
of
how
the
to
time,
fix
it's
them.
completely unrelated. It just stops reporting errors. That is so fucking annoying. I think I'm done fixing everything, and all of a sudden, more errors. Oh, and someone's mentioning Go. Don't get me started on Go. Just don't.
Don't go there.
Anyway. Go, I swear to God. I'd rather use Rust still. Now, what was I going to say? If it compiles, good luck getting it to compile, because someone said if it compiles, it works. Yeah, good luck getting it to
That's
compile. And
also
most of the things are logic errors. That the compiler's not going to help you with that. Most bugs are logic errors. Anyway, what I want you to look at is I posted it in chat. It's this screenshot here from my compiler. The bottom is cut off. It's a function declaration. But what this basically just does, it declares 3 templates depending on whether a Boolean is true or false. It selects between 2 types. Would you argue that this is complicated or?
yeah.
Okay, then this is probably as complicated as it would get normally.
See, this is I don't like this. This is my issue. I don't even like trying to understand this. What is a conditional T?
Conditional T takes in a bool and 2 types, and it evaluates to the first type of the bool. It's like if in Lisp, basically. It's conditional
Why
T is
can't we
like
use if?
Because if is a keyword. We could have called it if T. Yeah, sure. You could call
No, but like, why can't
that.
we literally just say if as candidate?
Because the problem with that is that unfortunately C++ doesn't support types as values. So you have to do this nonsense. I agree, this isn't ideal. I would very much just be able to write. I would very much prefer just be able to use a ternary operator in here.
So
And I hope eventually we'll be able to do this. But right now, currently, this is unfortunately what we're stuck with. So I agree. This is far from ideal, but at least we can comfortably select between 2 types instead of what we can't do that at all in C.
why do we need to do this?
Because in this case, sometimes I need to return an overload set that contains only functions, and sometimes an overload set that contains more metadata. I need it in this case.
It just seems okay. I don't like the solution C++ allows for.
It's better than having no. I agree, it's not ideal, but it's better than having no solution.
I mean, I agree. If it ever comes to this somewhere where we can't do it, then it's like it's realistic. I don't enjoy C++. It's like the debugging of C++ is like the type checker and the type system, and there's nothing to do with computers or anything.
Yeah, C++ is more about getting the compiler to do what you want than the computer to do what you want.
Exactly, and I like talking to the computer. Is Gary is my friend.
I'm a compiler writer. I like using the compiler. That's my argument always is why I like C++ is because I like writing compilers, so I have it easy because I know how a compiler works. I'm fairly familiar with C++, so I know what the compiler is trying to do. So if I get an error message, I actually know why it failed most of the time. And sure, that's not always that easy. That takes practice. But I'd say in most cases, it's not that bad either. Like, even this code is maybe not immediately obvious, but I think you can figure out what it means.
if you need to use stuff like this. And even that, this isn't particularly common. Like selecting between conditional T isn't. It's a template that's used every once in a while, but it's not like you have a code base that's just littered with that all the time. It's not like every other function is going to be like this. There's one function that uses this in my code base.
Well, that's the other problem that I have with C++. It's like the stupid standard library. You have to know every, like, oh, use ranges generate 427.
You don't have to
It
use
came out last Saturday.
Nice to know it.
Yes, but
You don't
everyone
have to.
does, and then as soon as they do, you have no idea what the code does, and you have to go down this stupid rabbit hole of like, oh, this is actually an implementation of the algorithm from 1975. And it's like, oh, they couldn't just...
Most of them, I'd say, are fairly straightforward. Like all of returns true if something is true for all elements of a collection.
But that has
Any
nothing to
of-
do with ranges.
What
I'm
do you
fine
mean?
with like algorithm, like learning a header. It's like the same in C where you have to learn like, oh, stir compare,
Yeah.
stir talk, stuff like that. You have to learn that stuff. But then
Yeah.
C++ goes further where it's like, oh yeah, there's stir talk, but then there's also this thing that some people will tell you to use called ranges stir talk, and it's actually better, but no one can tell you why. And then also there's this other header, and it has something called string to tokens, and it does the same thing, but in a slightly different implementation and uses templates instead. I hate it.
So basically, the main difference I can summarize. It's real quick. I can summarize it. The main difference is this.
Sassy Fetus, it sounds like you guys should maybe explore and try to compromise on a completely different language, because the main arg on both sides there is ew. That's the problem. There is no language. They all suck.
So this is basically if you look at in chat real quick, this is the main difference between ranges and the regular one. If you look at that, most standard algorithms like standard do thing accept the begin and end and some kind of function. Ranges, exactly the same thing, but you don't have to write begin and end anymore.
What's the
literally
difference?
You don't have to write begin and end anymore. That's it. Because writing
Why
begin
have
and end.
both?
Because unfortunately we only had the first one, and writing begin and end all the time got annoying, so we made the shorter one, which is ranges. That's the only difference.
Why
That's
wouldn't
all
you
there
just
is.
replace? Oh, it's the
Because you
stupid
can't
fucking
replace,
iterators that they're not willing to change still. The
you
stupid C++
can't.
standard. I hate it. I don't like it.
I like the way Herb Sutter puts it, because he explains that well. We can't do that because the way he phrases it is we would break the world. Everyone
Fine.
uses C++. You can't do that.
You can. We have,
Sure.
and we should. It's
Sure,
so
if you want to break
stupid.
a program in existence, and that's not something you do, unfortunately. It's this. We've talked about this
is.
before. So I don't want to start this discussion again, but what we settled on and what we agreed on is that in an ideal world, of course, you just remove the old thing that you don't want people to use and add the new thing. But unfortunately, we don't live in an ideal world. We live in a world where backwards compatibility is unfortunately necessary.
It's not
You
necessary.
can't add,
It's
you
a
just remove old
choice.
one.
So I'm just going to say one thing about it. Backwards compatibility is a good thing, but it's not worth it if you have to sacrifice forwards progress. That's it.
Sure, I agree with that.
And that's what
as a
C++
lot of people that
is. They've
argue that,
sacrificed all forwards progress.
Sure, that is definitely a problem with C++, that you can't remove all things. That is definitely, sometimes we fortunately got auto pointer removed at some point, but sometimes, sure, I agree, that is a problem, that you can't easily just remove things that aren't good. But the thing is that eventually every system that is widely used and continues to be widely used runs into the same problem. I'm pretty sure like Go also had that stance until like 2015 or 2016. Oh, we're not going to bother with that. We're just going to remove all features and refactor everything. And eventually they had to do a feature freeze because people were upset. They just wouldn't update their compilers because, well,
people are always upset.
well, no. See, if removing an old language feature makes people not want to update the language and instead keep using an older version because they need that old feature because it's used in their 2 million line of code base from 1990 that they don't feel like updating, which I can very much sympathize with.
There's no reason to force every new program
in a 1-year-old code base. You can't do that. It's unfortunate, but that's just how it is. I agree, it's not nice, it's not ideal, but that's just how it is.
There's
And
literally
no
compiler versions for this purpose.
It's a waste of energy.
There's compiler versions for this purpose. Like, there's semver isn't upheld by C++. They've broken semver because there's no breaking changes.
there's too many projects that still say we only use C++11.
That's fine. They can do that as long as they use GCC 9, but GCC 13 doesn't have to support that. I don't get it.
Well, unfortunately,
Doesn't make any
that's not how it
sense.
works.
It doesn't make
It
any
doesn't make
sense.
to you, but that's just how it is, unfortunately.
Fartingle brings a good point up too. Even for forward progress, you can provide solutions to migrate with, say, a side-loaded legacy feature. Exactly.
We have that in some cases, but unfortunately, progress in C++ is unfortunately slow sometimes. And the thing is,
It's not slow, it's
also
non-existent.
one argument that doesn't work in this case, why would you just remove the old thing? It's not entirely true, because sometimes you have a range of iterators that isn't begin and end, but some sub-range, and you only want to run the operator or the algorithm on that sub-range. So for that, you still need the old one. So it's not like range just
Well,
makes
that's what
the
we're
old case.
describing, a side-loaded
Let me
legacy
finish,
feature.
please. I'm still making a point. It's not like range just makes the old algorithms library obsolete. It's just that it provides a convenient shortcut for writing the most common case more easily instead of having to write these using the special case to implement the common case.
See,
so in
but
this
you're
case,
just thinking about it
algorithm
backwards.
doesn't even apply.
You're thinking about it backwards. Because all you have to do in that case is replace the original and then put the old one that you still might need in 1% of cases in the special case. And then the common case becomes better, and you make forward progress with breaking changes.
I don't see how that applies to this here, but sure.
So, okay. Like if you have ranges generate and generate, instead of making generate still take 2 because of stupid backwards compatibility for no reason, just make generate now take the collection instead and use begin and end. And then for those that still need begin and end, can they not just provide standard ranges generate that takes a begin and end? Why did they make the better one not the
see what you're
default?
saying. If you're arguing that standard generators should just have an overload that only takes one collection, I agree. I didn't know why they put it in the ranges namespace. I would have just put it in
Exactly.
the node. Maybe I
They're
could.
just
There was
splitting up
probably
the.
some reason for it, like some weird ADL thing or worried about name. There was some probably random reason, but the decisions that the committee makes aren't always the most sensible. Like there's some things that they have just done. Like the unfortunate truth is that a lot of people in the committee are just sometimes too worried about stuff like backwards compatibility and certain things to the point where that slows the progress of the language. I agree with that. So if you're saying that what they should just do is add a second overload in the standard namespace that just accepts a collection instead of begin and end, I agree. That's how I would have done it.
But
That's
they
how
do
I would
this
have done
in
it. But
every
unfortunately,
way.
I'm not the committee, so I can't. So we are stuck with this, unfortunately.
Right, but they do this in every way where there's 3 ways to do things, and one of them's technically the best way according to Stack Overflow, but you should never technically do it because you'll probably use it wrong. So actually use this other thing, and it's actually in this other namespace, which doesn't exist in this old compiler, so you have to get a new version, and then I hate it. It's just so much.
I'm not saying that there aren't problems with C++ in the sense of how the committee is handling the language. There is a lot of yeah, also someone is mentioning all the ways of initializing stuff. That is a nightmare. It is absolutely horrid that that's in the language somehow, all of that. Because they kept adding ways and now there's still the old ways and the entire vexing pass thing, and it's just atrocious, the situation sometimes. And this isn't much better. It's the standard ranges. That's why I always do like abbreviate the standard ranges namespace to just RGS, because I'd hate to type standard ranges every time. I wish it was just in the standard namespace. Yeah, it's not ideal. I'm not saying everything they're doing is perfectly, that they're these enlightened beings that are getting everything right, and that C++ is the perfect language that does everything right in the best way possible, and that you should only be using C++ and only do it as C++. No, it's a lot of the ways it's doing it is not ideal, but the thing is that it's decent. It is getting better, even if unfortunately the C++ way, unfortunately, often is just to make very slow progress sometimes, yeah, even in the implementation of new features, especially. So yeah, this is not ideal. I agree, but it's what we're stuck with. And I would argue it's not ideal, but dealing with things like we don't need to deal with things like that all the time. There are unfortunate parts about the language, but you don't encounter, it's not like that's all there is to C++. There's a lot more to it. And I'd say there's a lot of good things in the language that can be used efficiently to write code that is nice to look at, is performant, and also easy to use. and straightforward to use, and it's not it's not horribly complicated nested templates and substitute, and it's Finny and the CRTP and all of that. But someone was talking about Svinny earlier. I mistook that as I'm talking about CRTP, so if that confused anyone, that was that. But anyway, just as an aside. But what I'm saying is that it would still be better to use C++ than to implement all of this here, what I've done here in C, because the parts of C++ that allow us to rewrite this will make this easier. And the parts of C++ that are sometimes a bit horrible to use, not just because they may be complicated, but also because they might be questionably implemented, well, we don't have to use them all the time. And when we do, I typically try to sort of write some sort of wrapper around it or do something in that vein that makes it easier to use. So it's not like our entire life is just going to be with the horrible design decisions of the committee that have happened over the past 40 years.
So a good example of something I dislike is this defer stuff.
I will agree that that is horribly. That is not nice code. I very much agree. This is not in here, but I'm pretty sure there's some code. If you look at that in some of my projects, I like to call this a horrible hack. This is like template black magic. I don't consider this to be good code.
Right. So to
I
me,
agree.
I run into this shit every time I ask what can C++ do that C can't. It's this BS that I don't even like.
There's some people that like it. I like it because I like templates and I like templates a lot, but that's a personal thing. I can see why you wouldn't like this. I wouldn't like put this forward as as good code. It's a horrible hack that I like to use because I like being cute with how I write code. That's just a personal thing.
But I couldn't even like replicate this. I don't know what this does. I know what it does because it's called defer, and I know how to implement defer myself. But just looking at this, I would literally never understand it. It doesn't, like, what is forward? Forward's so confusing too, and no one can explain it.
It is horrible. Forward is
it's
a horrible
stupid
thing that exists. I can try and explain this real quick if you're interested, but
I'm not. I've been explained it, and I think I do understand it, but it's just in this scenario I don't understand it because I don't know what CB is, and then what's a callable? Oh, it's anything because it's a template. So now you have to go find where it's called and where it's actually used. So now you have to look at where it's defined, where it's used, and then every use of it could be different. So now you have to apply this one thing to 18 different things, and now we figured out what standard forward does here. So now we can figure out, that's actually the callable that's being initialized. Why do we have to forward it? I don't know.
callable generally means it's
so horrible. This is the BS that I have to deal with every time.
I agree. This is horrible.
And then you're like, we'll just write like a simple fatal, like, crash the program. What is this?
It's simple in terms of lines of code, but it's not particularly simple to understand what that does. I agree.
Ever. And so I could never write this program, even if you give me the source code. I'll never understand it. I could never write a similar program in another language, and I'll never be able to debug or fix anything in here. So why would I write this?
That may apply to I have two things to say about that. One is that is not how what the entire code base look like. You don't need variated templates.
It doesn't matter if even one part of it means I don't understand any of it.
Second point is, at some point, you also have to be willing to learn to some extent. Because you also, a year ago, you also didn't know about IRs or understood register allocation or any of that. And the same applies if you're using a programming language you're not that familiar with. There are certain constructs that
I'm just familiar with C++.
And it's the same in C.
That's the thing. I'm super familiar with C++. There's an entire kernel that I've written in it, and there's like user space programs. I've written it a lot. And I've even used it to implement old compilers that don't work. And they don't work because of C++. Because it makes it so complicated to do something simple.
It doesn't make it, I wouldn't say it makes it complicated to do something simple. It's just that you can do things that are complicated to understand, but that then make simpler. Okay, let me rephrase that, because this is something that is a bit complicated. It's that you can write code that is complicated to reduce to make using it easier, but in order for using it to become easy, you have to understand what the code does. So if you understand how variadic templates work and all of that, you can use them to do a lot of things in a fairly straightforward manner to someone who knows how variadic templates work. If you don't know anything about that, it's going to look like black magic to you.
And that
That
would
is
be
true.
fine if variadic templates were something you could just learn. Or like, for example, if you don't know what the function call syntax of C is, this will all just look like gibberish and a bunch of parentheses and it doesn't make sense. Until you go, oh, well, this is a function call because there's parentheses. This is this syntax. Each of these is an argument. You can start to understand that. Whereas template parameters aren't like that. It's just like, oh, it's ... Good luck. You have to figure it out based on context.
Well, you can't figure out C++ based on context. You have to understand it. That's the main thing. You have to have someone explain it to you or either look it up somewhere.
And that's
You can't
not fun
understand
to
it.
me.
It's not self-evident. I agree. And like Rust isn't self-evident either. A lot of things are not self-evident. You have to understand them. Instruction selection is not self-evident. Register allocation is not self-evident. You're not expected to be able to by yourself comprehend and rediscover everything that humanity knows about programming and programming languages.
No,
Some
but the
things you just have to have
language.
explained to you.
So, like, you're saying, like, Rosetta Stone, it's like we will be able to determine what it said, right? And we were. It was a bunch of
What do you mean?
gibberish. We found the Rosetta Stone. It was a bunch of gibberish. And then we figured out
Not exactly.
eventually what the words mean, right? Have you not heard of it?
I'm not sure I know what the Rosetta Stone is, but I'm not sure how that relates to this exactly.
Okay. So we were given something with no instructions on like anything, and then they're just random symbols, and slowly we put together what they all mean, right?
That is one way of putting it, I suppose.
Okay. But we don't necessarily know what they're talking about or what like we understood the meaning of the words, but we don't know what they sounded like necessarily.
If that's true for things like Old Egyptian, yes.
Right. So with C, you can't even determine what the words mean. The language itself isn't feasible just by looking at the language.
Ancient Egyptian, there's people who know C++ that can explain it to you.
There aren't. There aren't ones available. So if that's the case, I mean, then that's like saying, oh, if you have somebody who already knows C++, then you should write things in C++.
If you know C++, you should write things in C++, and the way you know something is you learn it from someone who knows it, whether directly or indirectly. That's generally how that works. If you learn a new skill or something, you learn it from someone who already knows it, either by having them teach you or by reading books, articles, whatever, watching tutorials, whatever.
Yes, it depends on what it is. You're talking more about like mental skills or like abilities.
Most things, like into some
like
sense,
learning how to
writing
run.
complicated C++ is also something you have to first learn how to understand, how to read that sort of code. It's not self-evident. I agree. It's very much not. You have to, if you know what it does, it makes sense to you. If you have no idea what any of this does, it's going to look like gibberish. Sure, that is just how it is. So in order to understand it, you have to learn it. Like we can go back to, let's go back to that format template. That's a good example.
What's the format template?
That standard format wrapper that you pointed out, the fatal function in the test runner.
Ugh. Already closed it.
What about this template here? To understand this, you have to understand how parameter packs work. And the ... thing, there's two things you have to know. If it's to the left of a name, it creates a pack. If it's to the right of a name, it expands a pack. So in this case, in the template argument list, we are creating a pack of types named arguments. So any template arguments you pass in will be collected in that. And then, for instance, in line 95 at the end, we are unpacking that pack, meaning for each element of the pack, do this. Meaning for each element of the pack, we create a parameter. That's the basic meaning of this ... thing. And the same thing in line 96, the ... to the right of the parameter of both arguments and args. Both arguments are and args are parameter packs, because on line 94, the ... to the left of arguments creates the pack arguments, and on line 95, the ... to the left of args creates the pack args, and the ... on the right of this expression on line 96 means repeat that expression for every member of the pack.
Jesus.
And in this case, inside of a function call, it also inserts commas in between, so it just unpacks all of that. It's a bit like it's sort of like the, what is it, the at comma thing in Lisp, where it splices that in. It's a bit like that.
Right. Just with all the same syntax instead of sensibly splitting it up. Like, oh, what if we just use ... for everything?
Yeah, I agree that the choice of ... for everything
Stupid.
makes it very hard to read. I agree that is not the best choice of operator for this, maybe. I'm not sure I could think of a much better syntax, but having this double meaning, where to the left of something it creates a pack, to the right of something it expands a pack, that is definitely far from ideal. That makes it confusing if you don't know what it does. And sometimes I even have to pause and check on which side it is to make sure what this really is.
And then it's like, here's another thing. This is used on an expression and does something totally different when it's on the right than this. This is completely different.
Well,
it's
if
related.
on the right in line 95, it expands arguments and puts it in there with commas in between.
Which is
on
not what
line
it does here.
It does that for the entire expression containing arguments. In this case, on line 95, it's just arguments by itself. So
which is just a different thing.
Containing a pack. Yeah, it is similar, but it is a bit different. So the way pack expansion works with the ... to the right, it's any expression containing a pack to the left of it is expanded one time for that pack. And if there are multiple packs, the packs must have the same length. Otherwise, it would get
It's
horrible.
ridiculous.
So it is a fairly complicated concept, but what other construct could you think of to concisely write a function that accepts as many arguments as you want and pass it to another function? You have to express that in some way. Maybe this is not ideal, but it's one way of doing it. Like, you can't do that in C other than with a macro, and even then, not really. Because with this case, you can insert stuff before or after it or whatever. With a macro, it's like we have VA args in C. That's somewhat better, but that's somewhat simpler, but it's also a mess, I would argue. So this is perhaps not ideal, but it is a very concise way of expressing it. Perhaps a bit too confusingly concise.
Why?
Sure.
So why are these needed at all?
Because you have to do something with a pack. A pack on its own can't be used. It's this weird. It is a bit of a
Why
weird
not?
thing.
Why require
would a
this ... on the right?
Having a pack expand automatically on its own, that's an interesting idea. Sure, that's not a bad idea, actually. You could probably do that. Why didn't they do that? Well, maybe they wanted to make pack expansion explicit. That you could do it that way, sure, but in this case, you need the ... after it. A pack in some ways, there are some weird things in C++ that can't be used on their own. Like a pack is one of these things. Because C++ doesn't really have metaprogramming, you can't really do anything with a pack. Using a pack on its own is kind of like using a keyword on its own almost. It doesn't mean anything without an expansion. So
It's
arguments
just not sensible.
Yeah, arguments in and of itself is a compile time only thing. It's a collection of types that unfortunately doesn't map to any. It's not a vector of types, not an array. It's not a C++ language construct. It's a weird compiler internal thing that is. It's a very weird entity. Like a pack is a very weird thing in C++. I agree. It is not exactly self-evident or obvious or anything.
It just feels like the wrong way to do things. Like, don't do that. You know, as soon as you look into it.
Idea, but can you think of a better syntax for it?
Yeah, no ... use a ... to describe, I
Sure.
want to create a template pack or a template parameter pack or whatever the fuck it's called. So say arguments, right? Template or whatever it is. This is going to be incorrect. But template type name arguments ... That's it. You've done it.
Yeah.
Then just use arguments. This is
That would have
stupid
been one way of doing it, sure, but they didn't do that for some reason.
and not a good
I mean-
one. Otherwise it would be obvious.
Thing where maybe the design I obviously don't know everything that went into every last design decision of the committee, so perhaps they have good reasons as to why this either would have been too confusing or would have conflicted with some other feature or would have just been too hard to implement on a compiler level. I didn't know every last thing about C++. I'm not part of the committee and I can't speak for every last decision they make or the rationale behind it, but the fact of the matter is that that's what they decided. That's what the way it is, and it would seem that just writing the pack arguments, it would seem at first glance that that's maybe a better way of doing it, but it's not what they did. It's unfortunate, but that's just how it is. Now you have to learn that ... to the left of a type means create a pack, to the right it means expand the pack, and unfortunately you just have to learn that. There is no good way around.
I've learned that and I still don't want to use it.
The thing is,
there's
about
nothing that
variant,
would make me use that ever. I'm not going to write one.
many uses for it. Like the main one is passing
just-
things along, and the other one is kind of doing fold expressions. I use that in one place, really. In my is function, because I wanted to be able to accept multiple things. One bool is. We can
I'm just
search
saying,
for
like,
that.
I'm a Lisp person. Things don't have to be the most understandable or like simplest for beginners or stuff like that. I obviously, right? C++ is worse than that. It's worse than, it's really bad. It's better than Rust, I'll give it that, in like usability and experience of using it. But it's very close to Rust.
I have another example here. This is a similar use of pack expansion. It's like, this is one I use semi-regularly. If you look at that in chat, I
see
another screenshot here. So if we look at the template itself, again, tease is a pack here. This creates a pack. And then the OR operator, it expands that, and instead of putting commas in between, it puts OR in between. So this takes an OR of all things.
This is so stupid.
Can you think of a concise way of doing that otherwise? In Lisp, what you do is you just put the OR at the beginning and then everything after it. But C++ uses infix notation, so it has to do this.
Well, the solution would be to make it easy to just do something for each of the template parameter pack, and not just use ... and make this unreadable bullshit.
There is a proposal for that, a context before loop that does that iterates over a pack and then expands for every. You just write for ... each member of the pack, and then you
no ... for TS. Just write the name of it.
That you can't do, because that doesn't really work too well with how that would be horrible because name resolution C++ is already bad enough. You don't want to make it even more ambiguous than it already is. That's already horrible enough.
If it has ... in it, I'm not interested. ...
after the for, if it's immediately next to the for, it's clear what it does, I would argue. But that syntax would allow you to write this loop in a more sensible manner than having to do this fold expression. It's syntactically it is a mess, especially because you need to put parentheses around it, otherwise it doesn't work.
And then just ... in general is stupid. That's what every single text editor uses for like, oh, there's more here, expand it.
Yeah, using ... so profusely isn't the best idea. I agree.
And then Mr. Mugume had a very eloquent point. My problem with C++ is that it just never gets to a point where it looks self-explanatory. Every time I look at C++, I feel like I see a new keyword or syntax, and don't get me started on the standard lib. With most other standard libraries, e.g. Rust, it just feels natural. I don't know, though, maybe that's because I never really looked at C++ deeply. And then he said later, every single screenshot has some weird-ass syntax. It's just crazy. And I would agree. But Rust is worse than that.
that gets better over time. But the problem with C++ is that over time means after you've used it for a couple years. Then that gets better. Like, to me, this code that I've shown here is fairly for me, it is self-evident. It's obvious what it does just from looking at it, because I'm used to looking at code like this. I've been looking at code like this for years. I'm used to it at this point. For me, it is obvious, and it's the easiest thing ever. But of course, if you're starting out, and even if you've been using C++ for a while now, if you don't use C++, and if you don't specifically do this sort of stuff a lot, then you won't learn it and it won't make sense to you. That is clear. That makes perfect sense. If you say you don't understand it, yeah, if you haven't been doing this sort of stuff for like a very long time, then that's unfortunately just how it is going to be.
Whereas like in Lisp, I can learn some crazy mathematical concept that I barely understand and then like implement it using very simple tools, and then it works. And then C++ is like, oh yeah, you want to do like a 2 + 2, but in this very specific way. Like, oh yeah, you're gonna have to figure out how this entire language works, and also there's no way to do that, so you just have to find someone to teach you. There's no documentation on how to learn it or anything like that.
One thing that I will say though is that with the parts where it is complicated like this, is only like fairly new complicated, like such as forwarding arguments to another function. Most languages don't even really have a language feature that does that at all. I mean, at least the languages I know. C certainly doesn't. JavaScript, not really. You have in JavaScript the fold thing, the dot to dot also exists in JavaScript in some way, but it's worse there because it creates a new object, the spread operator. So it's like, yeah, it is horribly complicated, but it's also a way of doing something that you otherwise couldn't do at all. You have to find some syntax for it, and in C++, generally, the idea is typically that we want to choose a syntax that doesn't conflict with anything else, and then you end up with somewhat unfortunate design decisions, like overloading this operator to mean so many things.
This is code that I dislike. And C++ pushes people towards that if they want to write like shorter code, or that's what they push you to, like, oh, we just came out with this new thing, it's called parameter packing, and then everyone wants to use the new feature and it's this, and then everyone's forced to like, oh, this sucks.
Well, we use it because simply the thing is also that with people who've been using C++ for a long time, you also get to the point where where most, if you look at this, might not make sense to people who haven't used C++ too much, but if you look at most features that get added to the language, for someone who's been using C++ for a long time, it's pretty obvious why they got added. They clearly solve one very specific problem with the language that you constantly have to deal with that is so annoying all the time. But the thing is, it doesn't fully solve it, it just makes it less annoying. But if you're not familiar with the underlying problem and with how this is better and how the underlying problem is worse, you won't see this as better. You'll just see this as bad, because this is a lot. Do you know what the alternative to this is? Writing a recursive function.
Which is way better.
Which is, which is the thing. It gets very annoying if you have, I don't know, 4 of these in a function. It's horrible. Writing recursive template functions is what you need to do in some cases, and it's pretty abysmal. That's how it started in the very beginning. Const expr, the only thing you were allowed to have in a const expr function was a single return statement. So we didn't even have for loops. So we'd have to do horrible recursive things, something that C++ is not good at. It's an imperative language. It's not a functional language that thrives in recursion. It's not good at expressing that. It's syntactically not easy to do that, and it's not easy to do that well. And because the alternative to this is worse. Like, I can rewrite this without the fold expression, but I wouldn't say it's better. Like, if we do this real quick, that doesn't take long.
I would rather write like 8 overloads than deal with that. Which is exactly what Davros said in chat. That's funny. Even if it means writing 10 overloads of fatal for 1, 2, 3, 10 params, that can still be preferable to excessively complex templates.
Agreed.
And then at that point, I still don't exist. I still don't understand why all of these things exist, and like why they don't ever simplify or fix anything. They just keep making it worse. They're like, oh, let's add another detail to the 18 million you have to know. That'll simplify it for you. That'll solve your problems, right? It's like, no, you're not solving anything. You're just making more complex shit. It's like if you scribble on a page enough, you'll just fill in the page and you won't see any lines. There's no scribbles. It's just a page.
Without fold expressions, that's the or ... This was the old way of writing it.
That's so much better already.
How is that better?
I at least understand it. There's no or ... which first of all just makes no sense. Even from after understanding it, we're like, oh, the ... to the right of an expression will repeat it for a template parameter pack. It's like, what is this? Isn't an expression.
This is a special case if you have a binary operator with an expression containing a pack on one side and the ... on the other side. It will repeat that expression for every pack and then insert the binary operator in between.
Okay, my issue with this, there's still a template parameter pack. First of all,
this is the old way of doing it. This is worse because now you have size of ... which gets the size of a pack. You have a recursive call. You have 3 lines of code with like either every line containing as much code as the first function that I showed you.
This is so much more readable.
It's so much more understandable. I don't give a shit about verbosity if I can read it.
Oh yeah, because if you need to write this 70 times in a row, then that's definitely much more convenient than writing the other one. Like, if you haven't written this sort, if you think this is good code, you haven't written this sort of code enough, is what I'm saying.
But we can at least understand it. We could write this if we like needed to solve a problem. This is something that we could feasibly come up with. Whereas the thing up top isn't. We would never come up with anything that looks like that ever. And that solution would just never happen unless specifically someone from C++ goes, hey, you can do this really specific stupid thing with binary expressions and template parameter packs. Like the rules of the language do not just clearly compose into beautiful programs. They've added all these little shortcuts and hacks to make it an okay language, but there's so many languages that just are okay languages without all these shitty specific hacks that you have to remember 18 million details about.
Well, it depends. Most languages don't have something like templates. A lot of languages don't.
Because they're sensible.
Well, I would agree that it makes writing code in those languages harder, that it makes writing code like this harder to do. Like, you have to just write longer functions with simpler code, but I don't like writing more code that is less expressive. And I agree
that's not less expressive.
That's 100% my thing.
Fewer lines of code that does more things, that is denser in notation
Python.
and semantics.
You're describing Python. Go use Python. If you want to write one-liners and like, oh yes, it's the high-level semantics of this for of x in array xy. That's such a genius, complex solution. Go write Python if you want to do that. That's not what this is for.
Python is not a low-level language. C++ is a low-level language, or at least a language that compiles to low-level code, to machine code, and still gets this stuff done. C++ is supposed to be a high language that has high-level abstractions to make writing code easy, but still performant.
Tingle says all templates and no play makes Jack a dull boy. That's what we're getting at.
It's the code, the first word of the fold expression, the or ... might not be obvious, but if you have a bunch of C++ programmers who've written the code on the bottom way too often, then you can maybe start seeing why the one at the top was introduced.
I'd agree with you that C++ only makes sense to write if you've already written worse C++.
Yeah.
Because you're already, that's the sunk cost fallacy.
The point is, the one that you said was the old one had to have happened first, whether or not you like it, to even get to the new one.
And then it's why have 2 ways to do things just to make it a little bit shorter and confuse everybody.
I'm saying that this is how it happened.
Yeah,
like
I like how it happened, but I don't like what it came to.
If the people who now have 20, 30, 40 years of experience with C++ went back to 1980 and designed C++, they design a very different C++ than what we have now. The unfortunate thing about C++ is that we have to deal with 40 years of legacy and somehow extend the language in a way that makes it easy to use for the people that know it. without breaking every last code base in the world. That is the main fundamental problem, and why it's hard to just add a new language feature that's easier to use. I mean, you can look
a
at things
fundamental
like
problem
HubSpot
with permanent backwards
CPP2,
compatibility.
which we can take a look at projects like HubSpot CPP2, which aims to, and it's also what he says in his talk about CPP2, that within C++ there is a 10 times simpler and 10 times safer language waiting to come out. And
Go write a version of the standard that does that, and fuck
that's what
backwards
he's trying to
compatibility.
do. Yeah, but the thing is that takes a lot of work, a lot of experimentation, and it's not something you can just do. And even if you do that, you at the same time you can't just throw away all the code that is out there.
Well, tell Herb he can hire me, and I'll work full time on C++ too. Because I want to see that.
It's an open source project. It's on his GitHub. You can commit to it if you want to.
I don't have time.
It's got to be a paid thing.
Yeah. I spend so much time just trying to
I'm not touching
make money to survive.
I'm being paid twice what I'm being paid in my current job. And
Well, yeah, I agree. It's not ideal, but if I have to write the code like this all the time, and I know that I can, and I understand how fold expressions work, I'm going to use a fold expression because it's short.
Yeah, sure, great. I don't understand it, so I'm not going to read it. But
as
you can
someone who knows what it does, I can look at this and I know what this does. It is easy for me to read that than to read 3 lines of code.
Okay, you know those videos, you know the one they did, you sent it in the Discord a while ago with like, they're making fun of the Emacs people. Like the Emacs users, and they have like a fake beard on.
That one, yeah. The programmers are also human is the name of the channel, I think.
Yeah.
That one's great.
You just reminded me so much of that style when you, like, I am just picturing a guy with C++ on his shirt, and he's saying, like, if I know how something works, then when I look at it, I know how it works. Like, yep, that's C++.
Yeah.
There's so much prerequisite knowledge is my problem. Like, I can't go join a new project because everybody's got 30 years of C++ in their head, and I'm like, write the simple thing so I can understand it. I'm never going to touch C++ if I didn't write it myself for that exact reason.
The thing for me is also that I've been programming C++ for a very long time, and it's not just that. I constantly watch CPP-Con talks and other conference talks. I read proposals about the language. I look things up in the standard. I'm very familiar with the language, and I constantly keep learning new things about the language, and I'm up to date with what's going on in the language. And that's why I know how this works. I know that I'm familiar with the new features, and when they come out, when things like I don't know, deducing this comes out, I will have already known that for 3-4 years. I will be perfectly familiar with how the feature works once it comes out, because we've been hearing about this. The people who are very interested in C++ and do a lot of things with C++, we've been hearing about this for 4 years, and when it comes out, we'll know how to use it. And things like deducing this is probably, if you have never seen it before, it will look horribly complicated, but everyone who's been programming C++ for a while knows that solves a very common problem. It's like, it's always this thing with when new features are often designed to make, because C++ is Turing complete. You can do anything with it. So the only work that is being done now is to make things that are tedious, less tedious, and things that are error prone, less error prone, and so on. And if you don't know why these things are error prone, why these things are tedious, you won't understand why they are a thing. And that, I think, is a fundamental problem, not just with C++, but also with just certain things in programming, because it's also with things like how a lot of code bases have a convention that in C++ class members are prefixed with underscore or M underscore or something like that. And there's a variety of reasons that people give for that. Some people say, oh, this is because we want to know that this is a class member. Well, my argument against that is typically you have syntax highlighting. You can just make class members purple, then you know that it is. That's not a good argument. That's just Hungarian notation all over again. And most people nowadays agree that Hungarian notation was a horrible thing and that existed only in typeless languages where it made sense. But what people don't tell you, and what I found is the main problem, is something completely unrelated: shadowing. A lot of the times, if you have a member function that maybe sets a value or accepts a value, it just so happens that, seeing as you probably chose the most sensible name for the member, for a class member that there was for it, such as size, the most sensible name for a function parameter is probably also size or something like that. but you can't just reuse size because of shadowing problems. So now you have to rename the function parameter to like SZ or something horrible. You can't use the name you would like to use because, well, that's already the class member. And that's not something, that is what all writes, as someone points out in chat, write this arrow to access members, which is equally horrible. That's 6 characters. It's better to write underscore before a member if you want to start writing this arrow. And the thing is, this is something that people, I feel like, don't tell you. It's like you're sort of kind of expected to know that, I've come to believe at this point, because the only thing you hear about, oh, it's to make it clear that that's a class member. No, that's a horrible argument. That's a subjective argument that, in my opinion, I disagree with. But a very objective reason for it is that shadowing is a problem. If you don't understand what shadowing is a problem, you haven't had enough shadowing bugs yet, is also another thing. But it is clearly a problem, and prefixing class members or something like that solves that problem. And that's also why I find it genius that for instance, in the Yacht programming language, which was made by, what was his name? Andreas Kling. You may him the guy who made Serenity OS. In that language, you have to prefix class members with dot. You have to write dot name or dot size, for instance, to access members in member functions. You don't have to write this dot self. You can just write dot. This dot size. You can just write dot size. And that, at first, if you just used to the way where everything is just in scope, might seem annoying. Why do I have to write dot in front of everything? But if you've been dealing with this shadowing nonsense and prefixing so much, it makes absolute sense that this would be a language feature. And the thing that annoys me sometimes about such things is that they don't mention that. It's not like they go ahead, oh, we'd introduced it because of this. It's like, no, most of the time, for a lot of the time, there is a good reason for why something exists, why a convention exists, or why something is done in a way in which it is done. But the unfortunate thing is that that is not apparent at all unless you've dealt with the underlying problem way too many times. And the thing about C++ is that with a lot of new language features, which this is, fold expressions, I think, are from C++ 17, and variadic templates too. Variadic templates are also from 14 or 17. I forgot. It's been a while. But the thing is, a lot of these features only make sense if you've been dealing with the problems that they solve way too much and for way too long, to the point where writing that code over and over again is tedious, and you just want to a shorter way of writing it. And fold expressions are a shorter way of writing this horrible recursive nonsense, especially in the middle of a function. And it's like that with many other features. Variadic templates weren't in the language from the beginning. They were introduced because we had to forward functions. Standard forward was introduced, well, because of how template argument deduction works. Why does it work that way? I don't know. It's probably worked that way since 1990, and there's no fixing that now. So we have to introduce another feature that preserves types exactly, which is forwarding references and template, and add a library feature that makes use of that, so we can forward types exactly as they are to functions, so we can actually move from functions, from things that are being passed to us. It's like all of these things solve very concrete problems, but if you're not familiar with dealing with the underlying problems, they're probably just going to seem like a lot of nonsense to you. And I don't have an easy solution for that, other than say, go program in C++ for 2 years, and then you'll understand what the problem is. It's the same thing with an example of that you probably do understand is why namespaces exist. Because in C, we constantly write IR underscore opt underscore library name underscore. In C++, instead, you delete the underscore, insert double colons, and that is basically the same for everyone who uses the library. It's one extra character. That's not that bad. But for you, as the library writer, you can omit that prefix in your own code. So that makes code simpler. Namespaces solve a very concrete problem. And that's the same for all of these other language features. It's just, if you are only used to, I don't know, maybe writing C# or Java or some other language that doesn't really have this strict namespacing thing, because the problem with namespaces is binary compatibility. Like, you get link errors if you have the same name. That's why you have to prefix everything. It's a fundamental problem that you don't have in high level languages a lot of the time, because they namespace everything automatically for you. So if you haven't been dealing with this problem for a while, if you're not aware with that, namespaces might seem weird to you. They might not make sense. And it's the same thing with fold expressions, and with variadic templates, and with conditional T, and with pretty much every other feature that you might call complicated in C++, and that definitely is complicated. So if you're saying so, the only thing I want to say is, it's not needless complexity a lot of the time. It's complexity that's there to solve a problem. Now, whether that problem originated from unfortunate circumstances, yeah, that may be true sometimes, but it's what we're stuck with, unfortunately. So there's a reason for all of this complexity, but the reason might not be apparent, and that's why the features themselves might not be obvious. And the only way to learn them is to learn about the problem they solve and about how they work exactly. Because a lot of C++ is definitely not apparent, or at least not obvious. And yeah, in Davros in chat is saying you can write decent systems without using all the C++ features. That's definitely true. Like even using just C++
Exactly.
11, which I don't suggest we should do. We should be using up-to-date C++ because there are a lot of features in there that aren't complicated, such as standard span, which is basically just a string view but for arbitrary things. That's fairly straightforward. That's not really something complicated. And that's a C++ 20 feature. So it's not like we only want to use C++11, but even just using C++11 would be nicer than doing all of this macro generic nonsense and jury rigging member functions into a language that doesn't support, getters and setters into a language that doesn't even support member functions. Like, I'm not saying we need to write the most complicated code ever. I will agree that I might be prone to writing complicated code simply because I'm used to writing it that way. So if it's something is too complicated for you, I'm more than welcome to explain it. And if you say it doesn't make any sense at all, I'll try my hardest to not use and rewrite it into something that is more obvious, unless if for some ungodly reason it's really not possible at all, but such cases shouldn't really happen. So this is generally my point on this, I think. Any questions?
Are you okay?
How do you breathe?
No, I'm fine. It's just I've been the reason why I have so much to say about this is I just happened to think about this recently. I'm also writing a dissertation on complexity in programming languages, so all of this stuff is like in my mind constantly,
Nice.
That's
and I
fair.
like talking about it too. So
Yeah, I was just messing with you. So I see what you're saying, because when somebody comes along to like part 50 of the compiler series and then asks, "What's a compiler?" I like I understand where from your perspective that's kind of what's going on. Because it's like, well, we're not working on what's a compiler right now. We're past that. And you're saying that C++ as a language is like that, where it's like they started, they did all this, what they would classify as like the start or simple stuff, and then they've iterated since then to fix the simple stuff, but in
yeah,
doing so they've lost the ability to explain the simple stuff at all.
yeah, to some extent, sure. That's definitely true. If you're too, I very much like this quote that I found by someone. I read a blog post. This was a few weeks ago or months ago at this point about someone explaining the Hindley-Milner type inference algorithm, and they put it this way: they fully understand it, and they've tried to explain it in a way that makes sense for a beginner, or as he put it something like that. I've tried to explain this in a way that would have made sense to me back when I learned about it, but unfortunately, I no longer have access to that version of myself.
Yep.
And that's
Exactly.
kind
That
of how it
becomes
is
the
with C++. I fundamentally cannot see how the code on the bottom here that uses if const expert size of ... t, so the 3 lines of code, how that would be easier to understand at a glance than the code with the fold expression. Fundamentally, the one above is just easier for me to understand at this point because I'm just so incredibly used to what this means. And it's shorter, it's denser, but I know what the syntax means. I can tell what it does. And that's why for me, it's hard to see how the thing at the how you wouldn't want to write code like this instead of the one at the bottom. Because I prefer writing one line of code instead of 3 if it expresses the same thing and is as understandable, if not more, to me. So that's kind of my point on this, or my point of view at least.
Yeah, and I get it. I get it. But it's sort of a sunk cost fallacy if you think about it. It's like, well, I've done this for so long that this doesn't seem bad anymore. so I must keep doing it.
Generally, sunk cost fallacy is the way I understand it. It's more like I've already invested so much time into it, I might as well keep going. It's too late to stop now.
That's where
Is
you're
that
at.
the case? Is C++ just a giant sunk cost fallacy?
No.
I suppose there's some people that would argue that. I'm pretty sure a lot of the proponents of
Peter.
Rust argue that way. I could see how people would make this argument. The thing is, I like C++, so I want to keep going. I enjoy doing C++. And the thing is, there is a light at the end of the tunnel. Like, there are, again, features being proposed that will make much of the horrible stuff easier to do. Like things like a compile time loop that allows you to loop over parameter packs. That means we don't have to do these fold expressions anymore, even though I'd probably still use them because they're short and convenient if you know them. So is C++ just more of a sunk cost fallacy? While I don't know too many good alternatives that I like and that allow me to write expressive code in the way that C++ does. Because once you're familiar with C++, there's a lot of things you can write fairly concisely and very expressively with templates. Than you could in many, like I can write C++ code that does the same thing in fewer lines of code much more generically than any Go programmer could in Go probably, or something like that. But the thing is, it's a lot easier to learn Go than C++. If you've already learned it, you can do things like this fairly well. But the main problem I'd say in C++ is that it has a very steep learning curve, and there's a lot you need to learn to be able to use it well and not just make mistakes here and there. Such as, like, you need to know about iterate invalidation. If you don't know about that, you're going to cause so many bugs. But I'd say to some extent that still applies to C, because you can also have iterate invalidation in C. So any low-level language that doesn't have garbage collection and deals with fixed memory will run into iterate invalidation at some point, I would argue. So Rust fixes this problem with the borrow checker, but that makes a lot of other things more complicated. So you have to, that's just iterate invalidation is less of a C++ thing and more like a fundamental systems programming thing, I would argue at this point.
I agree.
If you have iterates over things and inserts and deletes, as soon as things can move, that just is a problem. I also will say I have a tendency to just ramble a bit and just digress. So if I keep talking for too long, feel free to just stop me, because otherwise I might not at some point. But yeah, the point I was originally going to make is that the sunken cost fallacy thing, I don't believe it is, but also I've been doing C++ for a long time, so I'm not sure I'd be able to tell you that it is. But I've never seen another language that lets me write code quite like C++ and quite as, for me, conveniently, as someone who knows C++ as C++. Because with a lot of other languages, I always see them making some sort of concessions, or things like, it's always for me that, oh, this really common thing that I like doing, such as using templates and abstracting over types and stuff like that, I can't do that in most languages. Like, ironically, the language that I found that I like the most in terms of the type system that's closest to C++ is TypeScript, and what you can do with TypeScript types at type check time. But I guess that's also saying something, because if you look at some of the complex TypeScript code, it's as of like complex TypeScript types.
It's bad.
It's as unreadable to someone who doesn't know it, and I'm not that familiar with TypeScript, as complicated template code. So I guess there is, I guess there is an overlap in that regard.
So, yeah, someone in chat just brought up a good point. The sunk
Yeah,
cost
also,
fallacy kind of implies that you're making a bad choice,
yeah,
but you're not. You're just making a choice based on the same reasoning as the sunk cost fallacy, but
yeah,
it's
I
not the
suppose.
fallacy.
And also in this case, especially because, again, to that thing with how Herb Sutter puts it very elegantly, I would say we'd break the world if we change something. There's so much code written in C++. We can't just change that, because
The
it would
world
take
breaks all the time.
spent years, if not decades, just rewriting stuff and not making progress at all.
And the end result, would that be better? What language would we rewrite it in? If we rewrote the entire world in Rust, would it be in a better place
Don't
then?
say
I'm
that.
not
They're going to
sure.
say yes. Don't say that.
The
Don't give them a
Rust
chance.
people, the
It
Rust
won't
people
be.
are also going to say yes probably to that. But yeah, I also wouldn't, to some extent, that's also why it's not just C++. How much code is there written in COBOL? And I recently, a few weeks ago, had someone proudly explain or describe their PL1 Java Angular stack to me.
Oh my god.
And that's like a big global what is not a company that makes I don't know how many billions of revenue. So it's like there's a lot of code out there written in some in very outdated systems, some in just also very old C++. And you can't just change that. And the thing is, you want people to use newer compilers, because the thing about compilers is it's not just that they introduce new features.
Yeah, there's security stuff
A
and
lot
bullshit.
of compiler bugs get fixed constantly. That's why you have to update your compiler. If you're compiling with an old compiler, you're compiling with a buggy compiler.
I have a solution.
We saw that today. My compile time options library breaks with your GCC 10. It works with my GCC 13. It's like we saw an example that today is, and miscompiles and stuff like this. All of them, you want people to update software. So you have to support the old features. Otherwise, people are going to be using C++ 11 forever with GCC, I don't know, 8 or something, whatever. Just a random number.
I still don't understand why those two things can't be separated. Why aren't they different languages?
Why aren't they different languages? Because you still want to be able to, okay, you want to support to be backwards compatible, so people don't have to really change the code.
They
but
don't
you also
have to
want
if it's a different language.
able to update
The alternative is rewriting everything, is what
because you have to, yeah, that's the problem. You have
to
to rewrite everything.
Only if you want it in the new language.
Well,
come again?
Yeah, but if you're writing a new language to replace the old language,
It's not to
which is what I assume.
It's not to replace, it's to upgrade. Replacing would be like fixing bugs. New features would be a new language. And then just make a new language and say C++ 2023, that's going to be a new language, and C++ 20, that's a new language. And then you can compile each language with each compiler still. There is somewhat backwards compatibility because the new compilers do compile the old code.
Yeah, in a sense it is, because that's in C++. You can still compile something as C++ 98 with GCC 13. Yes, that is true. But the thing is, you can't, at some point, you will run into problems if you try to combine backwards compatibility and updates, because of the thing you mentioned. At some point, you would very much like to deprecate and remove ancient features that are just bad, that have been superseded by newer things. There's newer things that you should use, and you shouldn't ever use the old thing anymore. But there's a lot of code out there using the old thing. So you can't both remove it and add new features at the same time. It's either you keep the old features and only introduce new features, but then you end up with a bunch of old features that are just there collecting dust that you
like
would
C++.
very much prefer not to be there. Or the alternative is you just add new features, remove the old thing, but now no one can just start using the new features because they'd first have to remove all the old ones. So you can't. It's not that simple. You will have to end up having to rewrite code, and that is not always a good thing. Because the thing about refactoring and even large rewrites is that it's not just a time sink. It consumes a lot of things. It consumes a lot of space and time and money also for a lot of people. It's a commercial thing. And also, only to arrive exactly where you started.
Hopefully arrive exactly where you started.
Hopefully.
There's a very good chance you introduce a slew of new bugs.
That's what I'm getting to. That 15-year-old code there, what do you think, how many bug fixes and problems in there have already been solved, and how many lines of code are there specifically to solve very hard to track down bugs? If you rewrite the entire thing, will you be aware of every last thing that people found out over these 15 years? People have probably left the company since then.
So you don't rewrite it. So if we're saying it's a very similar language, it's just a new one. Like, let's say range-based for loops come in instead of for loops, but they happen to break the original for loops for some reason. Don't worry about that. But imagine, like, okay, we replace for loops with range-based for loops. You're not going to introduce huge, gigantic bugs and ruin bug fixes and delete all your code and restart over just to fix for loops and make them better, or to change standard generate to use a collection instead of begin and end.
The thing about that is that as you say yourself, you maybe don't know C++ that well, because the thing is, if you change things like that, because of how everything is kind of connected and because of how name resolution and all of that works, if you just change something that seems fairly innocuous, you might cause consequences down the line that are very much not obvious immediately. So that's especially why they
I'd
are
rather have
often
that.
looking to change existing things,
I'd
because
rather
it
have the
could just
potential
create
for
bugs
problems.
somewhere that are hard to find, hard to track down, or might even cause you to have to rewrite code somewhere else entirely. It's like you can't just change something from out under people, even if it seems to be a simple feature, unless it is absolutely clear that changing that thing won't break existing code, or only will do something that, unless it's clear that it won't break existing code. There's exceptions to that. For instance, what they have done is that standard auto pointer is no longer a thing since C++ 17. Why? Because it was replaced by unique pointer, and standard auto pointer was flawed because it would do a move when you copy it. Because when it was introduced, it didn't have move constructors, so you can see how that's fundamentally a problem, I think.
Yes.
And why you should never be using auto pointer. So they deprecated it, they removed it, it's gone now. Because with auto pointer, you really can just replace it with unique pointer and it will just work. Any code that was previously relying on auto pointer working correctly that would be broken through unique pointer, that was probably a bug. So with that, it is a very clear thing. You have one feature that completely replaces another one. That makes sense, but it's often not that simple.
So basically, the world existing is ruining the further existence of the world.
Yes.
That's an elegant way of putting it.
So it's like me existing now kills the child that grew into me.
Yes.
That is very philosophical, but I think it goes in the right direction.
So every moment you are murdering your past self.
Yes.
Now it's getting too philosophical for me. But what I'm saying
You
is
started
that
this.
with
So we're
respect to
all
code,
serial killers.
Yeah, we're all perpetual serial. You are murdering right now.
Always have been.
Fartingle says baby boomers ruining the economy. It's not even that. It's that baby boomers ruined their old economy by the current one having existed.
So yeah, it's always this thing that
I don't know
we've
if that's
talked
true.
about this before, and I hope that today would be the last discussion on this matter. That the reason why you can't just do it is because there's too many things that depend on it, and you can't just change that, because you would love to be able to do that, but unfortunately, the world is the way it is, and because of it, we often can't do the things we'd like to do.
Yeah, that's very accurate. You're correct. I'm not going to disagree with you there. Insert San Andreas sounds.
Leading back to the original question of that we started talking about, I think at this point an hour or two ago, about rewriting intercept in C++. I'm all for it, obviously. I like writing C++. I can try not to write too complicated C++, or if you're actually interested in learning. But the thing about it is, if you're not interested in learning about C++, you're going to hate it. That's always the thing. If you're not interested in learning more about something, having to do advanced things in that field is never going to be fun to you. Like I've had to do even fairly elementary, like interfacing with image processing libraries, and after that, I never want to do image processing again in my life. I loathe image processing now because I don't want to learn more things about it because I
Text
can't
rendering.
stand it. So if that's the same for you for C++, then I suppose I get where you're coming from. If you don't want to learn about it at all, then of course seeing this code all the time is going to make you hate programming in it. But I'd also hope that you wouldn't be seeing this code all the time. It could be confined to one or two places in the code base where either I explain it with a comment or something, or I try to rewrite it and replace it with something that's easy to understand. So that's my argument about rewriting in C++, and the argument you were making about what was it? A new series. I would argue that it would make sense to start a new series, especially because of one reason, if not for anything else, is that people who start watching the old one, what they see is, I don't think any of the code you write at the beginning is even in the code base anymore.
No.
And
For
if
sure
they
not.
start learning about it, oh, this is how you write a compiler, but then a few episodes later, no, change everything. That's also not particularly nice. Now at least we have a, I wouldn't say stable, there's still not some refactoring that needs to be done, manifestly. But at least it's in a somewhat more stable place now than it was in the very early prototyping phase. So now you could
Yes.
actually, if we were to start a new series, you could actually look at this and say, okay, this is how you can write a compiler. It's not perfectly ideal, obviously, there's problems with it, but this is one approach to it that isn't just completely confused, maybe.
Yeah.
Because I will say for an imperative language, writing a Lisp-like parser is a bit weird.
That's your opinion.
It is my opinion, yeah.
I agree that it's weird in that it's not done normally, but I don't think it's weird in that it's a weird solution to the problem.
To me, it just seemed as an inconvenient solution because it just was so contrary to how I normally write passes. And the thing is that, from my point of view, this is just, I'm not going to go on about this for too long, don't worry. Just because I start talking doesn't mean we'll be here for 2 hours. But I have a way in which I write lexes and parsers that doesn't really change. Like if I write a lexer and parser, I don't write a new parser, I just write the old parser for a different language. To me, parsing and lexing is basically a solved problem. So changing anything about it, I don't really see a reason for that.
So now,
it's not something that I see much room for experimentation in, but that's maybe just my point of view.
so
But
now,
anyway,
I agree that's just your point of view. Can you see how when you bring up C++, it kind of seems like that same thing? Like we already have solutions to these problems and you're just making more complicated ones for no reason, just for a little bit of performance?
Yeah. I could see how it would seem that way. It's just that if you know the underlying problems, then you can see how these are solutions to actual problems that are out there. Like every new feature that exists is introduced for a reason, and typically that reason is to either fix an old feature or address some shortcoming.
That's
And that's true
fair.
for fault expression, etc., etc.
But yeah, people in chat are arguing about Rust. It's fine. So I think fundamentally we see each other's viewpoint. And I want to move forward and make progress, right?
Mm-hmm.
But I don't want to like ruin what, that's not the right word, not ruin. I don't want to like infect the like understandable basis with just like C++ness. Like I don't want my days to just be filled with like learning a new C++ feature. I still want it to be like focused on, oh, I'm working on this IR thing. Not like I'm working on this C++.
I'd love to see you work on like exactly the generic thing or something, namespacing things, the obvious, easy things that C++ does objectively better. But yeah, I don't think this kind of project benefits from any fanciness.
Okay, so I have a solution too.
Yeah.
One, C++ could always be allowed if we just never use it. Like it can always be a leaf. Does that make sense?
I'm not sure.
So for example, we're not going to like write the IR struct in C++.
That I would okay, that would kind of defeat the point of it though. Because all of the only
Defeat
thing
your point.
the thing is that with this, if you look at this, all the accesses, it's manifestly obvious that this wants to be just a class or struct with member functions. Because if you turn all of these things into member functions, you could at least remove the IR underscore prefix. So that would already make it more readable.
I disagree. I think that's the same readability. It is a different way of doing it and probably simpler and puts less on the screen, but I don't think it's more readable because everyone understands what IR underscore means. What was that?
It's also easy to write in all of this horribleness.
with generic and because every time if I want to make a function that is just called the same but accepts two, if a function overload, I have to do this horrible generic macro thing and then manually create the overloads anyway. It's just, it sucks.
I don't know. It's difficult.
You haven't implemented it, I have just now, and it sucks. It sucked. And using it also sucks. It's not the worst. It's better than marking uses manually, but that's a really low bar.
Yeah, and then it's just like, it's also going to suck if we use C++. Like you said, it's not a perfect solution. And the ways in which it sucks, C doesn't suck that way right now. And I don't know if I want that trade-off.
I personally don't think it's going to be that big of a problem. Like, I don't see, again, what Local mentioned, I don't think there's that many things you'd add here that I think the most complicated thing structurally, and even that wouldn't be that complicated, is maybe some very simple iterators that just do bounds checking. But I wouldn't argue that that's particularly complicated in terms of templates. There
Just
isn't
data
that
structures.
many things to. Sorry.
Even just data structures. It's
Well,
not even to do with like complex code or templates. It's like it can't even represent the data we need in a sensible way. We have to deal with endless, ununderstandable variant errors.
Neither can see. Well, we're not gonna. I would use inheritance, not variance.
Well, then with inheritance, it's some stupid, ununderstandable thing because that's the kaleidoscope tutorial. It's literally everyone gets stuck on the inheritance part.
That's object oriented. I'm talking about just using inheritance. I'm not talking about virtual functions or any of that nonsense. We're just gonna have a function with a switch on the kind of the AST node or stuff like that. And the inheritance is just for literally just for concatenating the location and type and whatever else that is at the beginning onto the start of every like struct. I'm not planning on using any class features other than private, public, and inheritance. That's like the extent of OOP-ness that we're going to add. Because this is, if you're calling access OOP, well, then we're already doing OOP with all of this stuff in here.
Yeah.
So it's not going to get more OOP-ish.
I still prefer the C tagged union to using inheritance to solve that problem.
So then it's like, but then
unions again, they're hard to use, and there's also the size problem. Like, and if you get huge nodes, and just it's a waste of. Okay, that's not memory is less of an issue these days, but it's still not ideal.
But then
and
you brought up we can't.
Memory that also makes iteration slower.
We can't switch on the type. The kind.
The kind would still be. I would still make because the kind would still be an enum or something. I would still make that an enum somewhere.
So you're saying we'll still have a tagged union, just C++ stuff also?
It's not. Yeah, I will just have the tag basically.
That sounds awful.
It sounds like it's defeating the purpose of inheritance.
Sorry?
It sounds like it's defeating the purpose of inheritance to also tag what you've inherited.
Well, you have to somehow store what the type is somewhere, right? You can't just cast it. You have to somehow know what type it is.
Right.
So you have to store that somewhere. So you have two choices for that. One,
right, so RTTI isn't powerful enough for that?
RTTI is also an option, but it's not ideal. RTTI is slow.
C++ is not ideal. I think I'm on Lenz's side here.
RTTI and dynamic cast, if you want to go that way. Have a virtual destructor. We probably do need a virtual destructor, honestly. That is a good point. Typically,
that's the way this is shaping out is exactly why I don't want to touch C++. Oh, it's as easy as doing this one thing. Oh, but if we do that one thing, then we have to do these 7 other things in sequence to make that one thing worth doing. It's just like I don't want to buy into anything that much.
Presenting an AST in a nice to use manner is still sort of an unsolved problem. It is. There is no best way of doing it that I can think of. There's the inheritance approach and the variant approach, and both have their own problems.
But I prefer the variant approach, and the variant approach in C++ is like broken, but in C it's like just understandable, like, oh, it's a number and data.
Mm-hmm.
That's where I'm at. The same thing. You can also
but we won't. That's what you're saying. You're saying we're not going to do that. So that's moot.
Yeah, because the reason is unions are, it's easy to misuse them. That's the main reason why you don't do that in
It's
C++.
easy to misuse every single feature of C and C++.
Yeah.
That is not a very good argument if we're talking about increasing the amount of C++.
We can use naked unions to just put a bunch of, because the data is going to be internal anyway. So you could just use a union, I suppose. That is possible. There are some things that directly use unions, like optional internally and expected internally. I'm pretty sure using standard options and special expected to use unions internally. So we could. The main thing about a union is you don't ever want to expose a union because that's easy to misuse. But we can use a union internally if you prefer that over standard variant. If we and considering we have a we need a tag anyway, but yeah, it's just that with variants, it's not just a problem with the standard variant being annoying to use, but it's that problem I showed earlier with like you have two variables all of a sudden. You need one way of accessing the shared data and one for accessing the what is it, the element data. Because the thing is, if we're doing this with the IR, for instance, we can't just expose all the fields because we're going to need we're going to need accesses anyway. Because exposing everything would like kind of defeat the entire purpose of that, would just cause the use marking problem again. So the only access to the outside would be via get set. For I'm not going to call them getters and setters because I don't like using the word get or set in the function name. I'm just going to do the thing that we're doing now, one overload to set the value, one overload to get the value. That's the most sensible thing. That's the pattern I like using for stuff like that if I have to use it. Or sometimes we can return things directly, but just make them const. Like C++ has const functions, that helps with that too, to like, kind of reduce the strain on that. But anyway, what was I going to say? Internally, the variant would only be the thing about it's really hard to say because the thing about if we have an inheritance hierarchy, we at least can sort of constrain it, because otherwise with the variant-based approach, you run into the problem where you have one struct and then 300 accessors that include things like get call arguments or get immediate value or immediate value. So you have the accessors for every last instruction on the instruction type. But if with the inheritance-based hierarchy, you'd only be able to get the arguments for a call instruction if you cast it to a call instruction. So that would be less just like mass of functions to deal with.
Yeah, the only time I'd ever want to call get call arguments anyway would be in a context where I already know that that's the case anyway.
Yeah.
Like, I mean, yes, that proves both of our points, but like, I don't mind having 100 free functions if I know I'm only ever going to get call args on switch case kind equals call arg, whatever.
Yeah, so again, my main worry with variants is that it might just, again, microparler works differently in that regard because this is for the AST, which has way less invariance than the IR. So I do permit direct access to, I do have direct access to just fields in my compiler because for the AST, it's not as bad as for the IR. So
yeah, I'm starting the encapsulation at the IR.
A bunch of the thing is also, if we're just using a bunch of accesses, it's less important how it's implemented internally because you're never going to be using the variant yourself manually anyway. So with inheritance, you'd get you might be able to obtain like a pointer to whatever, to just a call instruction, whereas with the variant approach, you'd only ever have one instruction type. But that's pretty much the only difference in terms of the API. Anything else would be the same internally. I mean, internally, you'd have to deal with the variant or with a bunch of downcasting, and we could use either a separate tag or dynamic cast for that if you want to use RTTI. The thing is that the problem with dynamic cast is that it's often it can be a bit slow sometimes, so it's often easier to just use a tag, and you can't switch on a dynamic cast or type info easily. So I don't like using dynamic cast generally and this like polymorphic stuff because it's just not ideal in many ways, and performance being just one of them.
I hear you. We've got a question in chat. Can anyone in the chat fill me in the context here or give a link? What is this a compiler for? On the screen now, you'll see intercept. This is rule 110. It's basically a low-level language that I just made up and I'm making for fun. And right now, it's we just merged a wonderful, huge PR from Serade that refactored a bunch of stuff. And as usual, about once every 3 seconds, I am bothered once again about the terrible choice of implementation language for the compiler and how it could be C++ instead and make things simpler. And for about 2 hours, 2.5 now, we've been talking about if that's a good idea or not.
Because also the thing about this is, if not in C++, what other language would we rewrite it in that is not tedious to deal with? I know you like Lisp, but I wouldn't want to write the compiler in Common Lisp.
Dear God, no.
So
You see,
yeah, what else? And don't say Rust.
Right. I agree with you there that, like, if we were going to rewrite it, the only option that ever would even start to make sense would be C++. Or even if we were going to start to allow a new language. It would
This
be
is
C++.
this is the position that Laia wants to slot right into. You've got C code, but you don't like writing all this weird stuff. Just add it to the build right there, but it's not ready yet. Sorry.
The problem. And the thing also is that the other reason for using C++ is that there are a lot of good C++ libraries that we can interface with. Like, it would make interfacing with Clang and stuff easier if we want to go that way. Which I'm going to write a library for that eventually anyway in C++, and it would make interfacing with that easier. And also even stuff like libformat. That's just, it makes interfacing with existing code easier if you're using C++. Because there's a lot of code written in C++.
Yep, and it also allows for interop with C, so obviously it's more there.
Yeah.
Yeah, I agree with you that the only sensible option that would even be considered is C++, and that shows a lot about C++. It's at least similar to C.
Yes, and what was I going to say? Yeah, about the things like the IR layout, I'll have to look into a good... I mean, do you have a particularly strong precedence for either inheritance or precedence or dislike, precedence for or dislike of either inheritance or the variant-based approach?
I just like both, but let me explain. I just like inheritance, not the like simple copy and paste inheritance where it's like, oh, just insert the members of a struct here. That shouldn't even be called inheritance. There should just be a way to do that in the syntax of a struct declaration where you say, take the members of this struct and put them in this one. So I don't even know if that would be technically inheritance. It is, that's what it's called, but that's fine. That doesn't bother me.
Super composition.
But the fact that with that solution, we're still going to need the tagged union. It's just now there's extra types on top of it. It's kind of like, why?
It's not exactly a tag. So there's two things we can do. You're right in that we can get away without the tag, because the way this works is, in order to be able to use a class hierarchy in a sensible manner, you need to be able to downcast. And well, you can just cast it. Well, you need to know what type it is somehow. So you need to store that somewhere. Now, in C++, by default, there's no way of telling what type something is just by looking at, well, the type, the data. So you need some way of representing that. That's different for polymorphic types. And a type is polymorphic if it has at least one virtual function. Very often that can just be a virtual destructor, which makes sense because you need a virtual destructor if you want to be able to delete a derived object through a pointer to the base class, because it has to call the destructor of the derived object. Does that make sense?
I lost you a little bit, not gonna lie.
Okay, so if you want to, very often if you have the base class and derived classes, you have pointers whose static type is that of the base class, but that actually point to a derived class, right?
Oh, yeah.
Yeah. And now if you delete the base class pointer, then you need to call its destructor. But if it's actually some derived object, you need to call that derived object's destructor.
I'm getting
Otherwise,
it
you'll
now.
just leak memory. Does that make sense?
Yeah, because it's
Yeah. So you have to know what destructor to call, and the most straightforward way of doing this is to make the destructor virtual. Because that way it's a virtual function, it will just be resolved, dispatched dynamically at runtime. Does that make sense?
That makes sense, yeah.
Okay. As soon as you have at least one virtual function, whether that's a member function, a destructor, whatever, every object has to know what function it has to call. So for that, it has a so-called vtable pointer that points to a table of functions, and that's different for every class. So for instance, if you have a derived object of class foo, it will point to the vtable of foo. If you have a derived object of class bar, it will point to the vtable of bar. And then if you call member function a virtual member function 1, it will look up in the vtable the slot for for member function 1, and it will call that, whichever one it ends up being. So as soon as you have at least one virtual function, you get this vtable, and the vtable is separate for each type, and therefore, based on the vtable, you can figure out what type it actually is at runtime. And there's an operator that does that. It's called dynamic cast. That's what dynamic cast does. It uses the virtual vtable to figure out what this thing is. And if it is the type you're trying to cast it to, then it's going to give you a pointer to that. Otherwise, it's going to return null. So that way, you're using dynamic cast, as long as you have at least one virtual function, you can use that to figure out what the type is, and then you don't need the extra tag. So that is an option. The only consideration is dynamic cast can be a bit slow and it requires runtime type information.
Which means it can't be used in a kernel, for example.
Yes, it adds an overhead in terms of binary size too, because now every type that is in the class hierarchy needs that type information.
Interesting.
That is one way of doing it. And the thing is, because if we ever want to be able to delete things through pointers to the base class, and pointers to the base class would be like instruction, and the subclass would be call instruction, whatever. We would be passing around instructions constantly, and when we don't need an instruction anymore, we delete that instruction. So we probably need a virtual destructor anyway for that to just work. And with that, we'd be able to use dynamic cast. So we could use dynamic cast, and then we wouldn't need the type, if that's what you want to do. The only problem is you can't, for instance, do a switch case on the type then easily. You can only do if dynamic cast, else if dynamic cast, and so on.
Oh dear.
Yeah, that sounds terrible. Don't do that.
That's because you don't have good pattern matching in C++. If you include an extra tag, I'd probably still give it the virtual destructor just in case, just to make sure that doesn't go wrong somewhere. But we could use the tag, and then we could at least do a switch case on that. We just have to set the tag properly for each derived class, but that's easy. You just do that in the constructor, and that's done automatically for you. You don't have to worry about that. So if we were to do inheritance, that's the way I do it. Virtual destructor just in case something goes wrong, or just in case we forget about that. And then a simple tag that tells you what it is. And in fact, this is not some outlandish thing. This is what LVM also does. They don't use C++'s type information because it's too slow. They have their own thing. That is basically this. Their own quote-unquote version of dynamic cast and their own tag that tells them what an object is, because you need some kind of tag.
I see. So it's not that. What you're saying is that for data structures, it does become more complicated to represent the same thing, but you also gain more stuff.
As C++ has no good way of representing either I like to call them static or a dynamic variant would be something like a class hierarchy, a single base class, and then a bunch of derived classes. And you always want to downcast to the derived classes. Like that would be like the same thing as a variant, but instead of the variant storing the data, it stores pointers to the thing. Conceptually, that's the same thing as an inheritance hierarchy with one level.
Yep.
So, and the main pain point is that there is no pattern matching in C++. That would make either one easy to use, because you could just write something that looks like a switch case and it just works. And there are proposals for that, but it's not yet.
Well, I think that decides it. It's a good way. I have to go soon, so it's a good way to end the stream. We're going to be using Rust going forward with pattern matching.
That's probably still better than this. I'll take anything about writing more of this generic stuff at this point. In C.
That's fair. And I see where you're coming from. I think I know the solution. I think we just have to write a good enough language that we can then just use that, and it's kind of a compromise between all of these things. And then we self-host.
One problem that I have with that solution is that it will take a long time to get there.
Yeah.
And that until we get there, we'll have to deal with this nonsense, and I don't like dealing with this nonsense.
But is it a fun journey, even if the destination
sucks?
At
this point. 4,000 lines of refactoring is not fun.
Hopefully you shouldn't have to do that too much more often.
Yeah, well, I'm not sure about that, because fundamentally architecturally flawed.
Yeah.
And there is no good way of doing it.
Ronnie Holmes says we could go with OCaml. What about that? Pattern matching.
Functional language.
OCaml. I've been tempted to learn OCaml in the past. I just never committed to it. And if I were to do it, it would be for a compiler.
OCaml, at least doing simple stuff was fun in it, like writing a basic program, but it is non-intuitive sometimes.
It was either that or Haskell.
Use F# or something, I don't know. I still know some F# from like a few, I don't know how long ago.
Yeah, F# has the benefit of the entire .NET framework and CLR, which is interesting to play with.
Language, I would do F# if it's got to be any functional language.
I think the hardest part about transitioning to a Rust code base would be the HRT.
The what?
Yep.
Oh, I
What?
see. It took me a second. Okay.
You gotta crack a few eggs to make an omelet, man.
Yes, I see how it is.
Write it purely in x86 assembly. Don't even use C. See, now we have real solutions coming through.
There we go.
How did we never think of this?
So yeah, I would recommend rewriting it in C++, or at least update. It doesn't have to be a full rewrite straight away. We can just, what we'll have to do is there are slightly different semantics in C and C++. So every use of like calloc and malloc needs a cast, because a void pointer is not just convertible to any pointer. So that's one annoying thing.
Oh, see, that'll never happen though. That's probably a W conversion error, isn't it? So we're gonna have 2,000 of those.
Hard error. That is a hard error. Converting a void.
Damn, never mind.
Is a hard error. That's not.
Which is ridiculous.
No, it's not. It's very sensible, actually, I would argue. So, but yeah, that needs fixing. That's the main thing, I'd say. Other than that, we'd probably be able to use most code. We could just, and obviously the first thing I'd do is just use standard vector everywhere instead of vector thing.
I'm at least gonna sleep on it.
And as for I really want to look more into good solutions to writing AST hierarchies in C++, because the thing is, you can't look at existing compilers for this. GCC has its tree system where everything is a macro, which it's had for probably 30 years. And the thing about Clang is, in Clang, you don't complain about stuff, you just do it. You just implement it in C++. You just write the class hierarchy, you just write the code, and it's just, there's so much code, you just write all the code, and that's it.
If there's already 100 million lines, what's 10,000 more?
Yeah, we just write the code. It's the way it is. You just keep writing the code. You don't complain about it. You don't think about it too hard. You just write the code the LVM way. And that's decent enough, I suppose. It works for them pretty well. So, and it's not, perhaps not a good way, but it's the way they're doing it. So.
Hey, I see your
so
point.
Lens is going to sleep on this decision. While you're asleep, Lens, I'm going to finish Laia, completely polish it up, no bugs, and then you'll have to wake up and have a new decision.
That sounds good. That's the right timeline.
See, I've already taken my melatonin for the night, though, so I'm probably not going to make it.
Ah,
fuck.
so it'll never happen.
Never happened. Nope, lie is dead. You killed it.
Rip.
So interestingly, the same thing about the IR rewrite also applies to the AST, but ironically, in this compiler, the AST is simpler than the IR.
I'm just that good.
So if we just solve it with the IR, then we'll do the same thing for the AST
Yeah.
and the MIR. And the thing about the machine AI is that's where templates come in. We could template over, like we could have just one dominator reconstruction algorithm that works for both, just one basic block type that works for both, like, because there's a lot of duplication there already. If we implement
true.
something for the instruction, we could just reuse it for the. We could probably just reuse a bunch of stuff for the machine IR.
That's true. All right, I'm running really late. I am going to end this thing.
All right.
Thank you everybody so much for watching. It's been amazing. Be sure to check out all of the links in all of the buttons that you can click right now. You should click those buttons. They're made for you. I have a compiler, which we've talked about a lot today. Got a lot of work done, merged something. It's amazing. It's coming forward. We're going to have a lot of stuff soon. It's a whole ass language. And I've got some decisions to make, as we've discussed. I also have other projects like an entire OS and a text editor. So if you're interested in like stuff like that and low level stuff, just you should stick around. Also, I have a YouTube, youtube.com/@LENSR. If you go there, there's all my previous streams, every single one. You can go watch it in full detail. Not that I recommend you should. Just realized AutoMod held a message. Ho camel. Anyway, be sure to click those links. Go subscribe to the YouTube, click the follow button here, and stick around. I'll be here at least next Sunday. Hopefully you're here too, and then hopefully I can do it more often than that. But that's the minimum. All right. Fartinkle says cheers. Simlurking. Good night. Good night, everybody. Thank you for coming out. You've been awesome. Does anybody here that has been part of the stream want to shout anything out or plug anything? The floor is yours.
Not particularly.
Other than the stream, I don't do all that often that I want to do more often.
Okay, go watch Local Laie. He's making his whole own compiler and language. It's really awesome. So if you see him
I'll try to
streaming, go
stream
check that
more
out.
movies.
And Fartingle says yes. Oh, not me. Okay. Wow. Shout out to Fartingle also for the hilarious name. I'll see you. I'll see everybody, in another life at another time after I've killed my old child self and come back as a C++ 26 or something. Bye.